So I think in the paucity of time, we will start. We are at Delhi Standard Time now, so I think we can start. Good morning, everyone. Welcome to this 155th edition of the Zak World of Façades conference series. My name is Ahmed. I'm part of the organizing team here at Zak. I'll take a couple of minutes. I'll just introduce the event for those who are attending for the first time, though it's our 6th or 7th time here in Delhi. But I'll quickly just go through with what we've been doing with the event. So we've been organizing this event since 2012. We finished around 154 editions in 41 countries around the globe. This is edition 155, and it's an event which spans from New Zealand up until Canada. So the way facades are designed, engineered, installed in different parts of the world are very unique, and every event is curated to talk about how they are looked at in that respective region. Even over here with Delhi, we have our first presenter who's talking about stone. Stone's used a lot in architecture here, not so much so in other parts of India. So this is very unique, this topic to Delhi. All the topics are curated to that respective city, to that respective region. And we've had a great journey so far. In some places it's about cost, some places it's about carbon, and then low carbon. So every event is unique for us, so we need to curate custom content for every event. So this is a calendar event for 24. Again, we had 29 events in 19 countries around the globe this year. Close to 35 events next year in 2025. I'd like to start off by thanking our event partners, starting with our presenting partner, Shuko. So Shuko is a world leader in aluminum door, window, curtain wall systems. So they are our presenting partner for this event. They've been a strong pillar of support of this conference series globally. System windows, system facades are picking up now on projects, and given that eventually in the future sustainability is going to be the norm and the trend, even in a country like India, these multinational companies with their vast database and knowledge of how to tackle sustainability issues will be able to assist designers and engineers on projects. Our powered by partner is Aluplex. Aluplex is one of the leading facade contractors based in out of Hyderabad and Mumbai. Doing projects all across India. They are our powered by partners. And I'll start by introducing our associate partners, Aludecor, one of the leading aluminium composite panel manufacturers. Aluform System is from Germany. They've formed an Indian subsidiary now. They've got louvers, they've got aluminium cladding and various other solutions. Cotswold Architectural Products is into hardware for doors, windows, and facades. Dow, one of the global leaders in silicon and sealing and bonding solutions. Eminent International is a new facade testing laboratory based out of Hyderabad. Euromax is partnering with DEC Diamond Engineering Corporation. They've got coil coating solutions in aluminium and other materials for cladding and building envelopes. Fundamax, again, world leaders in high pressure laminate solutions. Jotun, one of the leaders in powder coating solutions. Kainat Glass, one of the leading value-added glass processors out of the New Delhi area. Kinlong, a glass hardware and fitting solution provider. Panasonic KMW, they've got a ceramic cladding solution, which is again a self-cleanable and a unique new solution for the Indian market. AC Controls have actuators for windows and facades, where they help you automate for smoke and natural air. Viva, again, one of the leading aluminium composite panel manufacturers. Blick System, they've got a stone cladding system. They are partnering here with their partner, Diamond Engineering Corporation, and they are our branding partner for this event. Our next event is in a couple of weeks from now in Kuala Lumpur. We've got the big one in India, which is our biggest in the series, which is Mumbai. And of course, the pillar and platform of these events have actually been founded by the exhibitions which we organize on glass processing, doors, windows, and aluminium extrusion. So that's in Delhi, Pragati Maidan, 5 to 7 December. That's it from me. I'd like to call upon today's event host and convener, Ms. Suparna Bhalla from Abaxial Architects. She's going to be taking you through until the end of the day. And we've got some unique speakers talking on different topics. In case you miss any of them, all the presentations are recorded. Those we have permission to share with you. We'll send a YouTube link, and you can get access to it a week from now after the event. So thank you so much, and over to Ms. Suparna Bhalla. Thank you.
Hi, good morning. And for all those who have made this long journey and come from different parts of the country, welcome to Delhi, as they say. And thank you, Ahad, for taking us through the motions of the day. And thank you, Zak, for having me here. It's my first stint as convener and host, so please bear with me if I stumble and fall. Architects are known to make errors, even though we will never admit it. Okay. So first of all, the whole conference on facades, I think, personally, I think it's a very, very essential topic, not just for the way we look at them as commercial buildings or skylines as cities, but facades have always been essential in making of an image. Now, image is vital, as Kevin Lynch has written books on it, on image of a city. But more than that, an image is vital to how we read and understand our cities, our environments. Today, climate change, big word, AI, next big word, is forcing us to rethink how we do things. I hope it's forcing us to rethink. We are sometimes, in taking one step forward, we forget that it may be prudent to take 2 steps back. And here, actually, at this conference, with you meeting so many different types of people who are engaged in different aspects of facade. I mean, outside over here, just before this, there was a nice little coffee break where everybody was discussing everything from pigeon terrorism, which plagues our facades, to, ask architects, we hate pigeons and people trees, but to anything like, we were discussing the Bray Soleil by Corbusier and how it all began. This very building that you're sitting in is a testament to retrofit. It's a fancy, amazing building in the center of Delhi, in the heart. And for most of you who are not aware, this was built in the time of peak modernism. And yet it stands. So retrofit is another very big challenge. We are coming to a point where most of our cities are aging and not aging well. So how is it that we can become the wellness solution? I think that's another critical point that we would like you to think of. So to begin with, first of all, some rules for the day, because, I'm the convener and you have to obey me. So starting with the fact that we will not be asking our speakers any questions during the session. Please keep them for coffee breaks and networking during lunch. I'm being kind to all the architects. Yeah, they don't like being asked questions. And of course, after that, we'd like you to also have good conversations with them, which are, more free and less exposed. With this, I'd like to invite, the architect, Mr. Goonmeet Singh, to come on stage. And he's actually going to make a fabulous presentation on all the work that he's been doing. Please, a big hand of applause for him. He's a founding partner of Design Forum International, and I'm giving him the podium.
Thank you very much. Am I audible at the back out there?
Yes.
Yeah. So she just spoke about sometimes we take 1 step forward and 2 steps backward. My talk is all about taking 20 steps backward into time to really find our roots. And it's more of a personal journey for me and how I used it to inform my work, and was very fortunate to do some public buildings in Delhi. After practicing for almost 20 years, the first 10 years was spent making homes. The next 10 years was spent doing real estate architecture. And I felt really unfulfilled. And that's when I started looking for public projects with the government, and then my journey began. So it's really the romance with stone that this city has had. And it's gone over the last 1,000 years, from blue quartzite to red quartzite, then Agra stone, white stone, and various other materials happened in Delhi. And I'll walk you through that journey over the next 7-8 minutes, so I'm also left with some time forward. The Suraj Kund, this was built, I think, sometime in the 800 to 10 AD, 10th century AD, uses entirely the blue quartzite stone because you worked with the materials that were available to you. You know, unlike today where we have vendors bringing us material from across the globe, which poses some other problems, builders of that day had to rely on local materials and local construction technologies. And there were no vendors to come and teach you, so you can imagine how challenging it must have been for the builders of those days. And then you can see lime mortar being used in the construction of the fort walls as early as 11th century. And you see in the Chauhan dynasty, they have also started using red stone. And the lime mortar was used with the moru, which is morum. And that's why you see that reddish hue to the mortar. And then came the Mamluks. You know, Muhammad Ghori's general Qutubuddin Aibak defeated Prithviraj Chauhan. And then Mehroli was already existing, but then he chose to put his imprint in it with the Qutub Minar. And because this was an Islamic way of construction, they wanted to do carvings and inscriptions in stone. And that's why they brought in sandstone, because you could not put inscriptions into Delhi stone or into quartzite stone. So it's very interesting how the aspiration of the people and the culture influenced their material choices. And this is another first in that stone was actually clad. So Agra stone must have been, you know, they must have used hand saws. They didn't have the kind of machines that we have today, where we can choose 18 mm, 20 mm, 40 mm stones. So it's really fascinating when you dig deeper how the architects of those days must have struggled with details and sourcing. And Agra stone can still be sourced from local areas. The Jamuna also helped possibly in transporting the material, whereas white marble must have had to be carted on elephants from a long distance, which is why you see very little of white and some gray, but predominantly red. Then the next dynasty was more militant and militarily engaged, and therefore you don't see such great architecture except for one Alai Darwaza. But what you do see is far thicker fortifications, and the stone is a mix of blue and red. Then the Tughlaqs, you can actually see now the stone walls being a lot more thicker and inclined, and they clearly didn't have structural engineers to do calculations, so they had to rely on empirical knowledge. And again, the mortar has helped in that this has withstood almost 900 years of weathering. Then I'm skipping the Sayyads because there's not much architecturally different stuff that we saw there. But the Lodi period saw something very, very unique in that it saw the coming together of Hindu elements into Islamic architecture. This is also the period when the Bhakti and the Sufi movements were happening. So you can see a connection between the social political narrative being more inclusive and how it affected the architecture of those days. And so if you see at the top of this dome, you actually see a lotus there, and you'll see many instances of octagonal columns and corbelling, which typically you see in temple architecture, finding a place in the Lodi period, as also the ceramic tiles, the handmade ceramic tiles. And these are things which later inspired modern architects like Stein to kind of imbibe the elements into their buildings, which is why taking a walk back into history really helps. Then for a brief period, after Babur brought the Mughal dynasty to India, Sher Shah ruled and he made Delhi the capital. And that's when this fort was constructed. And you can see nothing very distinctive in terms of the architectural style. However, you do see the commencement of this pointy arch and the need for creating fancy doorways emerging. Then when Sher Shah ruled Delhi, Humayun, who was actually the natural successor, he went to Iran and he was there for a good 10, 15 years. And there he interacted a lot with Persian artists and the designers of those days. So when he came back and became a ruler, he brought in Persian architects, you know, like we have people here like Ricardo who come and teach us. In those days, the Persian architects came and you could clearly see a leap forward in terms of proportions, the whole concept of the high plinth with rhythmic arches, and even the central dome, which is onion-shaped, is slightly raised. And to hide the drum, you see the doorway is actually higher because you don't want to show the drum. So something like proportion, composition, rhythm, these are elements which were completely missing in the architecture before this. And those you begin to see in Mughal architecture here. And of course, you don't see rubble masonry anymore. All of it is clad. You know, just like modern day interiors, you don't see blank walls. You have so many materials that vendors want every architect to use. And therefore, all the walls have something or the other. Something like that happened in Humayun's time. Another very fascinating thing that emerged, and this is in Shah Jahan's time within the Red Fort, is red stone being used for the common man's area. So the Diwane Aam, which is the court where the king actually met the people, is made in Agra stone, which was cheaper and more readily available. And the Diwane Khas, which is where he met the nobility, is actually designed in white marble because white marble was that much scarce, difficult to saw because it had to be done manually and then polished. Also, the king's emperor's masjid is actually made in white stone. This was made by Aurangzeb. Whereas the Jama Masjid, I don't think we have an image of that. All of us know about Jama Masjid. Jama Masjid is made in red stone, but the dome, which is really an ode to the Lord, is in white marble. So there was a clear distinction that got established that red stone is for the ordinary people, and then white is to be used when you use it for nobility. Then there's a complete shift, and you see in the British period, the advent of steel and MS really in architecture. And this is 1860s as a fallout of the mutiny which happened in 1857. The Meerut garrison could not protect the officers in Delhi, and therefore the British Army decided to quickly put together a bridge on the Yamuna. And 20 years after this is when the Eiffel Tower happened in Paris. So you can actually see how 170 years ago, the use of steel in public buildings became very, very important, and as a way of making construction fast. All the stories that are told to us today are actually 170 years old. And that is when Delhi saw the first bridge, the Loha Pul, built over the Yamuna. And then you see stucco plaster coming to Delhi for the first time with this St. James Church. And this is even before Delhi became the capital city of India. And this stands today. If you go from Kashmiri Gate, you can actually see this church, and the government has just restored it. So you see the advent of stucco plaster. And then the move away from stone, and you see in St. Stephen's College as well as Modern School, Barakhamba Road, first use of exposed brickwork in the facades of public buildings in Delhi. Subsequently, even the National Stadium was made before this, the National Stadium was made in exposed brick, and that set the sort of tone that exposed brick then became the material that architects began to use. And then in post-independent India, we found with Convener using stone grit as a material. So you can see there is that yearning to be connected in some way to the soil of the place, and how grit was used as a material. And it was actually not a sheet that was clad. You had to actually do, I don't know what's the word for it now, but you actually plastered the grit and then you washed it, and that's how you got that grit wash finish. And when Korea made this building next to the Connaught Place, I wonder what would have been the reasons that he chose Agra stone and then one column of white. So to my mind, he must have been informed by history that most of it would be red, because this area is closest to the old part of Delhi, the old city, and the white column, because white has to be used more scarcely, and the singular column was clad in white. So you can actually see how a lot of contemporary architecture and architects have actually referred to the past in Delhi, and the past has informed their material choices. And then subsequently, the British Council Library, Triveni Kala Sangam, one of my favorite buildings, which is 70 years old and still vibrant today, one of the most used sort of buildings for art and culture in the city, used Delhi stone in a very, very different manner, in a more sort of modern idiom. And you also saw how Stein used pentagon and hexagons to actually create courses using 3 layers of stone. I never could relate much to Raj Rival's work, which I thought the stone was simply plastered onto a very modern building. So there was a conflict between the material and the language. But yes, I think he is one architect who possibly used Dholpur and Agra stone to the maximum, and made it more and more sort of the material of choice for public buildings in Delhi. He also worked a lot on cladding technologies, which is something that really influenced my work. Now, coming to my experiments with stone, I am a purist. So you'll find a lot of modern architecture uses large sheets of stone. To me, the eye is used to seeing stone in a more natural, horizontal manner, and the kind of sizes that you can actually pick and use in masonry. So the meter of stone that I've used in my architecture is actually the sizes of stone that were used when you built with stone rather than just cladded with stone. And even the patterns and the courses follow a certain rhythm. The first building where I used stone is the Delhi High Court. And this sits right on the India Gate hexagon. It's kind of one building away over there. You see the National Gallery of Modern Art, and that is the new High Court building that I made. And it is in between, it's next to a very modern building which was designed by architect Benjamin. And on one side is the Jaipur House, which is done in the colonial idiom, and on the other side is the Sher Shah Suri Gate. And what I really did was I blended the composition of the pediment and the column, which I inherited from Benjamin's building, and extended it into mine. But I took the materiality from the National Gallery of Modern Art, as also the meter of the stone. So when you actually see them together, you naturally feel that it belongs. Also, the building recedes at the top because I didn't want the new to kind of in any way overpower the existing. And so I've hidden it behind a colonnade of octagonal columns and very, very deep cantilevers, which creates a nice shaded effect. So in effect, it is a glass building, and you have floor-to-ceiling glass. So when you are inside, you actually see the outdoors, but none of the glass is really exposed to the incident sun. Even the foreground, where all the services normally ruin the landscape, we kind of put it under a water feature and plants. The bottom of the cantilevers, and the cantilevers are pergolas, otherwise they become very, very hot. You need to dissipate that heat, are also clad with stone. So we had to figure out a stainless steel framework to actually hold the stone. We reinforced the stone with granite so it won't chip on the edges. And me and my stonemason, both of us hung from one of the stone slabs, and I have that photograph, to actually prove it to the people that it won't fall. And that was the test that I told the one mason who was doing it that we will do for every stone. So there was one mason who did it. It took 6 months, but it was important that we did not allow that little piece to be delegated to just anybody within the team. So making friends with the stonemason was really very, very critical. In this building, I have also used red stone on the tips of the cantilever, something that later I realized wasn't right, and I've changed it in the buildings I did subsequently. I also have hidden all the aluminum with stone. So thanks to all the modern chemicals that are now available, the aluminum sections are all cladded with dry stone. I think I have just 3 more minutes, so I'll go to the next building. Yeah, that's a shot that I love in terms of the silhouette of the building. You know, modern architecture tends to be very, very flat, and I think the silhouette is read by the eye. Of course, this photograph brings it out more beautifully. Even in the landscape, we referred to Sher Shah's gate, and we brought in some inscriptions, which you only see when you go close, because I didn't want to do a khichdi architecture. This is the picture during construction and how the architect and the team have to keep the jazba alive. And also, the proportions have to be imagined post-cladding. So, you know, your structural engineer says, I need a 600-meter beam, and you say, no, I want it to be just 200 mm. And so all the beams are inverted and inclined. You don't see them. And all the pergolas actually are like drainage beds so that they don't break subsequently. These are just some pictures of them. Then I got very, very fortunate, and I got the opportunity to design Vanijya Bhavan, which is the Ministry of Commerce, the first project on the Central Vista, and it's the first building to be made on the India Gate really after 80 years. And here I began with octagonal columns, and I began with single columns, which kind of hid the glass behind. But later, I realized that Lutyens had actually designed a column for Delhi, which he called the Delhi Order column. So we took that column because we wanted to be very, very pure. He didn't use it much, really. But here we've got 128 of these columns. Each column is 4 feet in diameter. And it looks smaller. It also helps in making the building look shorter. So we actually used VR to get the proportions right. And each of those columns is made, each ring is made of 7 pieces of stone. And behind is actually a glass building, but you don't realize it. So from within you get excellent views of the surroundings, but from outside you don't. And that is the capital, which again was designed in those days with some tweaks that we did, and each of those bells that you see, which are inspired from temple architecture, are actually that large, solid stone with a stainless steel member driven right through it. This building also has a very interesting silhouette, which kind of borrows from the Rajasthani Chhatri architecture. Those are the columns used by Lutyens. Also, this is a symbol which Lutyens borrowed from temple architecture. And then these are just some of my doodles during that. And I wanted to put this on the underside of the soffit because the cantilevers are very deep and the soffits are really visible. And then we detailed this aspect on how we can actually do it to a size which will be read from the road because I wanted it to be visible. And that's what actually was implemented. I don't know if you can see it over there. So a lot of detailing went into crafting every piece. This was a lump sum contract. I had to do all of it before the tender. We got like 100 days to do the tender drawings. And yet we did lots of mock-ups. This is how each of those stone pieces were made. The column had to be just the right size before cladding so that post-cladding it doesn't become too fat. So all of those challenges were kind of met here. That's the capital. You can see it's almost as higher than a human figure at the back. And all of this is kind of clad on a giant column at the top. That's how the building kind of came up. I, at one time, felt that my columns were too sickly when the stone came on. It was a little more assured. And those are all the things that, and then you see the aluminum and you say, oh, I don't want to see the aluminum. And luckily, we have chemicals now that helped us clad all of those. Now, I can go on, but I think I've run out of time. So thank you very much.
Thank you, Mr. Chauhan. That was absolutely fascinating walk through the annals of history of Delhi. For those of you who don't know, there are 14 living cities in Delhi over time. I mean, over like thousands of years. And in fact, there's one right in the neighborhood here. The Humayun's tomb, which Sir referred to, is right around the corner for those of you who want to get a look at some point. So it's worth seeing. So with that, I'd like to introduce our next guest, and that is Mr. Ashwanii Khanna, who's the Chief Custom Officer of Fundamax India.
Yeah, good morning, everyone. Thank you, Mr. Chauhan. It was a lovely presentation, actually. Before I get into thick of things, I would like to talk to each one of you. How it is possible, I would request everyone to please open a menti.com on your mobile phones. Menti, M-E-N-T-I, from your browser, any mobile, any browser, menti.com. And once you log into menti.com, you have a code which is 85720078. It's mentioned on the top of the screen. I actually learned from Gaur Gopal Das that stage is a very lonely place. So I thought I should interact with everyone. I should not feel lonely. And the first question is, how is your mood today? But I can see only 11 people logged in, 12, 15, 19. I would request more and more participation, please. So good is becoming bigger, which means everyone is feeling good, mood is good. Thank you for that. I can see happy, excited, calm, relax. Wow, lovely words and lovely feelings. Yeah, let's move on. So my next question is, how has been the weather in Delhi this week? Those who are from Delhi or those who heard about Delhi. Bamboozled. Awesome, because of the rain. Flooded. It has been rainy, yes, it has been rainy. There were challenges in the morning, roads were flooded. But rain has its own effect. It brings a lot of happiness. That's also true. Pleasant. Bad for facade works. Someone said this. Yes, I agree. That's true. Okay. I'm moving on to the next question. Thanks for this lovely reply. Let's get into the facade topic. How important the facade is while designing the building? We often see facade as a face of a building, but how important it is? Very important. Like skin for the body. Someone said very critical legacy of a building. Yes, as we saw it in Mr. Chauhan's presentation as well. The face of a building, facade of a building has become the identity of a building actually. And very important is becoming bigger. So we cannot ignore facade. When we are designing the buildings, we cannot ignore facade. That's true. What is your expectation from facade material while making the unique designs? Thank God someone said sustainable because this is my topic today. Thank you for that. Durable, sustainable and durable is becoming bigger. Green material, affordable, long-lasting, flexible, lighter, less maintenance, last a lifetime. Yes, I do agree. When Taj Mahal was built, it was not built to be redone, right? It was built for ages. It was built for generations to come. So buildings should be done which are long-lasting, sustainable. Generations can use those buildings. What role facade material plays in ensuring the fire safety of the building? Because fire accidents are growing. We have witnessed many fire accidents in recent past. It should act as a shield. It's a very important point. Critical. Someone is saying fire retardant. It should prevent vertical fire. Okay, and your impression about sustainable facade, what it should be? Yeah, we have to look at ROI. That's very true. Someone has mentioned that. Energy efficiency, budgeted, climate friendly, long lasting, low carbon, climate friendly. Durable and long lasting is something which is coming again and again, and this is what my personal view is as well. When buildings are done, they are not supposed to be redone. They're not built to be redone. Thank you for this lovely responses. Now I don't feel alone here. May I request Ganesh to please play Fundamax video, corporate video.
Design is where aesthetics meets functionality, where beauty touches the surface. It is art making itself useful, touching the heart all the while. Individuality is what we want to offer. Uniqueness is what you make it. We see ourselves as co-designers of your design wishes. That's how we become partners in your success. Our origin is the book in which we turn the pages to read the future. Since we know where we come from, we also know where we want to go. Our products know it too. They want to find their way to you. Perfection is more than a claim to our skills. It is our way of showing respect for natural raw materials. Our way of bringing production and processing to perfection. Change has been our constant for 130 years, and we're doing it again. We change. We think ahead. We are open for new things, for inspiration, for innovation, and collaboration. Open for you, and open for you to create.
Ganesh, can I have my presentation, please? Yeah. So we are going to talk about sustainable facades, rear ventilated facades, and unique applications. Now, those who don't know what Fundamax is, we are into compact laminates. This is the product, actually. And when we talk about laminates, normally we think of laminates for interior application. Almost 2 decades back when we launched this product, there was a surprise in the industry, how can laminates be used for exterior application? But since then, we have done more than 20,000 projects. And in Delhi alone, we have done more than 4,000 projects. I mean, in North alone. So we are Austrian company. We have long tradition. We are 130-year-old company. All the products are coming from Austria. Manufacturing is happening in Austria. Nature is giving a valuable raw material to us, but the raw materials are sourced very responsibly. I'll explain that. Like when we say sustainable product, so we have to very selectively choose the raw material. Like all this product is made up of 65% paper, craft paper and decor paper. This paper is coming from regional forestry, like FSC certified and PEFC certified. So which means we are not responsible for deforestation. In fact, we are responsible for afforestation. And our more than 80% of energy needs are catered by biomass. This is a very important topic to take care of carbon topic, CO2 reduction. So on the baseline of 2005, we have done 30% of CO2 reduction. Any waste which is generated is going back into the production, or we are producing the heat energy which helps in district heating, because Europe is a cold country, especially Austria. So we are providing heat energy to more than 147,000 households. CO2 emissions, I spoke on the baseline of 2005, we have done the reduction of 30%, and we have taken a very challenging target to further reduce it by 50%. It's 100% wood and paper. As I explained, to make it more sustainable, we have acquired a company in Norway which is into paper manufacturing. It's known as Reinheim, to ensure that our supplies are controlled. It's fully controlled. Now this is how the panel looks like. The core is basically the craft paper, 65%, and it is 100% recyclable paper, and it's made up of 65% as paper. On top as well as the bottom is the decorative paper. So we have more than 132 decors which are suitable for the exterior. The core is basically treated with some kind of resins which makes the core flame retardant. It's a class B material. We also have a class A material which I'll talk about in the later part of the presentation. So in nutshell, we are talking about sustainable raw materials, sustainable manufacturing, sustainability certificate. We have a sustainability certificate for 33 years, which means the panel which was installed in a project, tested after 33 years, was passing the norms as per the European standards. We are talking about weather resistant, UV resistance, and long lasting. It is long lasting and low maintenance. When we talk about 33 years of sustainability certificate, so it is a long lasting material. Now, coming to how the installation is being done, it's basically a dry cladding. It's lightweight. We make it like a rear ventilated facade system, which is also a type of rain screen facade system, which not only protects your building from, it protects your building from any external condition like rain, heat. So suppose this is the wall, this is the cladding. There is a gap between the wall and the cladding. So this gap allow the hot air to rise up. There's continuous air circulation which is happening behind the cavity. thereby giving energy efficiency, thermal insulation. It also protects from rain. As per DIN standard, less than 1% of water will touch the external wall when the installation is done as the principle of rear ventilated facade system. And then it also acts as a sound insulation because it is not a closed box in front of a building. With the air circulation, the sound insulation is also taken care. So these are some of the unique projects which we have done. This project is in Lucknow actually, and it is done from one of the partner in Delhi. It is actually a double. On the left side we see which was the intent, which was the original intent of the project. And the whole idea was to reduce the glare, optimize the shading coefficient. And right side is the actual images of the project. It's like a double skin facade system, thereby giving a visual comfort to the occupants of the building. This project is in Raichur. It's an example of, again, a horizontal lower, wherein the angle of lower has been decided based on the sun path analysis. The same concept, the whole idea is to give, optimize the shading coefficient and give visual comfort and thermal comfort to the occupants. Now, when we have such kind of facades, this will, reduce the loads on HVAC as well. Now, on the extreme right side, you see a semicircular kind of building which is facing the tropical sun throughout the day. It's in Kerala, and it's a vertical lower, the same concept. These are some of the unique applications we have done, and this is also one screen which we can do, and these are movable screens. Sorry for this. These are movable screens. This is again a project in Kerala. This is a corridor project. It's a school project. So there was a lot of noise when children are moving out in the corridor. This perforation is helping to reduce the noise and as well as also ensuring the ventilation in the corridor. This is Luar project in Ahmedabad. It's Ahmedabad University. The same thing is also used in IIM Bangalore. Some international objects. This is one soffit. It's like parametric design. This is again a school, college project in Bangalore. This is in Mumbai. Pergolas can also be done. Yeah. We have done a lot of residences in Delhi. Some unique designs like this. This is individual print. Printing on panel is possible. In this facade, every panel is individually printed and fixed together to make this as a complete facade. Yeah, so we see every project as a canvas. We see facade as unique because it is the face of the building, and we invite all of you to, create a unique facade with the offerings from us. So we have more than 32,000 decors available with us, and we have a booth outside. We are open to, talk to you. In interest of time, I should stop now. Sorry. Thank you.
Thank you, Mr. Khanna. That was an interesting take on material. I mean, before this, we had Mr. Chauhan who took us through the politics of material. Now you're taking us through the potential of new materials. So thank you both for that. With that, I'd like to invite my good friend, Suresh, on stage. He represents Avante Facades Consulting and has done numerous work all over India and the world. So let's see what he has to say. Please raise your hands in applause. Thank you.
Good morning. Am I audible? Okay. So the biggest challenge we have, one of the challenges we have right now, is that, to build tactility in terms of, it's very difficult to manage the scale and texture to a building. So what we have is, architects, clients, and manufacturers and suppliers, they generally face, they need to create something which is other than just a glass building. So what we have is they create texture. They create the scalability by having, more to do with texture and richness, which basically helps in terms of, building up the scalability of the building. And so I have a video which talks about different examples of what we are talking of. This is a short video, and then I'll start with the presentation. So to differentiate, monolithic and monochromatic facades, it is to implement surfaces where what you basically want to see is a difference in surfaces, and it should look monolithic. So this is basically a platen cast bronze. There's a project in Midtown Manhattan, where it's a American folk art museum. And if you see, it's an open joint where you don't have silicon. The reason is because in a very polluted environment, what happens is it starts staining, and you won't be able to maintain it. So generally, you have a rain screen system for all the premium projects which you look at. And this is what you look at when people come in. They see the building. It looks wow because of the texture. All panels are unique. And there's no panels are similar because it's cast. So when you talk of modern materials, you talk of basically a sheet form, which is generally, it doesn't have a texture to it. So what we're talking of is texture. And now if you look at this building, it is like left-hand side is, the left-hand side is basically platen cast bronze, and the right-hand side is platen cast concrete. So you don't see the difference, and people actually look at it and feel wow. And that too, it's in the middle of Manhattan. So if you look, the memorable point was basically when the barricades were broken off. When they came off, the pedestrians went and touched the bronze to see what the texture is, what the material is. So that was the most interesting part as an architect. You feel the difference and why people are going there. Why don't they look at all the buildings around there? So that is a basic, the difference in terms of using surfaces. This is again a project in Manhattan, but this is cotton steel, which everybody knows it oxidizes, and it's got corrosion marks on the surface. But the client embraced the idea, saying that, okay, I want to do that, and I want this to be a monolithic surface with a different texture. So this is basically a 30 mm thick cotton steel, which is actually installed with a ventilation system. So this is how it looks, and it's one plate basically. It was installed in an industrial building. Now again, if you talk of rain screen, if you look at all the joints, this is a modern building, but there's actually a Haussmann architecture which actually embraced in Paris. There's a project in Paris where if you look at this was basically the architect's inspiration was about wood architecture, wooden patterns. And this is all actually a wooden pattern, which is, right now it is cast bronze. It's white bronze. So when people walk past this place, actually if you have a red shoes, a lady walking in a red shoes, you see the glinting effect. You see that whole image passing by through this surface of the bronze. And similarly, if you have a blue shirt, whatever, you have that glinting effect on the reflection on the surface. And also because of the horseman architecture, it basically they have controlled the points. Like you can't develop anything above the cornice. So you have only the ground floor where you can do the retail. Yeah. So this is how it is. And if you see the juxtaposition of the stainless steel and the bronze. So architects have been very careful in developing that retail space and making sure it doesn't look different from what the other buildings are. Now this massing is basically a material, but the massing, I'm talking only of the texture. So what has happened is that if you look 10 feet away from the facade, you basically see a texture which is a micro texture, which makes the surface looks more appealing, and it actually builds up the image of the brand. Now, as a pattern, it's basically what you want to see is not only the daytime, you want to see the building in the night time. So you need to also have patterns and texture to the building. So this building it's a flagship store for Burberry, but if you look at it, this is the nighttime image. It looks different from what the daytime is. And these patterns are basically crafted in a very different way. These panels are basically folded, and the engineering makes a big difference. So the challenge is where you are, which city you are. You need to be careful what we are proposing for that. So if you look at this, these are basically unitized panels which are basically installed on this. Now what Gurneet talked about sandstone, after that I came to know that this is basically a public space, and that's the reason they've used sandstone in Patiala. I didn't know that before. So this is a jali, there's a stone jali, which basically is contemporary to all Indian architecture. So it's used in a very good way in terms of it gives the building, the university, a richness. And it filters into the building, into the campus. Like there's a jali for basically glare control and sunshade, but used in a different way. There's a building in Shanghai where what we have done, what has happened is it's like it's a retail space, but it was a retrofit. It was an office building before, so they basically clad it in such a way that in the nighttime it should look like a fabric because Uniqlo. And daytime they wanted it to look very subtle. So if you look at the daytime images, it's very subtle, and they've used perforated panels and with a ceramic composite coating, which actually rinses away the dirt. So you don't find it dirty, and also the holes, the perforations are more than 10 mm, so you don't have the bridging of it, your capillary bridging of the panels. So you don't find it dirty. It basically cleans away the dirt. And also, as an architect, it's more important that we consider where you want to keep the substructure, where the attachment is. So it's very important that you work on that. So basically, in this building, what they've done is they've taken the supports in such a way that you don't read it from out. It looks more clean. This one?
Yeah, this one is for the next slide.
Okay, sorry. Okay, sorry. Yeah. So it's more to do with, architecture, in terms of texture and tonality. So stone is again a warm material which everybody wants to use. So this is a campus in Mumbai where it's basically, it's the warmth which comes with texture. It's with the surface and texture. So we've used stone here in terms of it's a sandstone. And it's got that texture in terms of, louvers and flat panels. Now, you don't have to spend money all the time. So here, it's a oculus, which basically is having, they call it China tile, but it's a fragmented tile. It's an Indian ceramic tile, which has been with a bed mortar. And it looks very clean and neat, and it rinses away the dirt again. So it's a campus. This is UC Berkeley, where the concept was basically getting into textures and patterns. So here it's all cast bronze, which has been in a two patterns, which is a rectilinear and cracked ice pattern, which has been installed in a rain screen. Again, you have got. So if you look at this, it's basically a pattern which is made, which makes the building interesting, and there's a competition in the whole university where which building looks good. So this is a natural daylight coming, and students love to sit here because of the light coming into the campus. This is Apple Store in Dubai, where the inner surfaces, the soffit and the vertical walls are basically polished GFRC, but it's got aggregates. It's got glass aggregates, which actually, when you touch the building, it gives a different feeling. So it's not like it's again a texture and a feel. People love to touch that and feel the, the reflection of the GFRC. This is how it is. And also the architect chose to use 3 mm grooves, which is normally very difficult for an interior space. But then it's handcrafted in the railing. So it's basically, it's a mold. And the exterior is always 12 to 13 mm, but this is 3 mm. So it shows that when it's a branding form, basically the people come in, they feel it's precise. Everything is 3 mm. So Apple is it's a precise company. They know what they're doing, This is stone, limestone used in a different form with reveals in metal, which gives it a different feel. And it's also got it's got a lantern effect, which basically lights up in the night. So it's a lantern which basically lights up in the night, and it's basically giving you the feel that, you have it's a subtle surface, and it's a pattern which you form. So I would like to end this slide with basically saying that, our experience, with our experience, that we feel it's a legacy to the urban facades, and we feel that we need to be careful and we need to be conscious on what we are doing, and it needs to interest the people. Needs to be, the building actually should fascinate. They should fascinate the people instead of the people trying to fascinate the building. So it's not just do something decorative. It's more to do with some subtle thing. So I would say that it is more important that we take the ownership of taking care of making the urban environment more warmer, more welcoming, friendlier, and visually interesting. Thank you.
Thank you, Suresh. That was fabulous. And in fact, very, very telling, because we often think of materials without understanding the tactility that they bring. Not just tactility in touch, it's not about those bronze panels which you're compelled to touch, but I think it's also visual tactility. Because today we are not just using cladding, not that cladding is a new method, but we are not using cladding only to create an image. We are also using it to create form, which is very different than how we've used it over, the last centuries. With that, I'd like to invite Mr. Rohan Keswani here. He's with Aluplex, and he has a very interesting take on glazed facades for high-end residential buildings. Correct? Please, a round of applause, ladies and gentlemen.
Right, am I audible? Excellent. Today I'm talking about glazed facades for high-end residential buildings. But before I do that, I just want to give you a quick brief about who we are, what we are. I'm Rohan, I'm from Aluplex, and we worked on a large number of buildings, more than 400 completed projects over the past 40 years. One of the pioneers in facades and glazing in India and curtain walling in India. Before I go into my topic, I'll just quickly give you a brief about what we've done here in the region, since we are in NCR and Delhi. We worked on the DLF Cyber Park in Gurgaon. What we've done the last 3-4 years is what I just want to show you. This is a high-end, platinum-rated building, which is just as you cross over from Delhi into Gurgaon, is when you see this as you cross the toll. And very interesting project in the sense that nothing too complicated, simple block structure. But it's something interesting is that initially the concept was to have these cladding elements, these revealed cladding elements between the two unitized panels, and the idea was to end the unitized panel there and to end the unitized panel at either location, and then you have this cladding element in the middle. We worked out the details to ensure that we have a continuous gutter, so you don't actually break the unitized panel. So we had the gutter in the stack joint to be continuous, so even through the glazed panel and through the reveal cladding panel, we had a continuous glazed, we just developed new extrusions and got that done so that we have a continuous facade there. Besides that, we've also done the DLF Camellias, which is in Gurgaon, which is one of the most high-end projects, which is in the NCR. We used a system over there, a lift and slide system, and this is done there. Other than that, a very interesting project is the Yashobhoomi Convention Center, which is in the India International Convention Center. It's called. It's a project that I worked with one of my close colleagues over here, Mr. Srinivas Hoysal as well, was involved in that project, and a few other people in this room were also involved in this project. Very interesting facade. It is has very, very large glass panels installed 16 meters above the ground, supported by a tensegrity tension rod system. Very complex. There's no sort of vertical supports there, no horizontal supports through the glazing. And we had to get a way to put that up there, 650 kilograms for each piece of glass. We helped organize ourselves to build these particular glass suckers, which were able to have a 800 kilo capacity, and they could swivel left and right either way, and they could turn and they could tilt frontwards and backwards. But then we got stuck. We weren't quite able to install it in these locations, given we have to maneuver our way through the tension rods, maneuver our way through the steel, get 16 meters up above there. And eventually, as you can see, there's some GRC that had to be installed before we installed the glass, because after that, they weren't able to do so. Eventually, we made this kind of swivel bracket that was allowing us to basically gave us the left and right movement, fixed it to a Hydra crane, and were able, so that using that we could then adjust it even left and right. Besides rotating, besides swiveling besides having the motorized glass sucker, we also had this particular swiveling mechanism which allowed us to, put the 650 kilogram glass into place. Very complex, but finally we achieved it, and that was the end result, and that was a interesting project in the region. Now coming back to what I'm actually here to speak about, sorry for rushing through that, but I don't want to be ding-dinged and belled by Shraddha on my right over here. So talking about high-rise buildings, high-end residential buildings, that's something which is more so in India compared to commercial buildings, or compared to high-rise commercial buildings. We have high-rise residential buildings, and in the residential buildings, there's been an evolution through time. We need to be able to maintain them. We need to have ventilation. We need to be able to, clean them. And based on that, the design has kind of evolved. The development rules have changed in cities like Mumbai. Earlier, you had balconies. Today, now, you have to pay for even the balconies. Earlier, that was called chori, as they called it earlier, where they would sort of just won't quite be part of the FSI. But now that doesn't quite exist. So I'll start off with a project which is very close to somebody who's sitting right in the front row over here, the keynote speaker of the day, Mr. Ricardo Mateu from UHA, who was the architect of this building. High-end residential development, ultra luxury, India's most luxurious project, as it was called. And what we had over here was these balustrades, as you can see. These balustrades were basically, these sort of unitized panel balustrades in the front, and we had these sort of window elements behind. The columns were cladded with, also with cladding, and, very interesting, we sort of developed the design for it. There were some cappings in the front earlier. We then removed the cappings because that wasn't quite desired. And eventually we were able to install these panels on this building. Sort of had to curve the glass, had to curve the aluminum transims. The handrail profile especially was 200 millimeters deep, and bending that to that particular radius, the 200 millimeter profile, was challenging. Also, the radius had to match with the radius of the glass. If it didn't match, you would have problems where the glass would touch the transims at the end, but there would be a gap in the middle, or the glass would touch the aluminum in the middle, and they would have a gap in the end. At the end of the transit, if the curvatures didn't quite, weren't to the right tolerances. So getting it to those tolerances, using laminated glass, bending it to that level was challenging, but we were able to achieve it. That's the sort of end result of the project. You have these curved balustrade panels, you have these straight, long balustrade panels, we have cladded balustrade panels, and on the inside, then we have these fixed and sort of sliding operable panels that we used. And the entire building, as you can see, you don't see any sort of concrete or any sort of plaster or any sort of paint that you would need to come back to. Everything is either cladded with aluminum and glass, so sort of easy to maintain in the long run for a high-rise development like this. The other project I talk about is Lodha Park. Somebody in the second row behind him is Mr. Srinivas Hoysal, again, who I worked with very closely on this project while he was at Lodha. This is in Mumbai as well. The tallest tower in Mumbai, or I think in India, in terms of that has been constructed and delivered in terms of number of floors. 81 floors is what the number of floors is. As you can see, it's basically made up of windows to a certain extent, but also has these pockets of glazing. And we developed a detail there, which was very interesting, where we had the operable window was, normally you have a plant-on operable window where you have an outer frame which is installed onto your mullion and transom, and you see and you can notice from the inside when you're looking outside what's the operable window and what is not the operable window. But over here we had like a seamless transition where we developed a detail where you could have the shutter frame on the glass over here, which was able to basically, this shutter frame is, it's aligned with your mullion and it's not a plant-on that's sticking out. And so then when you see the particular detail and you see the installed product on the left over here, that's the operable detail. You have a little slight line over here that you can see. But besides that, you don't quite see in terms of what is the plant-on, you don't see what the window is. In this project, we also used a particular passive ventilator system where, at certain windows, when you're at the 70th floor and the 80th floor, it's hard to sort of open these side-hung windows when it's very windy and rainy. We had this passive ventilator that was developed, and we installed them within the particular unitized facade. The idea was that we had this system where you had a transom above, a transom below, and within that, we installed this passive ventilator. We had it tested in a laboratory to ensure that it was, it would work in terms of there would be no water leakage. We had it also, we could open and close it, so you can choose when you want the outside ventilation in and when you don't want it. And eventually, that's the passive ventilator we had underneath the operable. Can't quite see it, and got a very complicated detail eventually, but we were able to deliver it and hand over that product. Besides that, the other project is the Trump Tower in Calcutta. It's a 40-story residential development in Calcutta. As you can see, they wanted the concept was to have an all glazed building in all ends. But then, as in buildings like Lodha Park, where, there were no balconies, again over here you have no balconies. The difference was that, people were not able to open their windows really beyond 300 millimeters, because that's the restrictor that you normally have on your side-hung window. So we spoke about using sliding windows incorporated into this particular unitized curtain wall. Now, incorporating a sliding window in this unitized curtain wall would obviously, you'd have a frame around the aluminum window. That wasn't quite desirable. So, we developed, we also had some dead walls on the building, which were earlier meant to be concrete, but then the Trump group, when they came in and bought into the project, they wanted it to be all glass. So basically, we had some rain screen elements where you have the RS on the dead walls. We have everything else being unitized, and we had the sliding window system, which is over here, but we didn't quite want it to be looking like sort of a typical sliding detail. So we developed a structurally glazed sliding system and had it tested. So over here, as you can see, the interlock over here, the fixed panel is over here, that's structurally glazed here. Even the sliding panel is structurally glazed instead of being within a frame. Similarly, for the sectional detail, we had a step glass, which is then covering your aluminum shutter frame. So it looks completely from the outside. As you can see, the image looks like you can't quite notice that there's any aluminum externally. It looks like an all glass building, even though it's incorporating a sliding system. That's the building that was under construction. It's now reached 30th floor, another 10 quite floors go. That's the system we use there. The other project to talk about in Pune, this is also for the Tribeca group. It incorporates, again, sliding doors with the railing incorporated into the unitized panel. Over here, they have the railing on the outside. And the railing is basically, and they have the sliding shutters within the unitized panel. We incorporated a bit of a clever detail over here where we had, the sliding shutters at the stack joint behind the head profile. We had the shutters installed over here. And now in order to, we had a particular connection device over here, which can go from one panel, a splice, even for the track. So the sliding shutter could slide from one panel over onto the next panel without having to have a very, very large unitized panel. This is under execution and it's on the verge of completion, being handed over soon, shortly. This is the railing detail which comes in front of it. So you have your glass railing which is over here, and this is your sliding shutter with your interlock fixed to your mullion, and that slides beyond that over there. This is the project, Voyage to the Stars, and it's under, a few towers done, a couple of more towers to go. The last project is Rustomjee Crown. There are 3 towers over here. 2 towers have been completed now, and the 3rd tower is what we've just started executing. This is, also in Mumbai, and it has it's a 260-meter development. And the concept in this project was again to have very, very large openings, to sort of have these 3-track, 6-shutter sliding doors. But at the same time, you want to have a continuous glazed facade. They didn't quite want it to be within openings, and then you have to measure these openings, and the measurements aren't quite matching with what you need, and you're dependent on the civil contractor to hand over you openings, and then you have to caulk it up with silicone, which then looks ugly, and then there is seepages through that. So we developed a system where we had a continuous glazed facade, where the entire facade, the entire sliding door system with its railing was all cantilevered from the building slab like a typical curtain wall. And what we had over here is we had 2 stack joints in a typical floor. So normally you would have a stack joint which is coming above, you'd have a stack joint which is probably at this level above your floor. So we made it, and we had brackets on the underside of the beam and on top of the beam. So then you had your panels, your spandrel panels which came in with 1 stack joint. And then above that particular spandrel panel, you again had these vision unitized panels which were spanning from floor to floor. And you also had your tracks installed within that. Then you had your sliding shutters which fell into that. And afterwards your railing came in and you install your railing, and that's the way it looked. So the detail looked a bit like this. You can see over here we have a fixed glass which is over here. And this is your top of the slab bracket. And then you have your stack joint over here, and within the sill profile, we designed it such that your stack joint was, your track was over here, and your sliding shutters would follow above that. You don't need any sort of movement over here because these brackets, these were resting over here. The dead load was resting on this particular system, and the brackets on top is where you had a slot where you had vertical movement allowable over there. So yeah, I'm just going to quickly show you a small little video on this particular project about how we executed it and the challenges involved, and to give you a better understanding of that.
Aluplex has been at the forefront of the facade and fenestration industry over the last 40 plus years, and we've completed over 400 plus projects to date. And I take this opportunity to thank the building fraternity for all your support over the years. With the advent of urbanization and the scarcity of land, we at Aluplex are happy to share with all of you that we've completed over 10 towers, 250 meter high. In fact, at this moment, we are working the facade project of the Rustomjee Crown.
So Rustomjee Crown is one of the most premium projects in Mumbai. It's a super high-rise project. The most unique feature of this project is the facade. In the West, the high-rise facade systems have greater reliance on artificial ventilation and limited natural ventilation. It was Mr. Irani's idea to give a continuous facade which is openable to give that feeling of openness like a deck or an open terrace. This is something that has not been done in India.
This was made possible by innovation in design, engineering, and construction by incorporating large sliding doors without compromising on the high performance of the unitized glazing facade. This has never been done before and posed a unique challenge. This bespoke design facade system was tested in a performance testing laboratory rigorously.
The largest panel on site was 6.5 meters wide and 3 meters in height, and that was a logistical challenge. Aluplex organized the production, the dispatch, the unloading, the vertical movement, and subsequent installation to work all in sync to ensure there was a continuous flow of throughput. In case a bottleneck was identified, we ensured they were eliminated by adding additional resources of manpower and machinery to them. We had more than 350 labor working at various locations for the project.
I'm glad that we were able to finish this facade in a record-breaking time with the teamwork between the Rustomjee team and the Aluplex team. We worked together to ensure that we were able to deliver a superlative product.
So I think that's just about on time. But yeah, that's my presentation. Thank you very much, ladies and gentlemen.
Thank you, Rohan, and thank you, Aluplex. They've been around for decades, showing us the way in facades. And with that presentation, it comes with the understanding that it's not what we do, it's also how we do it. That's very, very vital. Now, before we break for coffee and chai, which is becoming extremely essential in the room that I'm seeing, as you can see, everybody's faces are finally smiling and lighting up. But बहुत facade हो गया, अब कुछ chai हो जाए. But before that, we are going to welcome Reji, Mr. Reji Bhami. He's right here. There he is. And it's before we break, and after this, we'll take a quick break and get you all back in, all refreshed. Thanks.
Thank you, ma'am. Am I audible? Yeah. My name is Reji, Director of Eminent International Testing Center. And Rohan, it was a nice presentation, but you didn't take my name, my company name also. You have tested a couple of projects with Eminent International Testing Center. Yeah. Rohan has completed more than 6 testing with Eminent International Testing, including the Kolkata Trump Tower, which he has already mentioned. Okay. Basically, Eminent International Testing Center is one of the largest facade testing center located in Hyderabad. Our head office is in Dubai, and we operate on-site testing in Dubai. I will just play a short video about Eminent. So this is what Eminent and the speakers who spoke about the materials and the aluminum facade and all. They were all talking about facade design, facade and material. Eminent is supporting the industry, supporting those facade designers, the installers by testing their product and make sure the products are structurally adequate, make sure the products are completely airtight or watertight. So Eminent is an NABL accredited laboratory. We have accredited for various standards like ASTM, AMA standards, BSCN, CWCT standards. More than 100 test standards we are accredited by NABL. The reason why testing is essential, if the building is not completely airtight, especially we can understand that we know that the cold air is inside the building, and when there is a summer and the hot air is transferring to the building, you'll have a lot of condensation issues that can lead to your expensive flooring can damaged, and your furniture, your luxurious furniture can damage, and your walls, dry walls and all, it can be affected and it can damage a lot. So by testing this and make sure, that the air leakage is within the limit, and structural failure where there is a heavy wind, or the structurally it is not not tested properly and not designed properly, then what can happen? The system can fall off. The aluminum system can make vibrations. Those kind of things we can identify, and we can make sure at the time of testing whether it is structurally adequate, whether it is airtight, whether it is watertight, and seismic testing. And we simulate. We simulate the seismic effect in our laboratory and make sure even if there is a slight earthquake or building movement is there, it can the system, the aluminum system can withstand that load, that seismic effect, and still the system can move on for the future. So the benefits of testing to identify the design and the fabrication is in a correct position, and make sure there is no air leakage and there is no water leakage, or structural strength is okay, building movement wise it is fine. And if there is any changes is required, like the air leakage, normally in India we say that it's allowable for 1.8 cubic meter or 2 cubic meter per hour per meter square. At 300 Pascal, 600 Pascal, depend on the location. But some cases like, the system is not designed properly, then what will happen? The air can pass through the building, the water can enter to the building. So by conducting the testing, we can make sure this can be prevented. If you need to add extra gasket, if you need to change the gasket, if you need to put some sealant application, or you have to strengthen the mullion or transom, that can be done at the time of testing. So how the testing is to be conducted? So when the design is completed and the fabrication is done, and before it is going to be installed on site, we can prepare our contract, and then what we can do, we can set up our test rig. As you can see on the first photograph, we can set up our test rig, and we will install the beam, the horizontal beam, which will simulating like a building slab, and your the bracket location. Based on your bracket location, we adjust the beam up and down, like maybe the building height is 3 meters, I mean each floor is 3.5 meter or 4 meter height. We adjust the beam where you can install the brackets and hook the facade. And then once the facade installation is completed, we will cover the specimen, as you can see on the photograph 3. And we will cover the facade, we'll cover the chamber completely and make sure it is airtight. Then we apply the testing. Then we start to do the testing. The rig is ready for testing. Test performed. What are the testing we do in our laboratory? Basically, we do air infiltration testing as per different standards like ASTM, BSCN 1026, BSCN 12153. 1026 is a standard for doors and windows. 12153 is the standard for facade and curtain wall. And then water permeability, water penetration testing, water tightness testing. So this test we can do as per ASTM 331, BSCN 1028, BSCN 1215, 155. Then the structural performance test, the most common standard is ASTM 330, BSCN 12211, and BSCN 12179. These are the structural test load standards. And we do the dynamic water penetration testing, make sure if there is a heavy wind and the rain is happening, then how the facade is going to react. So this can be done in the laboratory and make sure the system is properly done, it is properly installed. And the seismic and jacking testing, and this is what I explained to you. When we have then any seismic movement, or if we have any dead load or wind load effect is there, this can be tested in the laboratory before it's going to the site. It can be tested as per ARMA 501.4, which is the seismic movement, ARMA 501.7, which is the vertical movement. Then we are able to do the thermal cycling testing. It is very Nowadays it's very common in Indian market also. Like we create a temperature difference of minus 18 degree to 80 degrees Celsius, where you can identify whether the gasket is okay, whether the sealant application is withstand for long time, because this testing is basically 3 cycle, minimum 3 cycle. It can go up to 6 cycle, 9 cycle, depend on the project requirements. Like we create a minus 18 degrees Celsius, and this will continue for 1 hour time, and then that minus 18 degrees Celsius we continue for 2 hours, maintain that minus 18 degrees Celsius for 2 hours, then it come back to normal temperature. Then we increase the temperature up to 80 degrees Celsius. This is what the standard says, 80 degrees Celsius, and then maintain for 2 hours. Then it bring back to a normal condition. This is 1 cycle. So this kind of cycle, we can make it 3 cycle for a system or 6 cycle for a system. And then we can check for the damages on the sealant gasket, whether it's for a long time, the sealant can work or not. And seal degradation testing, again, this is actually for the sealant quality. Like, for example, our systems are designed for maybe 20-25 years, and what will happen after 10-15 years, the sealant breaks, or silicone breaks, or gasket damages. Still, the rain or air, the rain, basically the rain, can withstand, the system can withstand the rain. If there is, we cut the sealant and then apply the water again and create the negative pressure inside the chamber. So we can check it, whether if the damaged sealant can work well or not. The railing and balustrade testing, we do the testing in our laboratory. We check the line load testing for the railing. We do the impact testing on the railing. We do the wind load testing on the railing. It can be done in the laboratory, and also we can do it on site. BMU pull-out testing. BMU cradle, BMU is a building maintenance unit. So basically, for the building, it will be installed for cleaning purpose. It will be installed for a maintenance purpose. So when the building BMU is installed and there is a heavy wind or something, this has to be arrested. The movement has to be arrested. For this pin usually installed on the facade system only. So we need to make sure when there is a wind, when people are inside the BMU and the wind is there, and how the facade system is going to withstand that load, including the BMU load, weight of the BMU, weight of the people, and it has to withstand the wind. The wind is also how the wind is going to affect the cradle, the BMU, with the people, with the material. The system is able to hold that BMU. So this can be simulated at the laboratory and tested and can issue the certificate. At impact testing, we do impact testing for various material, like we can do it on the glass, we can do it on the stone panel, we can do it on like ACP cladding panels. So basically, these are the testing I was talking about conducting in the laboratory, but this is the testing we usually perform on site. Like water hose testing can be done on site to check the water, water leakage of the building. And basically, this is checking the workmanship. It has nothing to do with our design and all. On site, we randomly choose the location and we can do the water hose testing with ARMA 501.2 standards. The next is site chamber testing. We have recently conducted one of the site in Delhi for Sahvia Facade, and it was an on-site testing. We build a chamber. We test up to 4 kPa wind load, and we along with the air, water, structural load testing. So basically, our team will construct the chamber on-site and perform air infiltration, water penetration, and structural load testing. And as I mentioned before, we can also conduct railing and balustrade testing on-site. Air tightness testing, it is not that common testing in India, but we have a facility to do this testing on-site, like a complete air tightness, checking the complete air tightness. For example, if you wanted to do the testing, if you wanted to measure the air leakage of this auditorium, we can install one fan and check the air leakage through that machine. we'll come to know what is energy losing, how energy is losing from this building. And this is another testing is thermography testing, which is as for ASTM E1186. This is actually part of a LEED certification program, and we are able to do this testing. And pull-out testing, anchor bolt pull-out testing can be done as for ASTM E488. Yeah, Eminent. The next is our facility. Like this is our facility. We build. We have at present 8 test rigs and for facade, and we have a 4 chamber for doors and windows testing. Eminent is always make sure client confidentiality, and we don't have any. We have the impartial approach. No matter who is paying us, who is dealing with us, our certificate is very clear. What is the test result? It will be in the report. And our equipments and our team is well experienced. We always make sure the equipments are calibrated. The range is actually as per the standard requirements. So these are the projects we have done so far. This is one of the Hyderabad project. We started with our testing facility. The first testing was done with Aluvision Facade. It's a consultant. It's a Hyderabad project. Elegance Imperia and SAS Crown project is done in Hyderabad. Phoenix 285. Aluplex was the aluminum contractor. This is another project, MLP Meenakshi. And Alembic City is a Bangalore project tested in Hyderabad. EO Navanami is tested in Hyderabad. Equinox, again, it's a Phoenix project. Navi Mumbai International Airport, we have tested the skylight and the roofing system for CalZip. And Phoenix Business Hub, we've done in Hyderabad, it's the Navi Mumbai Airport again. Phoenix 285, Centrum, Gold Mile, and my home Nishada tested for again Aluplex. Warangal Hospital is done. Trump Tower, which is again, I am taking your name a lot. Okay, Raymond Reality, we have tested. My home Grava again for Aluplex. Cantur Crescent, Gwalior Airport, we have done. Patna Airport. Hanimadu Airport, which is Maldives Airport. Palas is Royal and Lodha Signet project for Lodha. Godrej project. And we have done some testing for product testing we have done. Alcoy, Qvin, Shuka we have done couple of testing. And Polywood, Kolkata Glazing, Stonela, iClean, Lingle, Active Green, Aluke, Gilan Window, Aluke again, handrail testing for. Yeah, these are the projects we have done in the laboratory, and there are some couple of projects internationally we have done. As I told you, we have an office in Dubai. We work in Dubai also, so we have done a couple of testing in Dubai also. Yeah, that's it for now. We are located in Hyderabad, 1 hour away from Hyderabad International Airport, and we are about 30-40 minutes away from the main city, Gachibowli, in Hyderabad. That's it for now. And thank you so much for listening to me. And if you have anything related to, any doubts related to facade testing, any on-site testing or like a LEED certification program, if you wanted to discuss about the testing, our stall is there outside. You can come and discuss with us anytime. Thank you so much.
Thank you so much, Reji. Now he will position himself near the door and test everybody with a question so that you can go out and have coffee if you answered correctly. No, I'm just joking. Okay, but please, ladies and gentlemen, you can head out and take a little break. So now that everybody is caffeinated and, as they say in Delhi, you've had your chai pe charcha, and we have to have everybody back in the room. So whoever's outside the room and wants to join in, please come on in. It's all the seats are open and they'll get taken soon. But to begin the next session, we have a very interesting 2 speakers. We have Mr. Ahmed Sumair and Manali Joglekar from Sahvia Facades. And they're going to give us a very interesting talk on BIM.
Please put your hands together to welcome them. Thank you. I sound like a teacher.
Yeah, hi. Hello, everyone. So, good afternoon. So, before starting presentation on a BIM, we would like to share about our company, who we are actually. So, we represent Sahvia. We have a presence in Vietnam. India, we have 3 offices. Then Singapore, we have a representative office in Zervix UBI. Then we recently started in Saudi Arabia, and UAE we already have from past 2 years. We serve in 4 verticals. We are a facade consultant. We do a lighting design for interior, landscape, and facade lighting, signage and wayfinding, also BIM services. This is on the screen. We have a couple of projects we have locally and international also, like Cybertham with Bhutani, the Nathani Heights, CRC, Imar, couple of bullet train stations we are doing in Gujarat, and also international projects, architects like Norman Foster and Santiago Calatrava we are doing. So today's topic, myself and my colleague Manali is going to speak on use of BIM, and we are represent facade and practicing a facade. So what is the involvement and what is the benefits of using a BIM, we are going to share here. So understanding how different services with respect to facade. The one.
So good afternoon all. So today we will try to touch upon 3 main points. One is understanding how we coordinate different services when it comes to facade. We will try to link it with BIM. Then secondly, we will see integration of parametric facade in BIM. And then thirdly, we will see how BIM can be used with flexibility and adapted with different available technologies such as Grasshopper or Rhino and various different add-ons. So let us move on. And first things first, we will see what is BIM. So the widely known long form of BIM is Building Information Modeling. Now we will go into detail and we will see some points wherein we can explain what exactly the BIM is and what it does and how it can be useful. So the first thing is the definition, of course. So it is a 3D-based, cloud-based intelligent modeling, and we can have a digital representation of a project when we use BIM. So secondly, how it can be useful. Now, since we have a digital representation of any project, we can create and manage all the information that is related to project in one go. And what it does, it brings together all the multidisciplinary data available such as MEP, lighting, structural, landscape, and architect, of course. It brings it together on one platform and then tries to have a compiled package wherein everyone can be on the same page. Now we often hear people saying that we have to get these things clear first so that in the later stage, we can all be on the same page. Now, this can be achievable with this. We literally can be on the same page. And last but not the least, since it is a cloud-based model and since we have all the data together, we can have the process of planning, design, construction, and operations run smoothly. So to summarize everything, I can say that it's a 3D cloud-based modeling wherein we can have a smoother working in terms of planning, design, and construction because we have all the data compiled together on one platform. Now moving ahead with this, we will see that how BIM is useful in facade. Over to sir. He will explain that.
So what sort of document we are going to get in each development, each detail we can discuss here. So what is the benefit of BIMs first? So better visualization, we can understand the architectural intent in a 3D form, which is a very basic need actually. Then maximize the efficiency. Once we have a better visualization, then efficiency automatically increase and we can control the cost and estimate also. So there are different stages where we can have a detailed modeling and we can take the quantities and adopt the quantities in precisely to control the cost, then better insight into the projects like coordination with the other services, different services also. We can see in the same time a complete consolidated model. Then communication and collaboration is a key to make a project successful in terms of design, also during the execution till handing over also. So multiple disciplines are there, how we can coordinate and how we can integrate all the information in a single platform. Then the result is always is better when we have a completely collaborated and our teamwork.
So based on this, we can roughly divide the life cycle of BIM in 3 parts. First is, of course, the design and planning. So design starts from here. When an idea is germinated in any designer's head, he tries to put it on the paper. So the concept development is done, wherein just massing is done. Then we try to give it a more precise shape, I would say, which comes in, of course, the schematic stage. And then thirdly, the detailed design. So these 3 things make the first stage, which is design and planning. Once that is done, the detailed design set is available with us. We can move forward to the next stage, which is, of course, construction. It involves preparation of shop drawings, review of shop drawings, then fabrication drawings, review of fabrication drawings, and then with that installation takes place. And once that is done, we can move to the third part, which is operations and maintenance. And that involves handing over of the project and then renovation in the future if required. So all these 3 things comprise the life cycle of BIM. Now, why these 3 things only? Well, they've been arrived at after years of experience in the working, in this field, of course, and they have been developed by 2 agencies. First is American Institute of Architects, and second is Associated General Contractors of America. They have developed certain stages so that all these 3 things can be defined and explained properly. They are called LODs, or level of developments. Now, what are they? That will be explained by sir.
So as mentioned my colleague, they have already set the standards for detailing and the stages. So LOD, level of development, is a one stage, like we call concept, schematic, detail, construction, and LOD 500 for a facility management stage. So what we deliver in a concept stage, LOD 100 is a preliminary idea mass where we don't have a very refined information or member sizes. LOD 200 where you can have a little bit of refinement, where you can see the member sizes in visually and the modulation panels height. With LOD 200 helps to develop the design development, I can say, where from architect and consultant can develop the design development or tender drawings stage. So LOD 300, in this stage, we are going to have a complete insight of the profile. Like here you can see semi-tized profile, the gaskets, joinery details, subframes, glass preparation. So all precise information we will have in LOD 300. This is a detailed design stage. Also, generally we call like a tender drawing stage or tender drawing. So this is a stage where we can deliver that kind of a document. Apart from that, in LOD 300, during the modeling, we can visualize and detect the clashes between the other services, MEP or any disciplines. We can easily identify at this stage in 300. Then we can issue the raise and all. Then once comes to 350, so 350, we will generate the BIM sheets from LOD 300, where we have already precisely modeled all the components of facade integration. Then from there, we can crop or adopt the BIM sheets and we can float in the market for a tender drawings. Also, we can develop this stage in a shop drawing stage. So you will see all the connection details, annotations, all material specification at this stage. Also, in 350, we can generate complete bill of quantities, quantification of each element, and all type of profiles. Even we can calculate the screws also in this very precisely. Then when it comes to LOD 400, is a more refined model, like making a junction details, interfaces details with the different disciplines. Like for example, the bottom detail, the sill detail, the mid detail and top detail, the flashing, sealants, anchor bolts, brackets, bracket thickness, the distance of anchor bolts, distance from edge to the center point. So all minute details we will have in a LOD 400. From this stage, a contractor or consultant, they can have complete fabrication drawings for a production also. So this is a very minute model. Then comes 500. This is a facility management, and also we call as built. So once we develop all the stages, then we can have a very completely end result, coordinated, consolidated model here. So from design to execution, so from one example to understand how we have modeled till 400, then what we have executed, the geometry is very simple, but just want to show what is the relation, how we developed in LODs and what is the execution final output. So let's understand how coordination with the different services, which is a very key part during the design, also in the execution respect to facade works. And what are the challenges we are facing? Then why we need a BIM? Like lack of understanding the geometry. For example, if any parametric facade or the inspiration what a principal architect have, and to transfer those information to the different disciplines, it takes some time depend on the consultant to consultant. Then consolidated drawing packages. So in the 2D, what we do, we overlap, especially for MEP drawings, overlap for a terrace level, like especially for a BMU, we overlap the MEP layouts on that. So all this kind of consolidated package, we are facing an issue that we can resolve here. Then regular review, we can have a regular DRM, and one BIM manager will be appointed from the client side who can manage all the disciplines in a BIM, who can raise the notice to each and every consultant, what are the clashes and difficulties we have. Then delays in appointment of consultant. So generally lighting consultant or maybe facade consultant comes in a very advanced stage. So that time, till that time, the concept and schematic is already closed by the principal architect. So there are a lot of discussion, lot of understanding already communicated to the owner, but the later on, the other consultant require more time to catch, and at the same time they have to deliver in a limited schedule. So those kind of issues we can capture here. Then production and installation requirement, this is also one challenge which we can control, and we can have precise fabrication drawings.
So these are some of the challenges that we face generally in any project, and they are discussed upon regularly. But there is one more thing which we feel is seldom discussed, but is important also, and that is understanding the difference between civil and facade structural design. That is very, very, very important, I think. And we are trying to put some light upon that through our presentation, which is of course linked to BIM. So we just had a tea break. We are in Delhi. We have to talk about food. And I am a hardcore Mumbaiker, but I must say that some of the items in Delhi are just irresistible. You can't get the same taste anywhere else. You can't get the same look anywhere else. Look how tempting they are, right? You must have had them right now also, I don't know. So, of course, look is important, presentation is important, taste is important, but so is the construction. Otherwise, it might end up looking like that. And, you know, see the image. I mean, with hundreds of people gathered around that stall waiting for something like this to come in front of them, if that happens, it's hazardous. There is a hot oil. And then, of course, we are expecting this and we are getting that. So construction is important. And we are going to talk about that a little. So let us move on. If it goes wrong, it can go wrong very bad. Something like this can happen. The facade might fall off, the glass might break, the skylight might fall down, and it is risky to life also. It is risky for building's life also. So facade is not just an aesthetic element, it requires engineering analysis. And that's what we are trying to talk about today a bit through our presentation. So let us take one example, and then let us try to understand what that is, which will be explained by sir.
So when we develop model in a LOD 200, 300 and all, so it's not just aesthetic as my colleague said, it's require engineering. So always the requirement, yes, aesthetic also is important. This is the first like approach to the any project I can say. So in LOD 200, we will have this kind of arrangement where completely aesthetic model delivered from the consultant sides. For example, these are flare columns we do have is around like a 200 by 480 mm deep till 18 meter high. It's a small project. While designing the 200 LOD 200, the basic model, we have to calculate the engineering site also, like a wind load, the framing size, then projection of members in the width, in the depth also. When we calculate in a detailed engineering respect to the wind load and other parameters, the shapes and sizes may change in some time due to the connection design. For example, if architect says I don't want any connection in between because I don't want to have any obstruction, so this span is around like a 10 meter high. So to stand the 10 meter high structure, I need at least one support in between. If I don't need, then I need a certain height, depth and size. Once I introduce that one, then architectural intent will dilute in some cases. So how to manage it? So this kind of exercise during a very initial stage in LOD 200, we can get it done and we can communicate with all other disciplines like structural especially and architectural consultant. So then LOD, next is a 350. So what we have to do during developing before the 200, we have to calculate minutely, then we can communicate precise sizes to architect to have a very minute and final product. So these are the structural members you can say, then we have coordinated.
So in order to arrive at these sizes, we had to consider some basic design principles. And once those were considered, the loads were applied on the structure, we arrived at the sizes which are explained or given over here. So what are these basic design principles that we generally follow while designing any facade? So first, of course, are the loads coming on the building, which includes dead load, which is self-weight or any cladding weight or any facade element weight that is coming on the building. Second one is if it is an element like a railing, it's a line load or live load or imposed load, what we say. Then there is a seismic activity. If the zone or the building lies in seismic prone zone, then we need to check it from earthquakes point of view also. And one of the very important loads, wind load. And these are the factors: where the building is located, what the terrain around that building is, what the topography of that area is, what are the current weather patterns. Because right now NCR and Delhi, they are experiencing very gusty winds. That had never happened very often before. So all these updates, they need to be taken care of. So wind load is also very important. And this is where the difference lies. This is where the difference is between designing a primary RCC structure and designing a facade. So they are similar and different, I would say. So there is a difference, yes, and there isn't any difference, yes. There isn't any difference because ultimately it's a wind pressure, it's a wind load. And there is a difference because the calculating method or some gust factors are different while considering them from facade's point of view and when we are considering it on a structure as a whole. So understanding that difference is very important, and conveying that difference in approach to all the consultants involved is our responsibility, so that any future clashes can be avoided. So once all these factors are considered, then we arrive at all the sizes which were calculated. Now, these are some of the introductory videos which will be explained by sir, how we do the BIM designing and everything.
So I shared my colleague, like structural parameters are very important. जनरली इन दिल्ली एनसीआर के शर्मा जी की बिल्डिंग की हाइट इतनी है तो मेरा भी विंड प्रेशर इतना ही होगा. नहीं, सबके साइजेज, टेरेन कैटेगरी, द डायमेंशंस आर डिफरेंट, सो वी हैव टू कैलकुलेट फ्रॉम द बेसिक फॉर all parameters. So here we want to show one small clip actually how once we develop in LOD 300, then you can see the detection, you can visualize like the beam clashing with the facade line. So these kind of errors or clashes, we can raise the issue here to respective consultant. They will have a auto-generated email to respective consultant, then they will go there and they will resolve, then we can make the segmented facade panel. For example, one more here. So we are generating issue to respective consultant like for MEP. So there is a clash with a RWP pipe for a flare column. So we have one flare column of 18 meter high, which is cladded with the solid aluminum sheet in a box form. When we started modeling facade there, then we found there is a clash here. So we started raising an issue, then they saw that and then diverted in an angle. So here you can see. Then resolve. Once they resolve, issue is closed.
So once all these things are done, the final outcome we can expect very better, very coordinated and very consolidated. So the challenges we discussed can be resolved, or we can try to minimize them, I would say, not eliminate them completely. So we can have a design with precision and clarity. Then we can have very efficient design development since everybody is involved in the project. Then we can have better teamwork since everybody is on the same platform. The next thing is cost and time management can also be achieved because the clashes are resolved, or we are trying to resolve them at an earlier stage, and value engineering option and optimization can be thought upon at a later stage. So quality checks are also possible, regular quality checks are possible because we have all the things right in front of our eyes presented digitally. And with all these things, we can have a better consolidated package. So now we will move on and try to understand the integration of parametric facade into BIM. That will be explained by Sir with one of our projects.
Yeah, so one small amenity block we are doing with Majid Al Futtaim in Dubai, in Tilal Al Ghaf. So here we have used completely till of LOD 400. The soffit and roof is cladded with the solid surface material, Korean cladding, what we call here. And the structure also we have designed here, the complete steel structure. We have modeled in Grasshopper, designed in Grasshopper, then modeled in Rhino, then we imported in Revit with support of a SAT extension. So here you can see the complete structure, then we have a decking sheet and insulation, and then one more waterproofing layer on the roof, then solid surface. So each and every panel have a different dimension, different punch and different depression here, which with the support of Revit and the different platform, we have started generating a final production also. So here you can see. So these are the composition for a steel structure, exploded view, then insulation panel, then one more grating and waterproofing membrane, then solid surface sheet.
And while designing the structure, we had to think about all the loads, of course, and the geometry, because no panel is typical in this case. So what we did, we preferred using locally available codes because the behavior of weather and the material is better captured, I would say, in locally available codes. So if we take those codes in consideration and then we try to calculate what the behavior is going to be, we can arrive at more optimized solution is what our take is. So we calculated the wind load, we calculated what the imposed loads and then spider glazing, and all the bracket fixings were detailed and customized according to the curve of the building. And then these were some of the end results which we got. Then there was a spider glazing which was attached to this particular roof at 3 locations, and we had a challenge of designing the top bracket in order to accommodate the building movement or the frame movement. So all the brackets were supposed to be designed like that, and while designing that, we detailed it out and we published all the sheets, And then we arrived at this kind of a submission, I would say. So that's how we tried to implement BIM into this particular project where the facade was of a very uncommon shape. Then this is the rendered image, final rendered image of the project.
So during a concept stage only we have involved with the principal architect to develop the geometry, because a client want to make sure that it is buildable, and they want a completely engineering architectural model, not only like they made a model, then again we have to go in a detail engineering to save the time. So they involve in a very initial stage. Then here we just want to share some couple of example for adoption with the different technology, how we can integrate into Revit. So we want to share one example with our reference project. So it's a refurbishment project, Lucknow Airport. The piers are cladded with a multi-faceted panels. We are going with a GRP panel here. So there are 6 families, 6 modules, and each module have a till certain height is a typical panel, then the flares become in a different dimension, different sizes and all. So we have modeled in a grasshopper completely with the dimensions and all. Then again import into, modeled into a Rhino, and Rhino to Revit. So this is completely integrated and coordinated with the structural, because there are a couple of limitations due to the existing structure to design the steel and distance from the concrete surface to a fascia panel. So those all engineering model we have done here. So these are a couple of references, the images we have done and modeled.
So all the panels were of different sizes, pretty much all the panels were of different sizes. So we had to detail it out in a way that it is accommodated seamlessly into the facade or the main structure. Then this was the main model that we received from the principal consultant and architect. And our main challenge was to have a glazing and the FRP panels on these columns, and then have a glazing in between those 2 columns. Now the main challenge was to fix the glazing underneath the existing flyover, which is getting connected to the national highway. So this is the area wherein we had to connect our glazing, and the upper structure is already existing. They did not want to have any top support whatsoever, and height of the glazing is around 9.5 meters. So it was a big challenge to have 9.5 meters of a glazing without any top support. So we tried, because the soffit must be having some vibrations and dynamic loading due to the continuous vehicle movement. So they did not want to have any connection at the top. So what we tried to do is we tried to develop a model such that the top loads are minimized to the best of the possibility. We designed a very sleek portal frame around the entire glazing, and then we fixed that portal frame to the main structure. You can see the model over there. So the surrounding frame is a portal frame, and it will have around 5 or 6 supports which will be connected to the main piers of the bridge and not to the soffit. So that's how we were able to achieve the intent that what architect was thinking of. And then we tried to integrate that into Rhino, and then we are in the process of compiling it and presenting it. So those are some of the advantages which we were able to achieve, because everybody was working on the same platform. We used to have, or we still have, lots of calls on daily basis with all the people involved in the project. And this is the final look, where all the panels you can see are of different shape and geometry, and that's the complete extension part of the facade. So
yeah, so appointment of consultant on a initial stage will always helps to build a healthy communication and transferring the principal architect idea to a different discipline in a healthy manner. So and the design coordination. So that's it.
So that's about it. So to end it on a kind of funny note, I would say, when they said it wasn't worth the investment, the outcome would have been like that if it wasn't coordinated properly. But with coordination, we can see how beautiful the building is. So coordination is important, and BIM can be helpful in coordinating it well. On that note, we conclude. Thank you, everybody. Thank you,
Thank you.
Zak.
Thanks, everyone.
Thank you, Ahmed, and thank you, Manali. That was very good for all of us here. We have to collaborate, and technology can help us achieve that collaboration without too much headache. So, without much ado, I'd like to invite Mr. Awasthi here. He's the head of engineering at Shuko. Please give him a round of applause. Thank you.
Thank you, Ahmed. Thank you, Manali, for a wonderful presentation and detailed presentation on BIM. So hello, everyone. My name is Kushagra Awasthi, and I represent Shuko Engineering here in India. Today, I'll be speaking about the sustainability in the Indian context, basically two topics. How do we design to decarb, and how do we build up the supply chain to sustain towards sustainability? So here, I'll be speaking a little about the materials that we use here in India. I'll start off with few numbers. So this is a global number to start off with. So all over the world, just imagine if 100 units of energy is produced, 40% goes into the buildings. Let it be during the construction or operational. That is why you will see the 3/4 will be the embodied carbon that is going into the building and 1/4 for the operational. So 40 units of energy that is produced globally goes into the building. Now, how facades are connected, you all know, facade is part of the building. So 20% of the energy that is being consumed is only on the facades, right? So 20% of the 40% before. Again, facade has a lot of components, right? It has glass, it has aluminum sheets, aluminum profiles, mineral wool, polyamide, EPDM, and so on. So this 37% is really important for us, which is basically the aluminum profiles. So now you can do the maths again and see where actually you are landing. It will be roughly around 3.5 units per 100 units of the energy produced globally in the world. So what are we doing? I mean, this is a huge, substantial amount of energy that we are talking about, right? So just before that, I will walk you through this guideline from LETI, which is basically the whole carbon emission life cycle in buildings. And this is divided primarily into 4 parts. So A1 to A5 is basically the fabrication, the production, and the construction. So it includes the mining. It includes how it is, shipped, the transportation from the mine to the factory or where it is getting refined. So that is one part, which is A1 to A3, and then comes to the construction where actually this aluminum which has been mined has been converted into profiles and made into sections put up on a building, okay? And then the second phase starts, which is basically the B1 to B7, which is basically the operational cycle. So first part is the embodied carbon, the second part is the operational carbon. Then comes a phase when the life of the building is over, right? Then you need to demolish it. So that's when the phase C1 to C4 starts, and then in the end is the recyclability. You need to recycle it, right? So that's the phase, the fourth phase, which is phase D. There are different versions of connecting to how the cycle has happened, like cradle to gate, cradle to practical completion, cradle to grave, and cradle to cradle, right? So cradle to cradle is basically from the start till the end, right? And what is primarily important for us right now is, of course, this the first part, A1 to A5, is really important because that's the major embodied carbon, and you saw that the 3/4 of the entire building energy consumption was on the embodied part, and only 1/4 was on the operational part. So operational part still remains important, right? But we need to focus really on the increasing importance on the first part. So this low carbon emission materials, the design, transportation, the construction, this is the prime focus for us, okay? And how we are dealing with that. So we at Shuko, we have a carbon control mechanism which is helping to make the buildings greener by minimizing CO2 in the construction, okay? So CO2 is what? It's like carbon, the black carbon, right? And that is, we want to reduce it. So we have built up a tool which is primarily focusing on the 4 parts, the 4 phases. The first one is design to decarb. So this gives the right foundation to do a perfect design and planning, right? So this will help our partners, the builders, and we tell them how we are basically designing it. So this is designed to decarb. So whatever we are designing is basically low in consumption of carbon. Then the second phase comes, which is build to decarb. And this is basically to manage the carbon footprint of the planned buildings during its construction. And of course, we need to comply with the certain regulations, which is different from region to region. So we assist in that second quadrant also. The third part of the toolkit is the operate to decarb. So the buildings, this is the operational phase, right? So the embodied part is over. The third part is the operational part, and this is where we focus where the buildings are running. So how efficiently the buildings are running, how efficiently the facade is performing, how efficiently the windows and doors, everything which is part of the facade is performing. So that's where the focus is in the third quadrant. The fourth quadrant, of course, is the recyclable, which is the last phase, the D phase. So here we are enabling our customers and partners to recycle the materials as new resource. I mean, there is nothing new, but it's planned in a certain way. Out of the 4 boxes, I would like to focus today only on the first box, which was designed to decarb. Okay, every box is important in the toolkit, but this is the most important. And how do we attend to it? So I'll go a little more in detail only in the first quadrant, which is designed to decarb. So today I'll be focusing. There are n number of parameters in it, but today I will focus only on the U value, the air tightness, and the material consumption. So material consumption is more on the structural aspect, and the first two are mostly on the performance parameter, right? So let's see. So this is a short case study kind, so that we all can correlate what is actually happening, where is the industry. So this is an example from Ahmedabad. The project is called Adani Energy House. The architect is Arch Group. The facade consultant is Fencon. There the challenge was to, of course, reduce the operational carbon, okay? And the intent was to reduce the space cooling demand, have high daylighting, so the sizes were big, the grids were bigger, so the overheating was an issue, and then, of course, the running cost of the building has to come down. So U value was desired to be below 1.9, okay? So this U value is actually a little challenging in the current scenario, right? Because we are in a tropical region and we don't have any thermally insulated systems when it comes to facade systems. Of course, there exists a lot of systems, even in Shuko portfolio we have, but this is something which is not common and not well accepted still in the Indian market. So we had to do something. It has to be a non-insulated system, a lot of aluminum, of course. I mean, it's a big structure, right? But the U value has to be below 1.9. Okay, just to give you a reference where our industry stands. So the best bet will be 2.5 right now. Okay, if the industry is stretching, they will come to 2.1. But here, what we have done or achieved is little remarkable, which is 1.87 watt per meter square Kelvin. And how did we do it? So this is basically the design is basically only in the functional part. Okay, I will explain in the next slide what is the functional part and how we did it. So the functional area design was, targeted, and then we played on the geometry and of course the material selection. So we were able to generate a lot of options with the same design philosophy. So we played with the design philosophy here, and we came up with multiple options by the end of the project. So we already had like 5 options readily available, in both stick and unitized system with the same concept. When it comes to material selection, we had multiple options for each geometry available. Okay, so there was we did a lot of U value analysis, and then we came up with some optimized. It is not just the optimization of the profile section that we are talking about. This is the optimization of the thermal lines, how the heat is flowing, how the heat flux is flowing, where the condensation is happening. Okay, so we were able to design a system for 1.87 watt per meter square Kelvin for this particular project. And with the other options, we were able to come down to 1.3, which is again a remarkable thing. So again, there are no specifications right now which is driving this particular requirement. So that is why, I mean, our Indian industry needs to explicitly specify best-in-class U values in tenders. So this is the request. So once we do that, we will be able to substantially reduce the operational carbon. That is the most important thing that should come up in the mind, right? So how we did it. So this is the different sections. So this part is the functional zone here. This is the glass part, and this is the functional zone. This is very critical. So whatever we have to do exactly here, right? And the 1.87 that you saw was not just for a plain, simple facade panel. It included the openables also, right? And included the fins also. So it is for the overall facade that we are talking about. And that is something which is, again, best in class that we have done here in India. So this is an example how we played with the materials, because we have now a proprietary material that we are using here to reduce the U value. Of course, we cannot do anything on the glass because that is already specified and being used in the project. But whatever was in our hand was to play only in these functional areas, right here. And this is what helped us, the design and the material, the new age materials, which now we are, we have started using it in other projects also where the U value requirement is getting some importance. So this is just to give a reference for that. Now, the second important aspect that I spoke about for design to decarb is air tightness, right? So air tightness basically is, it helps us, right? There is no air exchange. So if you want to keep your buildings cool, here in India, you can, keep it cooler for a longer time if there is less of a heat exchange. If you want to heat up your building, if you are in Europe or in a colder region, then the less of air exchange will put down your heating bills down. So this is just an example to show what we have done here in Noida, which is Fairfox Eon, which is Eye of Noida, very popular project from designed by Design Forum International. Goonmeet ji was here. This morning we all heard from him. That's his firm. Facade consultant is Avante Facade again. Suresh ji was here. I don't see him now. The fabricate, it was actually the project is still on, and our fabrication partner, Shankar Fenestration, is also here. We're glad to see them. Here the problem was not actually a problem. Here the requirement was 600 Pascal, which is okay, not a big deal. But 600 Pascal comes in different stages. So it was not actually specified because the EN code allows you to have 600 Pascal in two classes, right? So the desired value was less than 3 meter cube per hour per meter square, okay? The industry currently stands at 27. And that's the leakage I'm talking about, the permissible leakage that I'm talking about. The industry stretch is at 9, which is again at 600 Pascal, okay? And then best in class is less than 3, which is again at 600 Pascal. So here I would like to emphasize on the point that you still have 600 Pascal specified in the tender, but you are not classifying it. So there is a big difference between the two, right? So when you take a EN class 3, which is basically a 600 Pascal, but you are getting a reference permeability at 9. And then again, the same 600 Pascal, you can have a better performance, a really high performance. You can see directly it's 3 times more, right? It's 3 times better. But it's again at the 600 Pascal. So how did we achieve it? I mean, again, we have to go back to the geometry. How do we work on the geometry? How do we solve the interfaces? How do we solve the interface of the profile with the gasket, with the other elements and so on? And then what kind of material are you using? It's important to understand that gaskets also doesn't solve all the problems, right? So if you want to have or achieve a higher water tightness or air tightness, then the composition of the gasket also has to be changed, and or maybe mixed with a certain other material like foam. Okay, so it's like co-extruded foam and gasket. We need to play with the geometry and then put in there. So we actually ended up with multiple options again here, and I'm really glad to say that in 600 Pascal category, we have solutions with a 2-barrier system, we have solutions with 3-barrier system, we have solutions with 4-barrier system, and we have solutions with 5-barrier systems. And these are all I'm talking about door, window, and facades all together. Okay, so this is one important aspect to be kept in mind. And here again, I like to re-emphasize on the same point that we have to specify the classification, not just the number in the tenders, and that will drive something which is much, much bigger and will help you out again in the operational reduction. This is again from the same project, Fairfox. Here you can see, I mean, it's not a simple straight facade, rectangular kind of a building that I'm talking about. This was a really complex building, right? If you want to see again, just go back and see this picture. This is a rendered image, and it's really complex. It's really complex. So there are multiple angles in this building, multiple corners, and it was really important to have the same performance as it would give in a straight facade. So that was another challenge. And couple of places we had to go from a 3-barrier system to a 4-barrier system and so on in order to achieve it. So we need to understand how the system is behaving, and there has to be a mix. And it is not like, you know, here you have given 3-barrier, there you cannot have a 4-barrier. No, it doesn't work like that, because every geometry is critical, right? And every corners are critical. The dimensions change, the grid size change. So we need to play with a lot of things and then come up with a solution right there. Okay, and this is again 600 Pascal with EN class 4. Not 3, okay? Third example is on the material optimization part, which is basically on the embodied carbon, okay? The first two what I showed was primarily directed towards the operational carbon. So now this is more towards the embodied carbon. So here again, we will talk about the profile section, of course, and then how we optimize the design. So this is a core design, structural design, I would say. So we have to design the elements right from the scratch. We need to define the nodes. We need to see where the stress is coming, where the deflection is coming, how much is permissible, how much we can afford, how much we cannot take the risk. So this is what it goes on. So this is a project which Reji also showed, because this was tested in Eminent for all the cycles, and we had really good results. And the project is Eon Navnami from Hyderabad. The architect is Panchil, based out of Pune. Facade consultant is RSM Design, and the fabricator partner is Active Green in Hyderabad. The challenge there was we have to reduce the dead weight on the structure, okay? And this is a challenge which I came across. I have never come across before, because this was required, because I was asked to put as much less weight on the structure. As you all know, facade is a non-load bearing structure, right? So the load is basically borne by the civil structure, right? So I was asked to put as least weight as possible, okay? The performance parameters cannot be changed, because the wind zoning where it is lying, that cannot be changed. The climatic conditions cannot be changed, right? Nothing can be changed, but it has to be as light as possible, okay? So that was the challenge. 1.8 kPa was the wind load, and when I saw the grid sizes and started working on it, then we came to know that roughly, you know, if I'm designing the same building without anything in mind, the industry will design it at 8 kgs per square meter, roughly around. The industry can stretch up to 7.5 for that particular wind load, 1.8 kPa for that particular grid that it had in this particular building, Eon. And the best in class is anything, you know, which can be less than 7.5 kgs per meter square, right? How did we do it, and what did we do? We actually achieved 25% reduction from the best what the industry can offer. So from 7.5 kg, we reduced further 25%. And we were able to make it as light as possible. And you will not believe that we designed for 1.8 kPa, but we were able to pass at Eminent for 2.5 kPa. And this is the design wind pressure I'm talking about, not the proof loading, which is basically 1.5 times of the design wind pressure. So of course, we had to use a lot of softwares. We have to use many tricks, and you know, we had to refer a lot of standards, what we can take from which standard, how do we interpret this standard, and so on. And that's when we realized, like, there is a possibility of, you know, doing the right thing in the design phase not from a cost-saving perspective, because, as I said, the agenda was not to save the cost, it was to reduce the weight that is coming onto the structure, right? But it was never appreciated like that. Once the design was done, it went into the the commercial part, like you have reduced the weight and hence, the costing is less. But that was never the intent. And that's what I want to emphasize, that when we engineers, we work and do something like this, it has to be appreciated. Not everything should be looked from a commercial perspective. Okay, that's just a request from my side. So that has to be appreciated. Right, anyway, so there were a lot of modulations were done. I will walk you through quickly for the softwares that we use. And this is just to give you an example, like how are the other things that we can play off with. So you can have the mass of aluminum will directly depend on the stack height. The mass of the aluminum will again depend directly on the floor height that you have. And then how the FEA analysis is done, the small nodes, how every element, the flange, the web thickness, how everything is designed, right? And there are different modulations that you can have and different options can be done. So just to tell you, if this is a profile section, so this profile section will have certain depth and height and will have certain mass properties, like the moment of inertia will be there, right? And everything is correlated. So if you increase the depth, you have a higher moment of inertia. If you increase the face width of the profile, you will have an increase in the minor axis moment of inertia, and so on. So this is the logic that we have to keep in mind, and everything depends on it. So we have this Shuko in-house software, which is still under development, which is called as Optics, and we are able to optimize a profile section nearly 94% of its original weight, because we need to give an input design, and what we found was 94% of the original weight. With 94% of original weight, we were able to achieve 114% of the original strength. And this is something which was remarkable, right? And this is how we were able to achieve what we designed for much higher, So again, coming back, I have a couple of minutes more. Just a recap, this discussion was completely on 3 topics only in the first quadrant of design to decarb. So there are multiple things that goes around into those carbon control toolkit that we'll speak later, see later in the later Zak. So today we saw discussion on the U value, air tightness, and material consumption. Most important things that will actually affect our industry here in India. Since I have a little more minutes, maybe I can just speak a little about impact on the embodied carbon emissions. Other ways, just to roughly touch the point. So the shape of the building is also very important for us, which is basically the form factor, it's called. Most of the architects will know this. So the form factor, if you reduce the form factor, the consumption, the material consumption, the facade surface will reduce, the material consumption will get reduced. The influence of the facade elements. So just to give you an example, like if you take a grid size of 1.5 meter by 4 meters versus 3 meters by 4 meters, the grid size, if you increase, the aluminum consumption will go down, right? The limitation lies is whether the system is capable of taking or delivering the same performance in that grid size, right? So we have solutions in Shuko where we can go wider, higher, taller, and so on. So we think from that perspective also, and that will reduce the aluminum consumptions even further, okay? So you can see a graph here depicting the same thing. Then choose the right system solution, systems with lesser materials, type of materials. Of course, this is what I was emphasizing when I was talking about the air section, the air tightness section. In the last, again, if this is the mining part, the A1 from that big Leti graph, the reduction of the embodied carbon directly from the billet itself. You can have standard aluminum, you can have low carbon aluminum, you can have ultra low carbon aluminum. So those are the values that you will get from that. So that's it from my side. Thank you.
Thank Thank you, Kushagra, especially to tell us how we can turn constraints into something positive. Now, next we have a special guest from London, our keynote speaker, who in his own words told me he doesn't need an introduction. I think the name should do it. Yeah, there's Ricardo, all the way from UK, Ricardo Mateu from UHA. So I'll have him take the podium. Ladies and gentlemen, please, a big applause.
I was very short and to the point. Hi, everybody. Is this working? Hi, everybody. Good morning. Good afternoon, even. I'm still on London time. It usually takes me about a week to get used to India time. Unfortunately, I'm leaving tomorrow, so I'll be back on London time again. We're not at the beginning of my presentation. We're about halfway through at the moment, which is interesting. So here you see it all in reverse very quickly. Close your eyes for a couple of seconds, and we'll start in the beginning. First of all, thank you very much to Zak World of Façades for inviting me to Delhi to speak to you, and thank you to our main sponsors, Shuko and Aluplex, for making it all happen. I'm going to show you some projects, obviously. Architects love to prattle on about their projects forever. I'll try and keep it short and sweet, but also I want to talk about partnerships with our clients, partnerships with consultants, and partnerships with our supply chain, the manufacturers who actually make it all happen, okay? Because building is a complex process, as we know, and it really is a partnership at the end of the day that makes it all happen. They are complex things. And without the partnership, you don't have the optimal conditions. You've got to work in tandem with everybody. You've got to coordinate well to get the best possible results. And obviously we're trying to make money on the way, but I think our objective is always to produce the best possible project, the best possible outcome, because at the end of the day, that's what we'll be remembered for, our latest and greatest project. So we're a studio based in London. We're founded in London, but we've sort of spread in an arc across Europe and Asia, as you can see, with India really at the epicenter of that operation. We kind of grew organically across Europe and have specialist studios in different places. I won't go into too much detail on that, other than perhaps to say we have a BIM specialist studio, and we pretty much produce all our projects in BIM these days. We have our own in-house visualization studio, which is based in Budapest, which is a center of excellence for both BIM and for visualization. And of course, we have our Mumbai office, which is our center of operations for India and the wider region. And then we have a couple of Far East offices in Tokyo and Taipei, which are really grown out of the London office, out of guys from the London office going back home. So we're in a kind of bizarre position, really, as a London-based architect with one project in London at the moment. Most UK architects are very UK-centric. In fact, they're very London-centric. We are quite the opposite. We're very international. We've always been that way since the beginning. And we're always looking for new opportunities and new markets. And they may come along as a result of having different people in different places, or through contacts, through engineering contacts, or however it may be. But we do like to explore the far-flung regions of the world. And within that, of course, India is probably our most important market. We started out very early in India, and it's sort of grown from there. These are our target markets at the moment: Greece, Japan, Taiwan, and UK, you can see on there. As I said, we don't have that much going on in the UK. But in Taiwan, we're now doing a couple of projects, a couple of master plan projects. In Japan, we're doing a house. It's only a house, but it's a very beautiful Japanese house, obviously. And in Greece, we have a number of projects coming up, with several projects on site at the moment. And then just talking about our key markets, which I'll come back to again and again during the talk. India, of course, Cyprus, which is the complete opposite, a tiny little island in the Mediterranean, but we've actually done many, many projects there, over 100 projects, and Mexico. They are perhaps for us 3 key markets, the most important markets, and they're very far apart, as you've noticed, so the time zone thing is quite important. Having offices around the world, of course, helps us work almost like a 24-hour studio. We don't currently have representation in Mexico, but if we did, we would be a 24-hour studio. But just to take you back a little bit, we founded in 2011. Before that, I used to work with Norman Foster. I was with Norman Foster for over 18 years and designed and then built the first Foster project in India, which is in Worli, in Mumbai. Then UHA took over that project and at least tried to see it through to its fruition, together with our friends from Aluplex, but didn't quite get there. Nevertheless, we're still quite proud of that project. We set up our office in 2013 in Mumbai, and we've been going strong ever since. Fast forward to 2023, when we celebrated our 10th anniversary in India with a big exhibition here in Delhi at the Stir Gallery. And on the way, obviously, we've picked up a few awards. We've done some very interesting buildings in other parts of the world, and we'll touch on a few of those. So what kind of projects do we do? Well, we do a bit of everything, to be honest. I would say our bread and butter is high-rise residential. This was the first project in India, the 1973 Worli project. But this really shows the range of projects that we're looking at. The next one is the tallest building in Delhi, here in Delhi, the Versace Residencies. And I believe our client will be in the room later. This is a collaboration with the local architect Jampi Mathur, who we've done a lot of projects with. We also do a lot of projects with DFI, with Design Forum International, who you've heard from earlier today. These partnerships are very important to us. And I think the number of projects that we've done with all of these architects is testament, really, to that relationship. Obviously, there are other kinds of projects as well, campus buildings, universities, and some rather bizarre-looking projects, such as the one in the bottom right, which is a tower that leans at 22 degrees. Just to put that into context, the Leaning Tower of Pisa is 8 degrees. This one's 22. It's not just an architectural folly. There's actually a reason behind it. We get all of that deck area free of FSI. So the client's very happy. There's a small addition to pay for the engineering and the structure, but more than paid for by the ticket price for the units, which were exceptionally high, the highest on the island. Along the way, we've designed the largest workspace in the world. This is the interior of a Zaha Hadid-designed building in Moscow. Zaha Hadid won the competition to do the architecture, and then UHA took over the project as executive architect, and also we won the competition for the interiors. So it is actually the second largest building, office building in the world after the Pentagon. It is significantly larger than Apple Campus, which has 12,000 employees. This has 16,000. And we designed everything custom for this building and had to rejig the facade as well quite a lot. Now, I'm a bit old school, obviously. Everything starts with a sketch. My business partner and I, my business partner is a Danish guy called Jonas Upton Hansen. We're both originally from Foster's. He went to the States to work with Murphy Yarn. And we're both kind of old school guys. We do a sketch, but that's very quickly translated into a 3D model. And we use the latest technology, and our 24-hour studio, or almost 24-hour studio, allows us to work on those projects across all of the studios. Very often we're working, the 3 of the studios will be working on the same project at once via the cloud. We we also spend a significant amount of time and effort and energy on new technology, on investigation, on research and development within the studio. So from cardboard models that you see there to augmented reality, we try and do a little bit of everything. And we're obviously exploring AI now in various forms, both as a design tool, and it is really a tool, nothing more than that as yet. There are some doom-mongering architects who suggest that AI is going to take over from us and we're all going to be out of a job soon. I'm slightly more upbeat about that, and I think it's a very useful tool that we can use. So, as I mentioned a little earlier on, it's all about the partnership. That's what brings together a building in a successful way. That's how we develop the buildings that we develop. That's how they end up being quite innovative, quite different. It's not through a war of attrition between designer, client, and contractor. We have to work in harmony to achieve the best results. And some of our partnerships have lasted many years. So we'll look at the three key markets of India, Cyprus, and Mexico, and the differences and the similarities between them. In India, our main markets obviously are Delhi, NCR, and Mumbai, but we've also worked on projects in Pune, in Hyderabad, and Bangalore. And Bangalore and Hyderabad obviously are on an upward trajectory now, so we're heavily involved in those markets and hoping to do some very interesting buildings there. But if we focus in on NCR, there's a huge amount of activity, construction activity going on in NCR right now, as I'm sure everybody in the room is aware. Most of it obviously centered in Gurugram and around the two main highways, the Dwarka Expressway and the Delhi Gurugram Expressway. But I understand that it's very difficult to get any parcels of land now in Delhi and in Gurugram, and they're becoming very expensive. Just to give you an idea of the trajectory of the partnership, let's say, here's one of our most important clients, who I'm pleased to say is represented in the room. And we started working with them in 2011, and we're still working with them today. We have, I think, 3 or 4 current projects with M3M. They're a very adventurous family. They've done a lot of exciting things. We've been along for the ride with them. So here's a little bit the timeline of that relationship, if you like, starting in 2011 with a clubhouse design for the golf estate. Unfortunately, it wasn't realized, but we have realized several projects along the way. And I'm sure some of you are familiar with some of them, and we go all the way to the present day, where we've turned full circle. We've done several residential towers, retail developments, a very large mixed-use master plan, and we've sort of come full circle, and now we're doing clubhouses again for M3M on several of their projects. If we just look at the sectors they're in, we started out with residential projects, residential kind of blended into hospitality, obviously, with the clubhouses. Clubhouse has become the driver, really, of every major residential project now in India, but particularly in the immediate region, where there's a huge competition between developers to have the biggest, the best, the most luxurious. This was all kicked off, obviously, by camellias and the buzz that happened around that project. And now every developer wants their own version. But also we've done some interesting retail concepts with M3M, starting with T Point and Urbana Premium. you'll see some very different types of project, culminating in the latest one, which is more of a plaza type open air experience, which is something quite nice about India. It's not so obsessed with air conditioned spaces. We've done a lot of open air retail as well. Just a quick look at Golf Estate. We've developed a couple of tower projects, delivered a couple of tower projects there. The two that you see in the image. I'm very pleased that St Andrew's Tower actually featured in the Oscar-nominated movie The White Tiger. I don't know if you saw that movie. Fantastic book, made into a really interesting movie, and also Latitude there in the background. And then jumping forward in time to the most recent projects we're doing with M3M, Altitude, which is a clubhouse and a redesign of the project with this amazing crown feature on the top of the building. We're very much about proportions and designing tall structures to look like they're meant to be tall structures. We very much aspire to the idea that a tall building should have a base, it should have a middle, and it should have a crown. It shouldn't be chopped off somewhere in the middle. It shouldn't just end without any kind of defining feature. If you'd like to scan the QR code, you can have a little bit more of an immersive experience looking at the project. I'll keep it up for a couple of seconds. This is where everybody starts ignoring the talk and just looking at the images. And on to another clubhouse project, the Kulinan. This is a really interesting project in that we were given a building that was already designed, a structure that was already defined, and told to fit in quite a large, quite an extensive clubhouse within a string of towers, which, as you can imagine, is extremely complicated. There are columns coming down all over the place. It's services everywhere. And really, we're trying to weave in and out of that and create a space that is very immersive, very green, and sustainable, but also is an experience as soon as you arrive there. So this is actually a circulation space. There's no use for this space other than coming out of the lifts and accessing all of the amenities. But we wanted it to be an experience from the very start. So as soon as the lift doors open, you're into this other world. Obviously quite different to street level in Gurugram. Sorry, Noida. Thank you. These are some more images. This is the circular drum that you see there is the parking ramp, often much maligned structure and very much ignored. So we decided to put the swimming pool on top of the ramp and create a kind of a panoramic feel to it. And you also get these wonderful clear glazed spaces above the ramps for the gymnasium. Okay. Another key client of ours here in the region is Elan, and we started working with Elan back in 2013 also, and have developed a number of retail projects with them, including Miracle, Epic, and several others. So they predominantly focused on retail projects to begin with, and then moved towards the residential sector. This is our first retail project that's delivered here in India, and I think it's delivered to quite a high standard. It is a challenge delivering buildings to the right quality. We have a local team, obviously, but I think part of that challenge can be overcome by working very closely with our clients, first and foremost, but also with the facade consultants and the suppliers who put all these components together. And it's very much, I think, what we need to look for is try and prefabricate as much as possible, build as much as possible under factory conditions before everything comes to site. I remember my first site experience in India, in Mumbai. I was horrified to see a facade being hammered into place, aluminium panels being hammered into place by some guys on site, desperate to get the work finished, all a little bit jugaad. So we try and avoid that, if at all possible, by studying the design from a very early stage, we use a lot of parametric tools, obviously, to rationalize the panels. We are not an architect who will design unique structures where every panel is different. Our clients would kill us if we did that. So we need to try and be sensible about the design whilst creating something distinctive. We're very proud of our in-house visualization department, which is why we have reams and reams of video and visualizations. Onto the presidential, which is our biggest project to date with Elan. It's a series of, I think, 18 towers. There's 1,200 apartments. And of course, it has India's largest clubhouse at its center. It was soft launched earlier in the year to great fanfare. I think very well received by the brokers. The only problem now is we have to design a smaller clubhouse for the first phase. The clubhouse is 18,000 square meters. And again, you can scan the code and get inside the space and have a look around if you want to. So as you can see, it's a very large-scale project. The tower design is quite repetitive. But we're trying to generate, we're trying to fulfill the area requirements, obviously, and maximize that buildable area, but at the same time create a really nice green oasis at the center of the project. And we started on site earlier in the year. And this is one of the most organized building sites I've seen in India. I think something to be proud of by the team. Onto a project here in Delhi itself, in Karol Bagh. This is a project that we've been working on for many years with Jampi Mathur and his team for Unity Group. And it's at the center of the master plan is the Versace residencies. It's a master plan of around 18 towers with the Icon Tower at the center. Now, interestingly, obviously, a lot of Delhi is protected, and it's difficult to build tall buildings in Delhi. Most of the heights are around 15 meters. This is obviously significantly taller. I was very interested to hear a little bit about the history of the Qutub Minar this morning from Goonmeet, and its origins and the detailing that goes into the facade of that piece, because I think there are, although this is a very contemporary example, there are definitely similarities with modern iconic buildings. So moving on to Mumbai, we also have a number of key clients there. Our office is indicated in orange, and we've done a few projects down in Pune as well. Again, it's about relationships. We have a number of projects that we're working on with certain key clients. Here's a little snapshot of some of the projects in Mumbai, starting with the 1973 Worley, which was featured in an earlier presentation, and a number of other projects, all different shapes and sizes, from private houses, very large private houses, to super tall towers. Oh yes, and there's our office in the middle. So these are the sectors, obviously with a heavy bias towards the residential sector, which is where the market has always been in the past 10 years. We've developed a number of office buildings as well. This one in particular for Suntech. These two, in fact, for Suntech. But mostly it's high-rise residential. This is a very interesting little building, much more compact in Pali Hill. So a very high-end neighborhood in the city. And we did a redesign of the facade and all of the common areas and the apartment interiors. We're on site at the moment, again, dealing with different coordination issues, because sometimes builders put columns in the wrong place. But this is all part of the challenge, I think, and we welcome the challenge. We work with them in partnership to get the best possible result. Not all the buildings need to be strange geometries and shout out so loud. Sometimes they can be very calm, framed, timeless buildings that really stand out by their subtlety. And this is a super tall tower that we designed around Mahalakshmi Racecourse. We've tried to do this 3 times now with different developers in different sites dotted around the racecourse. One day, one of them will come off. And this is quite a different project for us on Juhu Beach. Which is a low-rise, let's call it, a low-rise development, 10 stories high next to the private airport. And I can't really say any more about the project. But it's obviously an uber-luxury development with some timber jalis that we probably need to talk to some of you guys about, how to actually engineer it and make it move. But we're hoping that this project will start moving very soon. Changing tack and scale a little bit. I've only got 5 minutes left, so I better hurry up. Cyprus is a tiny island in the Mediterranean. Probably most of you have never been there. But we were invited down by a Russian developer who's lived on the island since he was 15 years old. He started out driving a tour bus for Russian tourists, taking them to the Orthodox Church and back, and turned into the biggest developer on the island. Starting out with a rental company, first of all, getting into property rental, then developing smaller projects. Then he got into more high-end projects and appointed us to do 3 flagship projects. This gives you an idea of the number of projects we've done for this team. And it's, I think along the way, you really become one team. You learn more about the client. You learn how they think. And it really helps the design process. And I think you start to see a design language, particularly in the facades, as to how this is developed over time. I think we got very lucky in the first instance because we started with these 3 projects back in 2017, and they're all very different in feel and size and scale. The first one is called Eden Rock, named after the client's favorite hotel. It's a mid-rise residential building, not on a premium site. So we wanted to make it premium by creating the terraces and creating all these penthouses. It also, the 2 different, the differentiator here really in the types of units are the penthouses on top and the duplex houses, the townhouses down at the bottom. And these are very big ticket sellers. This was not a high budget project, but sold very well. We had initially intended to put solid surface on the white bands, but that was cost prohibitive. So we actually opted for a very simple, a relatively simple render system. But because it's a marine environment, we persuaded our client to get the very best render system he could use, which is a stow render. Because obviously in a marine environment or in an environment like Delhi or Mumbai, the atmosphere is very aggressive, and after one monsoon you would end up with a green facade rather than a nice gleaming white facade. Sky Tower was the second flagship project we developed with this client. He wanted a very specific profile on the horizon so that you could see it from the highway beyond and from the seafront in front. These are very high-end residential projects with all of the amenities that you would expect to find in an Indian development of similar level. So it has a pool, gym, spa, even for such a small project. This was all designed in BIM, and I remember quite a few iterations of this tower where we were pulling in and out the facade ribbons using the grasshopper tools that the gentleman talked about earlier. But it's a fantastic way of optimizing the design. This is all ACP clad. We spent a lot of hours, a lot of man hours looking at the rationalization of the panels, and the delivery is actually really, really good quality. For the three projects, we set up our own project management team. So we were responsible for architecture, interiors, project management, and construction management. We simply could not get a project management team interested in going to Cyprus because they thought the market was too small. And there are now more towers going up in Limassol, the city of Limassol, than anywhere else in Europe. We also brought some innovation with us. Post-tension structures have been around for 30 years or more worldwide, but had never been done on the island, except on the motorways. The local engineer told us that we would kill everybody because it's a seismic zone, and he was very concerned that the building would fall down as soon as it went up. But after numerous presentations to the government, we managed to convince them that this was the way to go. And since then, every major developer on the island has adopted the same. And this is our baby that's just been born. It's just been finished in the last couple of weeks. I'm afraid I don't have any more up-to-date footage than this, so it's still covered in scaffolding, unfortunately, in the movie. But it's just been delivered, and the finish is absolutely fantastic. There's perforated panels at the back, and then the expressed ribs at the front, all in ACP. You can see the distance from the sea there. It's an aggressive marine environment that has to be a long-lasting design. On the other side of the world, we did a number of projects in Mexico back in the day. We took part in a large number of competitions together with a local architect, Juan Pablo Serrano, and did a number of projects both in Mexico City and then in the satellite city of Puebla. Puebla is to Mexico City what Gurugram is to Delhi. Unfortunately, the government in Mexico have seen fit not to allow any building permits for any major development over the past administration. So it's been incredibly difficult to deliver any projects of any scale. So all of these projects designed and went as far as planning, none of them got built. The only one that they're a mix of both residential, this is office, this is very much a mixed-use tower. There's a university building up there. And the only one that we managed to get built was in Puebla. And this was a master plan of 2 residential towers, mixed-use scheme with a hotel, office, and retail component. And we managed to maintain the ancient historic hacienda building at the front, which will become the entrance to the commercial center when it comes online. I'll just whiz through these, because unless you've been on holiday in Mexico, you won't really be that enthusiastic about this. But this is an amazing site. This is the Palace of Fine Arts here. This is Latin America's first skyscraper, the Torre Latinoamerica, built in the early 60s. And there's a couple of big orange towers there, which remind me of some of the stonework here in Delhi, but they're a very famous pair of government buildings by Ricardo Legarreta. And this is the Central Park of Mexico City. So this is a prime site. So you can imagine how hard it is to get planning permission. There's always a historic element to our projects in Mexico. This is the Monument to the Revolution, a very important plaza in the center of the city. And we've taken some of the cues from the geometry and the materials in that amazing monument and brought them into the building. And again, it's quite a calm, refined tower that doesn't shout too much because it's got a very important neighbor that it has to respect. Here's Sadro, which I just spoke about. So one of the towers is built. This is an amazing city ringed by 3 volcanoes. One of them is still active, called Popocatépetl. And we took our cue for the design from the skyline of the city, hence the angled top to the towers. And some of the materials used also, the paving around the site is basalt stone, which is generated from the volcano, from the volcanic lava. It is, of course, Mexico's first LEED residential building, which we're very proud of. I think it's Latin America's first LEED residential. So just to recap, our key markets, again, India very much at the forefront. It's not number 1 for no reason. Number 2, Cyprus, tiny in scale, but a phenomenal amount of work going on there. And Mexico City, which has a very rich heritage that we like to work with and generate iconic buildings. So what's next? What's next for UHA? What's next for India? India is obviously on a massive upward trajectory at the moment. We're very pleased that we've been here already 10 years. We've been around the block. We understand Vastu, finally. It's been a challenge. And we're looking further north, further south, sorry, to Pune, to Hyderabad, to Bangalore. We have our first projects now in both Hyderabad and Bangalore, and we're hoping to exploit that and do more work. In terms of type of work, again, we haven't done a lot of workspace yet. We're very keen to do some more workspace projects with a number of our clients. The clubhouses, I'm sure, is an endless stream of work that's going to keep coming for years to come. We've tried and failed to do villa master plans in India, but I think one will come very soon if I can manage to get to the north on a flight that's actually flying. I've tried many times to get a flight up north, and they've always cancelled because of the weather. And also, I think another important thread of our work is the experience of it all, and particularly related to retail. Retail is part of our culture these days, worldwide, particularly so here. And we want to try and create different spaces that are exciting to go and visit, because it's not just about the shopping anymore. We design for different climates. Obviously, we've designed for many different climates, from the extreme cold to the monsoon to the desert. And sustainability is a very important driver for our firm. So we have our own in-house sustainability consultancy called Habitera, which informs all of the projects from the start. What do I mean by that? Well, it's quite a hard sell to commercial developers here in India when you talk about sustainability and LEED. It is taking shape now, it is taking root, I think. But the first question is always, how much is it going to cost me? And I think the answer to that is, well, nothing, if you think about it from the beginning. and let's think about the passive measures we can introduce. Let's think about the orientation of the building. Let's think about the treatment of the facades before we get anywhere near site. And let's not bother bolting on solar panels and expensive movable shades until it's really necessary. All of those add-ons are important, but I think we need to get the form of our building right. We need to get the orientation of our building right before we think about any of that other peripheral stuff. We can get into the dynamics of the facade and the performance of the facade, all of which is important, of course, but it all leads to the summit. And at the bottom, you've got the lowest hanging fruit is that first concept sketch. Which way should our building be facing? Where does the wind come from? And I think here in Delhi, there is a very good opportunity, pollution notwithstanding the pollution that is here, to naturally ventilate buildings for a significant part of the year. There needs to be some industry push, some government push towards cleaning the air. And I know it's a problem with farming as well as construction. But I find it incredible that construction stops for several days in the year, weeks, due to pollution, and the farmers keep on burning. Yeah, that's obviously a very big political hot potato rather than anything else. But I think there are things we can do to clean the air up, to certainly create more of a microclimate around our projects. And we are trying to develop a series of hybrid clubhouses that are part outdoor, part indoor. There is some reticence at the moment because of the particularly bad pollution we've had over the past few months, which I've experienced in 3 visits here since November of last year. But hopefully things will get better. And I'll finish with a very short video that's very up-tempo and will wake you all up again. Thank you. Thank you very much.
Sure. Thank you, Ricardo, for that lovely, lovely presentation. More than immersive, I think it was nice to see the range of projects, mainly not just because of the scale and the variation in scale, but I think in each one there was immense sort of attention to detail and context. And I think both these things are very vital as we move ahead and understand design, especially facades, because someone wisely said, facades speak. Now, I'd like to invite our guests for the panel discussion, and of course, Mr. Srinivas Hoysal, who is the head of facades at DLF, to then come and up on stage and then introduce our panelists. Please. Thank you, and a round of applause for him, please.
Thank you so much, Ms. Suparna, for a wonderful introduction. And I would like to introduce our panelists for this discussion. Mr. Prashant Mahajan is the Vice President, Design and Projects from RSP. And we have Ms. Nikita Mehta, Principal from NM Corp. We have Ms. Shaun Sengupta, Director, Edifice Consultants. we have Miss Anupama Sharma, industry professional. And we have Mr. Madhur Goyal, senior architect, Mart McDonald. We welcome you all for this panel discussion on the challenges in designing high-rise buildings and glazed curtain wall. Generally, we have a few questions. Why high-rise glazed buildings? I think we have got a rapid urbanization going on, and people are finding some employment opportunities. And then, of course, land is very scarce. And, then again, there is a optimized, utilities or the services. We go with the high-rise, less of roads and less of the services, maybe that. Or it is also giving us a very good revenue in terms of, let me give you an example, like Mumbai Municipal Corporation. It has got the, the budget of Goa and Sikkim put together. So there are many opportunities. So, and also the recent trend is now, after this pandemic, we learned that the homes are getting much bigger, and then, people want to work from home, and they want to keep it as their office as too. So therefore, there are multiple opportunities in going high-rise. So that's why even I just want Mr. Prashant to elaborate on this.
Yeah, firstly, it's an absolute pleasure to be here, and thank you so much, Mr. Srinivas, and the entire Facade, team here. So I think you've really touched on some of the reasons why high-rise is really the way forward, and I think one of the last presentations we saw from UHA sort of exemplify how that is not just happening in extremely urban conditions, but also beginning to happen on islands like Cyprus, which was quite an eye-opener, Ricardo. So that was interesting. But yeah, I think you're absolutely right. It is urbanization. It is land scarcity to begin with. And it is also the demand for that growth to really sort of push for taller buildings. And revenue cannot be divorced, because ultimately it is really your business case and your client's vision which determines how a building that tall can actually be realized. I do remember seeing a graphic years ago when I was in the Middle East, and somebody showed it to me and said that every time there's been a financial crisis anywhere in the globe, there is, the tallest building in the world under construction or nearly finished somewhere being built. So maybe there is something to do with money and revenue and with tall buildings. But yeah, I think the trend is now generally across sector. We at RSP are noticing that trend, not just in India, but also in Middle East and Southeast Asia. It is something which is by far, quite frankly, it's, it's something which is consistent, especially in the years after COVID. We are seeing a lot of high-rise residential projects coming in the space, which was not the case earlier. Some of it is also, I think, the market drivers and policy, right? I mean, Anupama and a few others on our panel will, I'm sure, talk about that a lot more. But I can speak from Gurgaon, particularly where we're working a lot, where TOD and TDR to actually bring in more FSI, which is purchasable, gives you the ability to actually bring more space into such buildings. So that actually pushes, if you've got limitation of size, it actually then by default sort of brings you into an urban scale which is more and more taller. And it's coupled with the fact that the height restrictions are being relaxed tremendously, although we've got proximity to airport. Some of the tallest buildings we are doing right now are breaching 150 meters, which is not something we were seeing previously, in the years before COVID. So I think some of these things I thought were interesting to sort of answer that point.
Yeah. And also, once we go with the high-rise buildings, basically, we have got this building movements that need to be addressed because tall buildings always have got a tendency to sway. And then, is it because maybe the glazing systems can accommodate more of these movements in the building? Or is it speed of construction? Like, we have this, when we go for a tall buildings, the speed of construction is very important because one after the other floors can go on. And then also the prefabricated construction, because the glazing, unitized glazing system has got a prefabricated, most of it is all prefabricated. And is it because of this, or what do you feel, Ms. Anupama Sharma?
Can you hear me? Yeah, I think. All right. Well, firstly, thank you, Mr. Srinivas, for having us here. Thank you, Zak. It's a pleasure to be here. To answer that question, I think I will first talk about what a curtain wall system really is. So, essentially, curtain wall systems, as we all know, these are protective coverings for high-rise structures. And pretty much like the skin of our bodies, they sort of cover and protect what is within these structures. Now, what's interesting is that the curtain wall system or the facade system of these high-rise structures are the one element of the building that is most highly abused, right? They're exposed to weathering, they're exposed to degradation, they're exposed to wind, they're exposed to multiple other types of forces such as seismic and gravity, etc., also debris. And therefore, they need to be designed with utmost care, designed to be resilient systems. So what are the three most important factors that we need to consider while designing these systems? One is, of course, structural integrity. Second is provision for movement, which is what Srinivas was just talking about. And the third is weather tightness. Provision for movement becomes really critical in designing these systems, facade systems and glazing systems, primarily because buildings and structures are not static, right? These are not static structures. These are constantly in motion. Not only are the components within the building constantly moving, but also, like I mentioned earlier, these buildings are subject to different types of forces, wind forces, seismic forces, gravity forces, etc. And when the building moves, obviously the curtain wall system also moves with it. And it needs to be designed to be able to withstand these multiple different forces that are constantly acting on the building. So what that means is that the facade system or the curtain wall system, the joints and the details of the system, of the framework, needs to be designed to withstand these forces. If attention to detail is not given in the design of the joints, what happens is that stress is induced at the joints of these systems, and the stresses induced typically will lead to calculated deformation. Now, the combination of the stress and the deformation will withstand the forces that are applied to it to some degree, but there will come a point of failure where the systems will fail, which is why we need to design, pay attention to the designing of the details. So it's almost axiomatic to say that a well-functioning curtain wall system is really dependent on the design of the details and the joints. Speed of construction, these are modular systems, and the reason curtain wall systems are used for high-rise structures is because they enable speedy construction. So these can be prefabricated in a factory. For example, unitized systems are prefabricated in factory, controlled factory environments, something that I think Mateu was talking about just a little while ago, that to control quality. They can come prefabricated, and because of the modularity, the modular nature of these systems, they can be very easily installed, and they enhance the speed of construction. So therefore, very, very useful for high-rise structures. And also for larger scale projects, typically commercial projects, larger scale projects tend to use these systems for their speediness in construction.
Okay. One thing that comes to our mind is, we are using a lot of glazed facades for these high-rise buildings. How do we make glazed high-rise buildings more sustainable? Ms. Sean Gupta.
Hello and good afternoon, and thank you for whoever is here listening to all of us. Thank you. See, the raging debate here is that do we make high-rises? Do we make high-rises glazed? Do we make, urban development which is high-rise or low-rise or whatever it is? But the fact of the matter is India has surpassed China recently as being the most populated country in the world. So one of the ways that we can counter this rise of population is by densifying. And we have only that X amount of land available with us. And within that X amount of land, there is a certain percentage of land which has the infrastructure to take a certain kind of development that we require. So it kind of becomes imperative that at least in the urban city format, we make high-rises, right? Now, when we do make high-rises, obviously boxing them up, making an opaque facade is not something which one would make sustainable, right? So you do need light, you do need ventilation, you need your circadian rhythm to run to see the sunrise and sunset. So it is imperative we do have high-rises in a population-driven country as India. B, we will need to have glazed facade systems. We can, of course, optimize them. We can decide which direction to have more glazing, which direction to not have glazing. Actually, we've recently completed a very interesting project for the Ministry of New and Renewable Energy. It's actually India's first and only LEED Platinum 4.1 version rated plus Griha 5-star rated building. So when we were, and it's also designed to be a net zero, we designed it to be net positive. So when we started off with the building, like Ricardo just mentioned, that when you start from the beginning, when you start thinking about orientation, when you start thinking about wind directions, etc. and so forth, you can optimize the glazing. So in this particular building, why I brought this up is that we have 3 sides completely opaque and the eastern side completely glazed. So, and luckily we do have the building in a very sliver format where we were able to make the width of the building such that only the eastern glass was able to completely bring the natural light to the end of the flow plate. So these are optimizations that you need to do. So it's not a yes or no kind of an answer where do we need glazing, do we need glazed facade or not. The answer is yes and no, but optimization and the correct usage is the key.
Thank you. What are the key design considerations in architectural planning when you have a glazed curtain wall as exterior wall?
Hello. Good afternoon, everybody. So, when the first thing, as everybody is saying here, that right at the beginning, you have to have all the considerations in terms of planning. Throughout the conference since morning, people have been talking about facade, what you do with the glass, different kind of systems. But one very important factor here is also the architectural planning and the interior layouts. Because in India, in a tropical zone, when you're bringing in a lot of glass, it also comes with a lot of problems, which we as architects need to first understand. Now, when we are talking, let's say, for a residential planning, based on the bylaws that we have here as well as in Bombay and in NBC, we do have certain ventilation requirements that are mandated for toilets, for kitchen, and so on. At the same time, we would always want the living rooms and the bedrooms to have great views, ample natural light, and yet at the same time have privacy. So one of the first thing that comes into picture is the way you orient your overall building, that the way you orient the tower itself, it should either be facing north so that you have minimum heat gain during the day. The second important factor is the way we plan balconies. Now, what happens is that if you look at most of the buildings in Bombay in last 10 years, where fungible has now come into picture, we don't do balconies anymore in most of the buildings in Bombay so that you can get maximum area for within the apartment itself. In that case, when you do not have a balcony and you want to do a glazed system, it becomes very important what kind of window are you going to bring into picture. Are you going to do an entire sliding folding which opens inside and you still have a railing? Something that Rohan had showed for one of the Rustomji buildings in Bombay. Do you do something what I think you did for Lodha Park, where you have casement windows that open, but because you are going all the way to 72 floors, 78 floors, they open just about 30 degrees there, which will still give you enough ventilation without doing any kind of damage to children falling out or, like any kind of casualties in that manner. And then obviously there are other considerations that when I'm sitting inside a living room or in a bedroom, I do not see a whole cage of mullions and transoms all over, and how we have to design those looking at also the inside functionality of those rooms. So all these together come into play at different places. And also for all the glazed residential buildings, all the toilets then become mechanically ventilated, which will then change the way the building services work for the whole building. So I think all these architectural aspects also have to be thought right from the beginning, other than just looking at it from the outside.
Now, as regards to this building facade is concerned, especially on the glazing, what sort of a material we need to use in terms of, to avoid anything like the fire point of view?
So in terms of materials, definitely curtain wall system gives us the option or the advantage to add the insulation to the building. So that is, I believe, the very important or the opportunity for a building to get insulated is through curtain glaze system, either unitized or any other system that we use. So the glass, the aluminium, the fire stops that we need to use. So these are very important materials that as an architect, while we are designing the facade or doing the interior planning, we need to understand that all these have to play together, create an engineering component, and it has to work together all way. If we want to have the mechanical ventilation system or natural ventilation system, we want to keep in acknowledgement of how we control the ventilation, what are the instruments that we use. It is not only the material. Beyond material, we can look into the factors of the pressurization or depressurization. So because of these challenges, depressurization, fire, safety, the energy efficiency, there are a lot of materials that come into play which will be related to the facade. And the materials coming together to make the facade.
Okay, thank you. Prashant, we just wanted to understand, nowadays, the balcony is required, in most of the buildings. But then when we go to the high-rise buildings, is the balcony really required, or if it is required, is it safer, or how do we address, the balcony loads? And then, we have this gardening, we need to have a garden as well. And then how do we have all these things? And now in Mumbai, because of the FSI issue, we have many buildings where there are no balconies. So So I just want to, information from your end. What do you think about the balconies in a high rise?
Sure. I think this is a very interesting part of the dialogue, and just picking up from where Nikita and you sort of touched it. So you've got Mumbai, and then on the other side of the spectrum, we've got a project in Noida, where the very first requirement from the client, I wouldn't really call it a very tall building, but it's been recently launched, Estate 128 by Max Estates, where the Max chairman's requirement were to have a balcony which was 3 meters deep, right? So I think safety, certainly performance and materiality, but now what we're really hearing is lifestyle, right? So I don't think it's uncommon to even see some of the deep set recesses coming in some of the high rises, even in Mumbai, but I do appreciate it comes in at a huge cost because it is not FSI, which is where I'm putting it in the last bucket. But if you went in strictly by safety and guideline, the NBC of India directs you that as an architect, you should not be designing a balcony with a railing which is, or parapet which is less than 1 meter height. You should not go more than 1200 mm high. I don't know why we said not more than 1200, but it says that. And then you've got the local codes, which then say, for example, in Gurgaon, that if you've got a building which was 15 meter high, you could do a parapet which was 1 meter. But then if you went with a building which was more than 15 meter height, you should have a building with a parapet which was 1200 mm or more. So that's what the law says. But what happens with safety? What happens with materiality? And what happens with the client's aspirations? On an average, we are finding 1150, and I'm going to throw in materiality. This ties into some of the imagery which Ricardo was showing from UHA's work. We are also working with them on the presidential as the executive architects. So I think some of it gets tied into how you see the building facade and these elements sort of tying in. As you go taller and taller, and I'm talking about more than 60 meters, there is a lot of performance orientation which has to be kept into mind, like what Anupama was talking about. We are seeing a lot of advent of glass. We are seeing a lot of new generation cladding materials, which are either agglomerate or factory-made and modular. As you go taller, it's not just wind pressure, it's also how you detail them out and integrate them onto the facade. That becomes a massive challenge, right? So the gaps between panels, especially if you're using them in balconies, need to get tighter and tighter. If you're using glass, we actually have details where we are literally going with 0 gaps, which may or may not be how you would detail out a building which was below 60 meters. And as you went higher and higher, the height of the railing is now increasing. Some of it is safety, not just codal compliance, but it's also safety in terms of, just a psychological human factor. You are on a 50th floor of a tall skyscraper, and one of my colleagues just traveled with DLF, to see some of the projects in New York City done by another architect they wanted to work with. And that particular building faces the Central Park, and it's like 100 floors high. And this was probably on the 80th floor or something. And people were really feeling weak in the knees just coming close to the curtain wall. And they have a balcony which looks out at Central Park. And I don't think the parapet was more than 1100 high. Over here in our projects, anything beyond 30 floors, we are going on an average 1150 to maybe 1350. There are projects which are even taller than that. We are looking at about 1500 mm. 1500 mm, by the way, is like eye level, which is pretty tall. So I think some of it is also driven by the desire for safety and lifestyle. You don't want to do a deck, which then appears like a 6-foot balcony. If the client's desire was to really have a 3-meter balcony, it was really from a mindset that you're actually utilizing the better part of the year, the better part of the season, rainy season, in the winter, where you would get shade, and you can actually enjoy semi-outdoors, in an apartment condition. So it's a very interesting dynamic at play. And we are seeing this across commercial buildings. We don't see so much of the use of balconies, but yes, sometimes it becomes mandatory as you start to develop the form, the building cascades up. It could be setbacks, it could be height controls, it could be form, which determine that. And then you end up with a combination of terraces and balconies coming into play. One of the buildings we are doing with you for DLF have a triple height terrace which faces dead west. And the challenge was, how do you actually design something which is going to give comfort and shade and autonomy in terms of utilization for the tenant. So it was interesting to see how such spaces then become energized, not just regular balconies or terraces really, but becoming more meaningful even in commercial projects.
How do wind studies and thermal analysis and daylight analysis, fire studies and the acoustic studies at the beginning of the project, at the concept stage, impact high-rise glazed buildings? Can you please elaborate?
Before I go there, though, I just wanted to say what Prashant was talking about, buildings wanting, developers wanting 3 feet deep balconies, trend set by DLF. DLF was obviously, has set the mandate and has set the standard and the threshold in the micro market. And a lot is driven by lifestyle issues and, wellness issues, etc., especially after COVID. So, yeah, interesting. So coming to your question, Srinivas, wind, fire, these two aspects are really driven by structural integrity and life safety issues, whereas thermal comfort, acoustics, and daylighting really stem from indoor environmental quality issues. But before I touch upon these, what I really wanted to summarize what we've been talking about all morning is, why do we use curtain wall systems? Why curtain wall systems? So essentially, curtain wall systems bring, modern, allow the ability to design modern and sleek facades for our tall structures. They are modular, so they enable speed of construction. They go up really fast. They allow daylight penetration into the interiors, without. So they cut down the reliance on energy, mechanical, lighting systems, etc. Because they are modular, they don't add structural load to the high-rise structures. They enable use of energy-efficient materials and smart technologies, and also they can be engineered to withstand multiple different types of building movements, including wind loads. So coming to wind, wind is a very critical aspect of facade design, especially for high-rise structures. Wind is a very sort of a dynamic force that acts on a building and needs to be taken very seriously. Now, depending on the location of the building, any building would be subject to different kind of wind forces depending on where it is, also depending on the shape of the territory it sits in, the shape and location of the neighboring buildings around it. So all of these factors, along with the actual nature, speed, and direction of wind, have an impact on the building facade. And all of these factors need to be considered when you're designing facade for tall structures. Wind, the force is very dynamic. When it acts on the surface, any surface of a building, it actually puts that facade into, it causes it to stretch. So the windward side of that building will stretch, whereas the leeward side will sort of go into compression. So what happens is a tall structure, when it's subjected to wind pressure, sort of acts, it sort of bends like a cantilever. And the forces that are acting on the building and acting on the facade really need to be analyzed and properly analyzed and designed for. Otherwise, it can be really detrimental because wind can cause a lot of damage to buildings in terms of fatigue effects and aerodynamic effects and debris impacts and things like that. So there are tests available, that we typically rely on when we're designing high-rise structures, and these include wind tunnel testing, aerodynamic tests, as well as computational fluid testing, etc. That will help us, ascertain what are the pressures, the wind forces that are acting on the building, and how to really design for them. And these will determine the type of system to be used, the thickness of the facade, the glazing, the mullions, the attachment details, joinery details, and all of that. So wind is really important. Another important, very, very critical element is fire. Fire is directly linked to life safety. And of course, in the West, life safety issues are taken very, very seriously. I think in the Indian context, it is now, there's a growing awareness for these issues now, not so much in the past. But fire is very, very critical, and buildings need to be designed for fire, especially tall buildings. Reason being that when there's a fire at the bottom of a high-rise, the really high temperature will cause the fire and smoke to rise up the facade very, very rapidly. And what happens is people that are on the upper floors will get trapped, and it's very difficult to rescue them. So one has to take into consideration aspects of fire life safety. Now, the National Building Code and other codes, for example, are mandating certain features during design that need to be incorporated, including aspects like fire tower, fire shaft, fireman's lift, sprinklers, smoke detectors, PA system, all of these, which now all high-rise tall structures have to sort of incorporate in the design. But I think as architects and designers, we need to go a little bit beyond that, and we need to look at materiality, right? So what materials are we using for the building facade system? And we should really be focusing on using non-combustible materials. And amongst these, one very key element of materiality is fire-rated glass. I think we don't use it often enough, but fire-rated glass will help significantly in mitigating spread of fire, smoke, radiant heat, and will also maintain transparency and allow natural light to come in, even in a fire event, which will really help people escape out of a building. So very important, some of these aspects. Coming to thermal comfort, lighting, daylighting, and acoustics, I mean, these comprise aspects of indoor environmental quality. And as we all know, all green buildings and green rating systems place a lot of emphasis on indoor environmental quality. So two aspects I think we need to consider while designing these buildings. One is design parameters. And I think we touched upon it a little bit earlier. Looking at glazed balconies versus unglazed balconies. If we have glazed balconies, what is the type of glazing that we're using in the balconies? And then the window to wall ratio, right? So when your window to wall ratio is really high, you end up with a lot of heat gain on the inside of the building, and that's not really conducive to your energy coefficients and things like that. The other aspect we need to look at is high performance glass, right? Yeah. So again, high performance glass does tend to get cost prohibitive. I mean, it does get expensive, but it is so very crucial to designing tall structures and curtain wall systems. So high performance glass will include all kinds of different options, such as double glaze units, triple glaze units, gas filled glass units, insulated glass units, low emissivity glass, sun controlled glazing, things like that, which again we don't use as often as we should in the Indian context, because they do become cost prohibitive. They get value engineered out at some stage of the design cycle, which unfortunate, but yeah, some things that we need to keep in mind.
Thank you. Well, the factors influencing the ventilation and the air movement in high rise, now especially the wind direction and the speed and the differential temperature, like the stack effect, what we have in this. And how do we design these perforations in these building facades? And how about the changing, the climate and the pollution, especially in NCR? What do you have?
So wind and high rises is synonymous. So high-rise design is kind of mandated through the wind analysis. So what is the shape of the building? Where are the perforations? What is the kind of glass? What are you doing with the wind in and around the building? So because it's not only about the building itself. What happens is that when you are stopping the natural flow of the wind in that area, it is disturbing the microclimate. So one is that what does wind do to the building itself and the people who are inhabitants or users of the building? The other issue is what happens to the people who are outside of the building. So when you have high rises all around in a certain vicinity, you create pockets where there is no natural airflow. You create polluted hotspots, So it is important when you're building a building, you are sensitive to the microclimate of that area and you're not thinking only about the building. A lot of research, a lot of technology, everything has been kind of concentrated on the building that you're building. But what happens to the pedestrian level people in and around the building? So that sensitivity needs to be brought in. The other thing is that when you are designing the shape of the building, and I always keep going back to the shape of the building because a lot of designing starts with, the orientation and the shape of the building. Later on, retrofitting, putting in design, details, expensive elements, mechanical stuff, all of that is plus, 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 plus. But many questions are answered by the orientation and the shape of the building. One example is, the Gherkin in London. So if you see the way the building is, designed, it gives you a spherical shape. So the wind can just pass by the building and it's not really affecting either the building or creating stresses on the building. And it is not spoiling the microclimate of the area around as well. So what we typically do is that we make a wrong building, a wrong design, we create a problem for ourselves and then mechanically try to resolve it. Okay, so that is something which needs to be avoided by facade designers, building designers, master planners. That is important. Coming to, the design of what wind does to building facades, there are, of course, multiple methodologies of creating openings to kind of breezeways, etc. can also be created. So not always can you make a circular or a spherical building. You do need to make large wall kind of buildings. You'll see these residential complexes which are like large, huge walls. We make large IT buildings, even RSP does that, which are, you have to meet the FSI requirements, you have to meet, so for example, a TCS comes and tells us that I need 10,000 employees in this area, okay, so you have to go high, you have to create that wall of the building, you have to look at efficiencies. Then what do? You start making punctures, you do wind analysis, you create breezeways that make the building breathe. It may not be the interior of the building, but as a larger microclimate. So there are multiple, you could go on for a whole day telling what are the 100 measures to deal with it. But one has to design sensitively is all I can say before you start bringing in costly, expensive measures to try to resolve the problems that you've created. That's all I can say.
Okay. Now how do we address this ventilation in case of a fire? Is it smoke vents or plus this automated fire access comes smoke vents and with actuators integrated with building automation system? Is that the way forward?
See, all these are very viable in an office building. So, for example, when I was doing Geo World Center's office tower, we did have ventilators which were automated, and in fact, even in the public areas they were. But at the same time, when you come to residences, it's not possible to spend that kind of money on creating this entire set of ventilators. So that's why if you'll see, in any of the residential buildings which are glazed, we do not have any smoke vents. Instead of that, this is a hybrid approach where we are either giving every bedroom, every living room has sprinklers. The ventilation and the exhaust system is what we are trying to address through the actual windows, where we are trying to say that, let's say the 5% of the floor area becomes the size of the windows, which will then cater for exhaust systems as well. And then it's obviously the fire compartmentalization is a very important thing. And this just brings to the fact that, like you were saying, that why can't we have like fire rated glass? So when I was designing some of these buildings, the only possibility was a fire-rated glass, but it was so expensive, it was 3 times the cost, that it was not feasible. And when we are talking of much larger areas in terms of a building, it is not still an economically viable solution. So we developed a very hybrid concept, again referring back to NFPA rules in US and IBC, where we started doing a water curtain right outside that glass, that in the event that if it really reaches the maximum temperature and the glass breaks, then the water curtain will start acting as a sprinkler does in a normal case, and that way it could mitigate the fire kind of situations. And this was acceptable finally with the CFO also after a lot of deliberation. So I think we need to use the technology, but then make it viable for the factors that we have in India, and especially the economic part of it, which we cannot let go. So these were some of the ways that we could address the fire part.
Now, in this high-rise building is operable sliding window or a door in a glazed curtain wall. Is it a viable option or any other alternatives?
Yes, it is viable. Like we were looking at the presentation today morning, there are already systems in place that we have seen, that there are sliding systems. There are swing options which are there, which is not more than 300 mm from the face. So definitely there are multiple opening options that are there in the industry now. Balconies, which gives us the option of putting the indoor-outdoor opportunity in the buildings. So yes, with that.
Now coming back to this pros and cons of using high-performance glass, especially in a residential high-rise without a central air conditioning system. When and why is it required to have a high-performance glass in high-rise? How do we select this performance glass? What is the basis? And do we have any set performance parameters range, like, for the thermal, visual, and aesthetics and acoustics?
Yeah, I think some of us have already touched on this, but yeah, here are the 4 buckets: functionality, technology, sustainability, and aesthetics. Vision, light, and privacy, they are all intermeshed. You've got to find a balance, right? You want to reduce glare, but you want to get maximum natural light inside. Material, cost, and safety will go into the bucket of technology, because that's where you need to make a decision on what sort of a system you're going to use. If it's an extremely high-rise building, then obviously the system design goes through all of these things, which Anupama and the rest of you have touched on. Sustainability is really, ultimately it's not just the cost, and the embodied energy. It's also the comfort and minimizing the utilization of, these mechanical systems and other things which need to come into play. So I think it needs to be balanced on that. And of course, the decision to decide where should you actually be utilizing performance glass, high performance glass, needs to be studied in great detail at the concept and the schematic stage. And we are finding that in most projects, most Class A clients, and not just Class A clients, but across the board, across the industry, the level of awareness and the attempt to actually spend time, invest time to determine where should you actually be utilizing that glass is becoming more and more evident. Which means the studies, the softwares, the good old-fashioned, by first principle design parameters, figuring out how the sun is moving, the wind is blowing, deciding how much of daylight autonomy you are actually getting by just passive measures. How do you orient your building? Is that the right way to do it? If you were to sort of shift things around, does it really improve that? Does it limit the perimeter in such a way that you can actually have a balance between high performance glass and areas where you can actually minimize the use of high performance glass, because it comes at a huge cost to the project. So I think these are some of the things which come into play. And the last point is really the shading coefficient, the visual light transmission, the U value. I think the Shuko gentleman talked about that in great depth. VLT and obviously the thermal comfort need to be balanced. These are the parameters where architects are spending more and more time while recommending the selection of glazing, not just in terms of color or aesthetic or reflectance, but also in terms of balance of what these factors will actually do to bring in all of these aspects into the building design. And eventually, that's what is going to be real value for either tenants or owners at the end of the day, because it just makes it so much more easier to utilize the building, so much more comfortable, and less maybe dependent on mechanical measures if it's done properly.
Yeah, we had a few more questions, but because of the time constraint, we'll have this last question. How do you control the security and privacy in a fully glazed building?
We are out of time, but the thing is that in a fully glazed building, security, privacy is an issue, and we must pre-plan the entire building in a manner that, so we've had incidents where, you've had things flying into a glazing system, windows breaking. You've had in international, very well designed buildings where glazing windows have broken and fallen off on vehicles below and stuff like that. So, glazed buildings in high rises is a extremely high technology oriented output, and you can't do it unless you really know your work. You can't do it by bringing in third party advisors who are not committed and have their skin into the project. You need a project team who are invested with their own, like I said, skin into the project. Only then can you bring in the necessary safety measures into the building. The technology is there. The things that are the do's and don'ts are very readily, easily available. It is up to the team to bring it forward and then get it implemented. We as designers, we can design it, but we do need the other stakeholders, the project managers, the developers themselves, the investors to sing the same song along with us and make the implementation more robust. And that's how we make the building safe.
And just to add to what you're saying, a very important aspect, like we all have been talking about glass buildings. One thing that happens in India is that whether we make a glass building or a concrete building, we just don't maintain it. And I think one of the biggest plight of no matter how beautiful architecture any one of us designs is the maintenance. And at the end of this, if the buildings are not maintained, you don't have a proper BMU, then we'll just end up with a city with glass carcasses or even worse. So I think we should also lay a lot of stress on maintaining the buildings after they are designed and executed. And I know we are super late and everybody's very hungry, so we'll try to cut it short. Thank you.
Thank you all the panelists for a wonderful discussion.
Thank you. Thank you so much.
Thank you, everybody. And if you could break for a short lunch in the paucity of time, we'd like you back as soon as you've had what they say is a quick bite. Thank you.
Thank you, Shraddha, for being persistent. So I'm finally doing this one. So I'm sure most of the discussions has been around high rises and glass and the performances of glass. So I'm actually going to talk about something very different. It might be interesting to you all, could end up being boring, I don't know, but that's the kind of work we do, and we feel that's our process, and that's what guides our process, some of the values. So for us, and when this opportunity came up, we we realize that even through facades, the kind of work we do, it kind of relates. So for us, whether it's a project and now to oversee how even our final facades are or how our exterior expressions are, even climatically, culturally, locally, like we keep on taking these influences. And I think whether it's the inside of the building or outside of the building, there is a kind of relationship between these aspects. So for example, if you are in Kerala, that's the kind of lifestyle you have. It's well ventilated buildings, homes, that's the kind of food, that's the kind of costumes you wear. And you could be high up in the hills, which again responds to that region. And similarly, you could be in deep in the desert. So actually, India as a context, geographically, climatically, textile-wise, craft, they just have multiple regions and multiple zones. So for us, relating it to the context and then creating a meaning is our process. So it's not about just one static output which can be relevant anywhere. It has to be informed by the demographic, by the climate you are in. So, and yes, of course, as everybody is talking, there's a huge amount of globalization. So we are really being smitten over what's happening. And of course, and this has happened to us. We've been to projects in government and we've been asked that, okay, can we get a glass box like this? Can I get the gherkin from London? So it's actually the way it has been. It is becoming homogeneous. There is no identity. So the idea is that how you can create that identity, regional identity through the facade, because that's the first touch point of a building. Yes, there can be multiple layering of the project, multiple detailing of the project, but this is the first touch point when you really see the building in that city. So the idea is that how does the building relates to the city which you are in and make it part of the city. And more we see Gurgaon, we see all these buildings. We've been adding air conditioning, creating curtain glazings. And of course, yes, there have been discussion on the performances of it. I'm sure these being resolved also. But for us in the conditions like India and the conditions like Delhi, what is that kind of facade we really need versus really adding to the temperature, really adding to the air conditioning inside. So there has been some traditional wisdom which has been there relevant, and how we can still pick it up from there, even to resolve, I would say, buildings of today's time, and I would say even large-scale buildings. I'll show you some of our projects. So what could be the other ways of addressing our future? And these are the questions we typically ask whenever we end up doing a project. And actually I realize even if we end up doing the expression of the building, the facade of the building, these questions are still relevant to us. So for us, how can you create a timeless building? How can a building endure itself? I was hearing the last panel, how can it be a robust building, for example, endures well? How we can even make the building or the facade luxurious? And can it still be aspirational and not being a glass building, for example? How can we really fuse the practice of craft, which India has it in abundance? How can we still infuse it? How can we give work to a craftsman who work by hand? So how can we get that touch of hand into our facades of the building? How can we be frugal about it? Can we do more with less? So yes, technology is there, but how can we still be frugal about the technology? How can we low tech? And in low tech, can it still be inspirational? Can it still be luxurious? What I was talking earlier. And have projects where we've done adaptive reuse. So rather than breaking down the building, we feel the building which exists is the greenest of all, and actually we can still do a very important job out of it. So adaptive reuse of the buildings, of the facades, I would say. And still, while doing all this, how can we create magic into our projects, into the buildings we do? I'll take these quick examples. This is the headquarters of BGD in Bhubaneswar, where again, while working with the principles of deep recessed windows, of deeply recessed shaded areas, which a weather like Bhubaneswar needs, the regional identity comes through the interpretation of the Puri temples and the crafting of those graphic onto the facade of the building on the soft stone like laterite really gives it a very regional character to its place. So this is creating a little bit of a delight, a visual delight into the building, otherwise being very static, mundane facade. So that was our relationship to this particular building. So you can see the amount of work done into this particular facade. And even very small projects. I'm just picking up as an example, a home we all in Delhi, this is any neighborhood of Delhi, there are homes around. How can still the facade, while adding thermal mass is one part, but while doing that object, how can we still create a little oasis within a tight footprint area? So this facade actually evolved while we were making the building. So as and when we went up, we kept on creating these frames from the inside to the outside, where we can possibly hide some things and open up some better positions, like relationship to the tree, relationship to the sky. And that's the detailing of this facade. It's done in the beauty of brick, which as a material which we use often, or even how technology can play with the craftsmanship. So this is a big project, a large project out of Chennai, Royal Enfield, where the south facade, where again in Chennai the breeze is important, the wind is important, how we can still fuse the typical Mangalore tile, the tactile nature of the tile engineered into the facade of the building. So it's again another example how like the facade can be talking to the outside rather than being static elevations. These are again the details of that particular facade. And talking in detail, this is the first project. This is a small boutique hotel in the middle of Jodhpur overlooking the Mehrangarh Fort. That's the small site which we got. And to go through it quickly, while we had to retain some of the original structures, there were two new blocks which were created, which had to be the new block. And it had to relate to the Mehrangarh Fort. So it had to have the view of the Mehrangarh Fort, but whereas the Mehrangarh Fort was the west facing, so which is the most harsh sun in the context of Delhi and Rajasthan. So we picked up the idea of Hawa Mahal, like a brise soleil, and the idea being that while we need to allow those views in the evening, but during the day we need to cut that harsh sun and actually still allow for ventilation rather than creating trapped air-conditioned areas. So, and we wanted to create this elevation, which is again made from local stone. We believe whatever stone is available or whatever material is available close by, we should be able to use it, just adding to the energy performance index. And we again use the local craftsmen to create these jalis out of stone. So the whole west face of the new block, which are the rooms facing the fort, were laced with this stone. So it almost became a lantern at night, so that there is a backlighting from the rooms. And these are the views you get from the verandas of the room. These are actual stone, every panel being, the total sliding panel being about 250 kgs. We tried many details, but this was done locally again. So it kind of opens up towards the evening time whenever you want, and you get that connection to the fort. So it has a beautiful play of light and shadow. You get these recessed areas. So this is after a prototyping was done. So it's still working. The project was about 15 years old. So how the beauty of crafting, how the beauty of a local stone can still give us something which takes care of the climate. So that's the evening view, that's the morning view. These are the play of light and shadow during the day. Another project in Rajasthan where we got this building, this was a flagship store for a jewelry designer. The idea, she said you can break it down. But again, as I said earlier, we wanted to reuse this facade. And that's how it exists now. This is finished now. So again, how stone, how the play of texturing of the stone, how the inspirations of the various periods which Rajasthan, the history of Rajasthan, how we can fuse all this together to create a vibrant, visually delighting facade. These are the details of the facade. We created a grid of stone. The upper part is a gallery. It has these tall jalis. These are the other details of the facade. And again, the idea being that it is like the jewelry designer is one of the top-notch jewelry designers of India, but yet the idea is to do something which is connected to the city, connected materials from the city, from the region. Yeah. And that's the upper floor. That's going to be a museum. Now it's getting finished now. And that's how it appears at night. And now to more relatable projects, Max House Okhla, which is right opposite. We do a lot of work for Max Group. Is it opposite the Lotus Temple? And the context of this facade was, or the development was, we picked up from the Modi Mills nearby, which was a kind of an industrial building in brick, and we picked that up for our facade. So again, while shaping the building, we created narrow footplates so that we have the sun from either side and you get daylighting right through the center. That was one of the first ideas which we picked upon. And rather than again picking it up by making a curtain glazing, something in glass, we wanted to pick up that idea of Modi floor mills. I'm sure a lot of people would have been there. So to pick up those lines from the facade, I think I'm missing that slide, that became the inspiration. Yeah, that's it. So that's how we picked that up, and how again the timeless idea can be fused with the contemporary materials. And the client bought it. He anyways didn't really want a typical glass building. And we worked out the wall-window ratio. Whatever is the desired wall-window ratio, there is enough daylighting in. So this conception that, okay, if it's not a glass facade, you won't get light inside, that wasn't an issue, a challenge at all, at least for this footprint. So that was the rhythm created. All these boxes of brick also helped us in cutting the sun. It created a bit of thermal vase. And the long slivers of glass had these spandrels which gave it a kind of a timeless elegance. And that's how it exists as of now. That's the Lotus Temple. So it's a very simple expression of brick and glass, which we feel it's timeless. We feel it relates to the city. Brick is a material over here. There was a podium parking, so the facade really picks up after the podium parking. And now we've done further blocks next to it. So this was the first block. 2 more blocks have got added. Similar projects of Max we are doing out of brick only, a mix of brick. These are the details. So again, the crispness of the charcoal color, the metal, versus the robustness of the brick cladding. These are the podium level views. This is the parking at the ground level. And these are the details of the other side. So even the refuge areas can become interesting moments to come out, to enjoy the wind, to enjoy the ventilation, to have a breakout area. And probably the last project, this is in Bhubaneswar again. This building was for the Department of Agriculture, and that's the final output, where again the whole ground plane was made porous out of stone, the local condylite and laterite stone, because we picked up from Königsberger that the framework was that it's a livable city, it's the people city. So the ground plane connected to the cities was opened up to the people of Bhubaneswar, while the upper 3 floors are for the offices. So it became areas where we gave an auditorium, we gave a cafe, we gave multiple activities. So it became large shaded congregation areas. But the exterior expression is something which was again picked up from the local ikat pattern. See, again, a lot matters for the kind of projects we do. Probably a lot matters, where even cost come into play, the durability comes into play. So keeping all that in mind, and again to achieve setting up examples. So again, here I was talking, our first few meetings was that where is that glass box? Why is there not a glass building? So it took us a couple of meetings to tell them that this will help us in energy performances. It will help us in creating a different expression to the city. And finally, I think when it got built, they started relating to what we were saying. So these are simple, again, any double sin structure. The inside is fixed glass. The outside is these louvers made out of 4 colors of brick. So the idea was that how through the facade also we can get operational efficiency and create better thermal comfort. So in this case, a lot of building is non-air conditioned. The verandas, the inside corridors are non-air conditioned. About the main offices are air conditioned. And we created a temperature which is the comfort level temperature which we studied, which was a bit under 30 degrees, and they agreed to that. So we were working on a night purge system to get in the cool air at night and dissipate during they dissipated during the day. But again, the EPI came down drastically from these standards. And while it had the energy efficiency aspect to the facade, but again, what could be the expression? And we picked up the pattern, the local ikat pattern from there. And we created a tapestry from there, and using 4 colors of the brick, to an extent that even the colors of the soil out of Odisha, we were relating it from that format. And we did initial prototyping to finalize those colors. And as I mentioned earlier, the inside layer is fixed glass. There is the typical chhajja, which has been again a very basic architectural aspect, which has been there in practice for many years. And of course, there is a way to go and clean it. But the outside is these louvers made out of fins, made out of brick, which captures this facade, which captures these 4 colors of brick in ikat pattern. And that's how it kind of relates to the plinth with laterite stone. These are the other angles of the facade. So yes, for us and for the city, it became little bit of a beacon where they have cultural areas, they have events. So it's opened up to public and they relate to this is the image from the street. And yeah, that's the image towards the evening. Yeah, I guess these are some of the projects, and there are many other projects which you are doing. I thought these are more relevant in context to giving a completely different contrast from the kind of buildings I haven't added in the slides. We do some high rises, but I thought I could focus on this particular aspect of when we end up doing the facades of the building. Thank you.
I'm glad there are questions, but there'll be a coffee break, and that's when you can have them. I mean, we are running a little back on time, but thank you for that absolutely lovely presentation. I think the facades really blew our minds. I mean, they were very beautiful, and the fact that they come out of a local context makes it even more so. So next, I would like to invite please put your hands together for Deepak Parameswaran from Jotun Powder Coatings. He has an interesting presentation for all of us. There he is. Oh, I was looking there. Thank you. Please.
Thank you for the kind words, and it's been a privilege to be addressing the forum here. Durability, aesthetics, and sustainability, I believe these are cornerstones to any architectural projects that are created today. In fact, we may not be wrong in saying that these 3 parameters rank at the top when we are envisaging any kind of architectural masterpiece. Jotun, through its coating solutions, is very proud to be a part of this journey, and we have been offering coating solutions over the years, and we would like to show a glimpse of what we offer and the new offerings that we have. Before that, I would just like to give a brief of what the company is all about. With our roots in Norway, we have been in this business of providing paints and coatings for nearly about 100 years. We started our journey with marine coatings and gradually moved into other segments like protective coatings, decorative, and powder coatings. We are truly a global player with presence in about 100 countries, servicing through our 40 manufacturing facilities and 7 innovation labs that we have. We are truly spread amongst the breadth and the length of the continents, and this basically provides the scale of what we do. We are very proud to say that out of the top 20 skyscrapers that that has been done, 14 have been coated with the paints and coating solutions from Jotun. So, where all does Jotun basically operate? We operate in 5 basic concepts: architectural, appliances, furniture, general industries, and pipe business. Today, we are mainly focusing on the architectural powder coatings. And with iconic projects like the Burj Khalifa, Louvre, Abu Dhabi, and more closer home, the Terminal 2, Mumbai Terminal 2, we understand how important it is for you to basically make structures and projects which are beautiful, durable, functional, and sustainable. So we will be basically covering these 3 aspects: durability, aesthetics, and sustainability. Let's start with the durability aspect. When it comes to the durability of aluminium, it is generally classified or generally categorized by AMA standards or Colicode standards. We basically refer to AMA standards. And AMA 2603, 04 and 05 are the 3 basic standards that are available for defining the durability of aluminium, powder coatings on aluminium. Against this, AMA 2603, we have Jotun Facade. AMA 2604, AMA 2604, we have Jotun Super Durable, and AMA 2605, we have Jotun, the best of the class, Jotun Durasol. We offer 15, 25 and 30 years guarantee for these products when applied in the external environments. So we will be mainly focusing on Jotun Super Durable and Durasol. First, let's start off with Super Durable. So this is, as the tagline says, friendly on design, tough on protection. This has been a product which has been a time-tested product. It has been in use for a long time, and it basically offers a range of colors, the best possible protection in terms of 25 years guarantee that we offer, in compliance with AMA 2604. And sustainability by default, the powder coating is a sustainable product because it's a low VOC product and it's a highly environment-friendly product. So on all 3 parameters, basically the product scores very well. It is one thing to basically have something in theory, but we have been testing this in practice as well. And we have this couple of projects which we would like to showcase, where we have been measuring how the shade has been performing over the years. So we have taken up 2 projects. One is Atlantis the Palm. This is on the sea coast, as we all know. And we have used RAL 6033 there, Super Durable 2003. So the initial gloss, and as we can see, we have the master panel which was retained for at the beginning of the project. And what you see, the door profile is basically the current state of the profile. So the initial gloss is in the range of 35. So we can measure them in 3 bases. After polishing, the gloss is very close to what it was at the beginning of the profile, at the beginning of the project. Similarly, color difference, you will see that the color difference, the delta E for a shade like a green color is less than 2. I mean, so over the past 15 years, there has not been much change in the shade as well as the gloss of the product. Moreover, the film integrity is very much visible from what we see in the photographs. Against the master panel, the door profile is looking very similar. So this is an actual experiment that we are carrying out. We are trying for some projects which we have done in India as well. Once we get some information, we can showcase them as well. Similarly, we have done the Shoreline Apartments, again a part of Palm Jumeirah, which is again on the coast. Here we had used a lighter shade, RAL 1014, and the readings are very much similar. There has been no change over the past 17 years in terms of the color, in terms of the gloss, and more importantly, the film integrity. So these are highly durable, and the aesthetics are preserved over a period of time, as we are talking about, as well as they are sustainable solutions. The latest product that has been introduced in this particular, in powder coatings is Jotun Durasol. This is AMA 2605 compliant, and we offer a 30 years guarantee for this product. This is also available in a range of finishes, and sustainability wise, it is a much superior product as compared to the nearest competing technology, which is PVDF. Since this product compares against PVDF, we have put together a small comparison against PVDF. So this is basically a single coat system as compared to a PVDF system, which is either a 2-coat or a 3-coat system. It offers, Jotun Durasol offers say about 50 to 70 microns of thickness on the aluminium, whereas a PVDF ranges from anywhere from 35 to 45 microns. So by both of them are AMA 2605 compliant, as I mentioned, PVDF as well as Durasol. They use the same backbone resin, which is the fluoropolymer resin. Extreme durability in compliance with AMA 2605 for both PVDF and Durasol. It's a low VOC product, AMA Jotun Durasol, as compared to PVDF. PVDF, because it has a solvent, it has a high amount of volatile organic compounds, and hence it's a less sustainable product as compared to Jotun Durasol. And most importantly, we offer 30 years guarantee for this product. Now, when we talk about guarantees, what are we mainly covering in these guarantees? We are covering the color retention, the gloss retention, and the film integrity over the entire period of the the product guarantees that we are mentioning. So if we are saying for Facade, we are covering for 15 years, these three parameters are covered for 15 years. For Jotun Durasol, it is covered for 30 years. And how do we ensure that the guarantees are being, are being offered? It is important to have the right set of applicators in order to ensure that it's just not the powder which is being, which is good, but the application process is also equally good. So we have a process by which we, try to segregate the best from the rest, and this is known as the Jotun Approved Applicator Program. As a part of this program, we audit their systems, we audit their line, we basically have a long-term testing process which is conducted, and based on the results on the long-term testing process, if it clears through, then we ensure that we are offering them the Approved Applicator certification. And after the approved applicator certification is offered for each series separately. So a 15 years, 25 years, or a 30 years series. If an applicator is compliant for 15 years series, it doesn't necessarily mean that he can do 30 years. He has to be clearing the 30 year series certification as well. Globally, we have 87 approved applicators for Durasol, including 5 in India, and 182 Jotun approved applicators for Super Durable, which is AMA 2604 compliant, including 26 in India. So this is the process through which we ensure that the quality is assured at the end of the fabricator basically gets the best coated aluminium in the market. So now coming to the aesthetics part, we covered the durability part. Now the aesthetics part. So powder coatings can be offered in a range of finishes, as we all know. So some of the finishes that we are listing out here is the metallics finish, the Sahara finish, which is the texture finish, cool shades. Cool shades is basically a sustainable, we use a sustainable resin in it. So as a result of it, it offers some additional lead points as well. And the wood spiration or the wood coatings that we commonly refer to as. So quickly covering each one of them one by one. So first is the metallics. So as it represents premiumness, elegance. If you see, most of the projects today have a metallic content in it. Combined with the metallic content, if it is made in a matte base, if you are either going for a 20% gloss level product or a 35% gloss level product, it basically amplifies the the metallic content and the matteness. The matteness and the metallic content comes together, and that gives a different premium, elegant look to the project. So it provides a unique distinction, as I mentioned, dimension and emphasis for the project, and it adds value to the project. Some of the projects that we have done include City Tower Dubai and Oberoi Sky City Mumbai, which has been using our 9006 for the past 10-15 years. They have been quite happy with the product. The Sahara collection, as I previously mentioned, is the fine texture finish. So the textures can be offered in fine or coarse, and these are also finishes which help in concealing the imperfections of a substrate such as dye lines and wells by virtue of the texture. Minimal visual effects from wear and tear, mar and scratch forgiving, and in some cases it is also it has been seen to be having better dirt pickup resistance as compared to the other the smooth coatings. So this is a finish which is again picking up a lot of traction. Basically, the coarse textures are picking up more tractions, I would say, rather than the fine textures. Shuko Grey is one of the most common fine texture finishes that you would have seen in the market. Apart from that, nowadays there are more coarser textures which are available in the market in the architectural field, which was not earlier available. Some of the panels are available at our table. I think we can show it to you if anybody is interested. The wood spiration collection, this, as we all know, is a wood coating finish. There are two types of wood coating finish. One is powder on powder, and the other one is the sublimation process. In India, the sublimation process is the only process which is available, which means that you have a base powder coat followed by sublimation, which needs to be done with a wood coating film. So this, gives a range. The permutations and combinations between the powder and the sublimation film gives you a range of finishes, and it depends upon your choice as to which one do you want to go for. So it brings the aesthetics of real wood on an aluminium. A lot of patterns resistant to heat, humidity, UV radiation, and abrasion. These are generally made in the 15-year series product. The backbone of the powder is the 15 years guarantee product. So there is also a base, which is a high-performing base which is used in order to prepare these wood coating finishes. The cool shade collections, these are the heat reflective powder coatings. These are more recent, I would say, in terms of the innovation and developments. I would say that it reduces the surface and interior temperature by virtue of transmitting less of heat and inside the building, inside through the aluminiums. So it contributes to energy consumption, in reduction in energy consumption of the buildings, and helps reducing the heat island effect, and therefore contribute to lead points as well. So currently we have not done any projects in India, but the trend is picking up a lot in the Middle East, and these are some of the projects which we have done in the Middle East with this particular product. Green building solutions, since we are talking about cool shades, green building solutions follow. Jotun basically can contribute up to say 7 points with the products from Jotun, which includes the paints and coating solutions. With powder coatings, we can contribute up to say 4 points. If there is any change in the REACH regulations, which we are, the LCA EPD registrations which we are talking about, then the powder coating points can increase up to say 7 points in a project. So we have the products. The products are EPD certified. So we have the EPD certifications. In fact, we have the highest range of EPD certifications in the business. These products are EPD certified not just in powder coatings but in the other segments as well, and they can be shared with you based on your requirement for the project. And this, I believe, helps in garnering lead points as well. So we can share these certificates as well for your references. We also have powder coatings for steel structures. So up to C5X environments. Again, this is a 2-coat system. Generally, liquids are more used in this space. But if you are moving towards a more sustainable option, and if you are moving more towards an option which is faster in terms of application and consumption, then the trend is also picking up in terms of architectural steel coating. So this is a 2-coat system, as I mentioned. We have a primer coat. And then on top of that, we can either have Jotun Facade or Jotun Super Durable, offering 5 to 7 years of guarantees for the product. So this is what we had from Jotun. We would like to just showcase some of the projects that we have done over the years. So Jotun Facade, Burj Khalifa, it is a Jotun Facade project, and it's one of our most premium projects that we have done. Jotun Durosol, the AMA 2605 grade powder that we spoke about against PVDF. So there has been a range of PVDF to powder conversions in the Middle East, and now picking up trend in India as well. So some of the projects that I would like to showcase is Jotun Durosol, Masdar University, Abu Dhabi, Khalifa International Stadium, Qatar, Saudi Arabia. Basically, as I said, in a range of projects have been converted from PVDF to Durosol. So again, Qatar projects, then Aramco, Jotun Durosol projects again, Future Generation Bahrain, Durosol, Salalah International Airports, a range of infrastructure projects as well, like airports. Nearly about 4 airports have been coated in the Middle East with Jotun Durosol, and we are doing one in India as well right now. Cairo International Airport, then Jewel of Creek, Dubai. These are all coastal environments where durability is of the topmost concern. It's important that we go for a product which is AMA 2605 compliant, Jotun Durosol. That basically gives you the peace of mind and the durability that is required for the project. Civil Aviation Authority, Oman, again a Durosol project. Hyatt Regency. Many other projects, King Salman Energy Park, Durosol, World Trade Center, Indonesia, China. This is much more closer home. This is the first Durosol project that we did in India. It is in Chennai. It was a Shobha project which we did, Olympia Park, India. Followed by the current projects that we are doing, Noida International Airport. We are supplying Durosol for the project, and then we come to the super durable projects, which is AMA 2604. This is a project, as I said, which is taking a lot of. It is now becoming a default product for most of the applications. So on the exteriors, it is AMA 2605. Interior aluminum, it is more or less AMA 2604. So AMA 2604 Jotun super durable products are picking up a lot. Some of the projects, as I can highlight here, Sapphire in Istanbul, Turkey, Medina Jumeirah, again airport projects, Shobha Crest, Dubai, and much more. Closer home, Central Secretariat project, which is being done in Jotun super durable, DLF downtown, SCB Cuttack, which is one of the biggest projects that we are currently doing, and Phoenix Market City in Pune. Thank you very much. Yeah.
Thank you again. And Jotun products are quite good, and I can say that from personal experience. So next we have Mr. Praveen Chaube from the Facade Design Factory, and he is going to be speaking on the different approach for building high-rise facades. There he is. Put your hands together, please, for Mr. Chaube.
I know it's really difficult to sit for a session post-lunch, and the lunch was good. So, but then I'll ensure that at least people don't doze off. Agar fir bhi koi ho jaye to maaf kar dena. Okay. So, since when I was offered by Zak to present some topics for the fraternity, facade fraternity, I was just thinking of a topic, and then all of a sudden, since the recent Olympics are going on, so I thought of the shooter, Mr. Yusuf, who without any gears just took away the silver with his simplicity. So rather than displaying what we have done, what projects we are doing, I would like to go back to the basics where most of the people are still going wrong. And every now and then we are coming up with the same topics and the same problems which people are facing in terms of doing the high-rise buildings. High-rise buildings, as you know, has eventually started picking up in NCR, and people are building 215 meter, 220 meters. Is a very normal talk of the town for most of the developers that have started building. But then eventually, the same problem everybody is facing. So we thought of just covering those aspects and not displaying what we have done or what we can do. I thought it should be more of an informative session so that people can take something out of this presentation. Okay. So what we tried and do, it could have been a very exhaustive presentation, but then the main context or where people are going wrong, we thought of just covering those, the wind pressure, the performance criterias, and the availability of correct system for the application that we are having. So wind pressure, as we normally know, is the amount of resistance that has been given by the building to the flow of the wind. So there are various factors which are affecting the building. Is the height of the building, the shape of the building, orientation, local terrain, and other factors that actually guide the basic wind pressure for the building. Okay, so far what we have is, these are the different methods that are available for calculating the wind pressure for the building. Is IS 875 Part 3 gust method. CFD is computer fluid dynamics, wherein it's a computer simulation where you generate the model of the building and the same parameters are replicated on the computer, and then you get the pressure coefficients out of it. And the wind tunnel, you actually make the building, and then you have the sensors on the building, and then the wind is blown through the blowers, and then the pressure coordinates are being coordinated on the building. Okay, so we start with the IS 875. It started with the 1997, and the same codes have been still used with some modifications in the code. So the main context for giving this is architectural and building from that stage till now has changed considerably. but then the codal parameters for this is still going the same. So if you actually compare with international codes, if you code with if you have a comparison with ASCS, you will see they are more logical and more precise to the geometry and to the orientations and the locations of the building. Okay. One more thing, what normally people don't know, in fact, the wind speed, when you actually look at the wind table speed, the wind speed that has been given to you, 50 meters per second for Bombay, for Delhi, is the basic wind speed, and as you go up, the wind velocity will increase. That's the normal, you can say normal physics in which it functions. But then people are of the opinion that as the wind velocity increases, the wind pressure will also increase. Okay, but that's generally not the case, because 99% of the people are actually of the same assumptions that as the velocity will increase, the pressure will also increase. But then that's what we did some case studies to evaluate this. Okay, so this is the basic wind pressure coefficients that you add. This is, you take the basic wind speed, you add the risk coefficient, terrain category K1, K2, K3, and all those multiplications will you come up with a certain figure. The basic drawback of this is it is actually completely dependent on the individual who is designing it. Okay, the same building for me could be terrain category 2, somebody else who is designing it could be terrain category 3, somebody else designing is terrain category 4. Okay, so based on my mood, if I want to be a little lenient, I can go to terrain category 3, but then if I feel no, I should be a little strict, it should be terrain category 2. And all of a sudden I feel, no, I should be designing as an importance factor to the building. This building is very important. Irrespective of the terrain, I'll design it for terrain category 1. Okay, so it is completely, there is no guidance factor that is written in the book, but then eventually it's the prerogative of the individual who is designing it. Okay, so we just did a small comparison. Basic wind speed is geographical location. While if you look at the other codes which are using it, these are actually looking at the historical data. Okay, so Delhi, if you actually go as per the Met Department cyclonic zone factors in Delhi, if you actually follow that, you will see that Delhi is the least cyclone prone region as per the map given. These maps were released way back, but then if you actually, people who are staying in Delhi, you don't actually call them cyclones, but the kind of wind pressures that people have started experiencing nowadays, they have changed substantially, and I feel in due course of time, we could be having situations where you could have this cyclonic kind of wind pressures exerting on that. Pressure coefficients are defined values, these are dynamic factors. So we'll again come to this. Okay. So with the height with the slenderness of the buildings increasing, so what you have a small floor plate and you are actually constructing the building till say 200 meters, 300 meters. So when you actually start calculating the height to width ratio of the building, if the ratio exceeds 5, if you see most of the buildings will now have the ratio beyond 5, if you have a smaller base plate and if you are actually constructing the building higher, your width to height ratio will always be greater than 5. So the code says once you go with the, if you have something which is more than 5, so building will have its own sway. Okay, if you imagine a small pencil or a straw, you try to do it, it will have its own sway. So you cannot use any more dynamic factor for using the same wind pressures. So you'll have to go with the dynamic. You cannot use static. You have to go with dynamic wind pressure. So this parameter came into picture that is called as the gust. A positive or negative departure of wind speed from its mean value lasting up not more than say 2 minutes with the peak occurrence from a specific value. So if somebody has designed the wind pressure at 44 meter per second or 50 meter per second for Delhi region, so it will calculate the mean. That is, if it has gone for say 5 meter per second extra for a period of 2 minutes. Okay, so that's how you define the gust factor. So compiling all the case studies together, we were doing this building. This building looks, again, height to width ratio it's a very slender building. Okay, so we thought of considering this as a case study for the audience. So if you see the podium level is more of kind of an aerodynamic figure. So you see that the wind could easily navigate through that. The top structure also looks like more of an aerodynamic and a pencil structure. Okay, so like I rightly said, so what we did is, since the height to width ratio was much higher, so we went with a dynamic factor for this. So what we did is, I was in a very good mood and said, let's do it a terrain category 4 for the building. Since it is dense, this is right in the heart of the city in Bombay, and it is closely located with all the buildings all around. So we thought of first designing the building at terrain category 4. So this was the height of the building. The building was 150-meter tall structure, not a very, very high structure. Terrain category 4 we did. And then the wind pressures that we were getting, the design wind pressure came to 2.2, and when we were actually, if you see the segregation of the building, from ground to podium, we were only getting a 0.4 kPa. Okay. So definitely there is some flaw in the overall approach for both the methods, that is the static method as well as the dynamic method. So if you see the ground floor to podium is 0.4 kPa, which cannot be the case. The code says that even for internal application, you have to use at least a 0.8 kPa for designing of any of the facades. So P4 to podium 9 is 1 kPa. So first to 19th is 1.8. 20 to 38 is again 2.2, which looks like a logical figure. So if you actually look at the ground portions are figures which are absolutely wrong. This cannot be the case. While if you look at the from first to 30th floor, it still looks logical. Okay, because again it is considering the dynamic factor. As you go up, it increases the sway, and that's how it is calculating the your wind pressure, and the bottom will not sway, hence it is giving this kind of figures. Then we again did it terrain category 3. So here we got some logical figures of ground pressures. Ground floor is 1.3. P4 to P9 is again 1.8. From 1st to 19th, it was 2.4, and 38 to 39 was 2.8 kPa. So 1.3 again for a terrain category like Bombay is little vague in terms of getting these kind of wind pressures. So again we did the exercise with terrain category 2. Okay. So now we got something figures of ground floor to 1.6, and these were the figures which were kind of acceptable. Okay. But then eventually what I had to do is I had to actually do the manipulation for getting the right wind pressure, because definitely that building does not come in terrain category 2. Okay, because of the adjacent buildings and the geographical location of the building. So the problem with high rise, when you start building high rises, these small values actually help you in determining the right wind pressures. I'll not say reducing the cost, but then you should actually have the right wind pressures for your building. And then finally the CFD was considered. So if you look at the CFD analysis, we are reaching at, the building were rotated at various angles. So we got figures at 0 degree and 90 degree. So still we are getting a 1.5 to 1.4, which is the right wind pressures, even for we were terrain category 2, and we are almost in the range. But then if you see 20 to 38, we are getting 2.8 and 2.4 kPa, which is again for terrain category 2. So if somebody has already determined that the building would be terrain category 3, so the whole wind pressure would have gone wrong. So then we did a small exercise in terms of effects of shape of the wind pressure. Unfortunately, with facade consultants or even with structural consultants, what we have seen is the geometry of the building is never considering either of the structural consultant or the facade consultant in place. It is more based on the FSI, maximum usage of FSI, and what is the sellable area that you're going to get out of it. So we took one rectangular building and then we did a small CFD for it. All the buildings were with, so the height for all the cases, a height of 150 meters was considered, and more or less the floor plate area that was considered as same. So here if you see at the extreme right, you can see the pressure coefficients happening there. This is just the velocity diagram, and this is how the wind is actually traveling. Now if you see the wind velocity there, the heights are same, but then if you actually look at the wind velocity, there is 126 meters per second. That is the maximum wind velocity the structure has reached, but then the wind pressures are altogether different for the same structure. If you had actually designed all the buildings for IS, you would have got a very constant pressure for most of it, unless you have a very circular building or something where you can have some coefficients for, this was the square. So here, actually, if you look at the wind velocities have increases to 135 meter per second, but then the pressure coefficients have dropped. The pressure on the building is less. So like we were always saying, as the velocity increases, the pressure should increase. But based on the geometry, if you see, it's altogether a very different figure that has come up. Then this is also the circular. So here we are still at a lesser pressure, but then again, if you see here, the wind velocities are higher, but pressures are less. So basically, the context for this was that whenever you are designing a building, the geometry of the building will definitely determine the exact wind pressure on the building and how your building behaves to the wind velocities and the So it was a little strange. Normally, everybody has the misconception that a circular building will have a lesser wind pressure because of the aerodynamics. But then in this case, if you actually look at the pentagon came out to be the, so if you actually in a pentagon, septagon, octagon, if you start designing, you will see the wind pressures are much lower. Here the wind velocity, if you see, is 188 meter per second. But then again, your pressures are less. So again, the whole crux of this is if you are actually building a very high-rise building, I think the preliminary consideration should be also the geometry, so that you can actually optimize the wind pressure on the buildings and then get a better product and a better ambient comfort for people staying in the building. The second problem that we always face is now with most of the people wanting to go for a green rating for their buildings. So normally you have, this is the two category that we have considered, that is GREHA and LEED. GREHA is something more related to a mandate that is written in the manual, that you have to have a specific SHGC, that is solar heat gain coefficient for a building, for any of a structure to get the GREHA rating for this. While LEED is more of a performance based, you have to do many calculations for it and then eventually get out to a specific parameter of a glass. So we'll just cover the glass parameter. So for a gold rating or a platinum rating, what they are asking for is they are asking for a residential building for effective SHGC of 45. Okay. So once you are telling is solar factor, to get a solar factor of 45, the one thing is for sure the glass needs to be very reflective, and secondly, it will be more of a commercial looking building than a residential building. People still have that notion of having very clear glass for the buildings and not having a reflective glass for the building. But then one catch here is they are asking for as an effective SHGC of 45. So we had one case study for the building where again we had a GREHA rating. So this was the floor plate for the building, and then we actually, when if you see with the large balconies coming in, most of the time the glasses were completely shaded. So we are still using a glass for, in fact, we had two options. We are using a DGU glass with a clear glass with an SHGC of 75, still achieving an effective SHGC of 45, or we went up with using a single glass with a solar factor of 65, and then we are still getting the GREHA rating out of it. So again, when you are doing a green building rating, you have to get into sunpath analysis and seeing what kind of shading you are getting, the orientation of the building. The last thing, I think we are running out of time. The last thing what we will cover is performance of the windows. Again, this is a very common question, that till what pressure the windows should be designed. So this is just an example of a failure of a sliding window. Okay. So you can see here the water is actually trying to drain out of the slots. This is a sliding window. And it's a rain outside, and water is just trying to escape out of this, and then everywhere what you have is water because of the bubbling effect of the water which is trying to escape. So again, as per mandate, since you should at least have 20% of your wind pressure as your water test pressure, for the windows. So eventually people were designing it at 300 Pascals for the windows, but then for Delhi region as well, people should start using 450 or 600 Pascals. So future trends are the options that are available. We might still have robotic and automation inspections for doing the wind pressures. Thank you.
Thank you, Mr. Chaube, for that very informative, sort of session, so that we could understand the performance parameters, when we design a building. Like we all heard earlier, like we have to begin correct. So if you begin correct, you end correct. I suppose that's more logical. And with that, I'd like to invite Mr. Dastagir, who's right here from Viva Metal Composite Panels, and he's going to tell us how to clad our buildings. Put your hands together, please. Thank you.
Happy evening, all. And this is not the response I want. I'll waste 1 minute on it. It's okay with me. Happy evening, all. Happy evening, Delhi. Come on, show some spirit, yaar. Okay, I'm Pfizer National Head, Viva Composite Panel. Asia's 5th largest manufacturer of metal composite panels and India's largest manufacturer on date. The presentation today is not, thanks for the introduction, ma'am, but these are experts. I'm not going to teach them how to clad. I'm just going to show them the next 20 minutes, your perception about what metal composite can be, what metal composite is today in India, and where is it heading to in the future. And just a little eye-opener on what, as an Indian manufacturer, can do in this context. So the primary topics basically are coil coating standards, paint technology, customization of shades and textures, and exciting sustainable products. So the third point, I think, is going to be more exciting to all of you than there are the first two. Just a quick introduction about the brand I represent. I represent the largest manufacturer of metal composite panel in India in terms of infrastructure, and 5th in Asia today, including China. We started our journey in 2003 with the vision of one single man, Mr. Prakash Jain. From a trader to where we are today is his vision, which is being imbibed by the entire team. Today we have a nationwide presence. We have offices in 15 countries all over the world. We're doing projects in the US as well. We have operations in Gulf in Africa as well. Officially, we're the largest exporter of ACP for the last 2 years, declared by Government of India. We make high quality metal composite panel, as you all know, and fire resistant, self-cleaning, anti-scratch being a few things that we value add to ACP. We have an impressive metal production capacity of 12 million square meter, which you calculate on an average per day would be 30,000 square meter per day, which is great by any global standards. Our facility is at Gujarat, Umargaon in Vapi, and we have 12 production lines, 3 coating lines, which is now going to become 4 from the month of October, where we be manufacturing first time in India horizontally coated solid sheets 3 mm and 2 mm, which will also be offered to you as panels ready to fix. ACP, all you know, doesn't need introduction. It's a material that has gone through its own journey. It has its own highs and own lows. But I feel today we are at a point where it is sustainable, it is safe, it is durable. And what the world had to offer, the same technology is there in India today. So confidently we can say that we are now giving back what we used to buy from the globe outside India, and we're giving it back to the globe again. Now we are exporting ACP from India, which is commendable. Just to understand a bit about what governs the coating that you have on an ACP. A lot of times I have people asking me, why does the color on the ACP fade? Why do we see a metal composite panel fade? The answer to that is that there was never a proper coating technology that was there in India a few years ago. So we didn't have coating lines in India. We used to buy ACP coated coils from China, which we had no control on. But today we have coating lines in India, and we follow the international standards called AMA 2605. My friend Deepak also spoke about it from Jotun. So this is a standard that governs your coating on an external cladding product. And the basic factor here for a layman to understand is that anything that happens on your coated panel is because of UV. If you see deterioration, if you see color fading, it's because that the UV harshness has taken the paint away. The molecular structure of the paint has broken down. But if you use a proper paint, if you use the proper technology, if you use the proper amount of coating that is required and follow the standard properly, there's no reason why the panel should fade. And when we announce any series with a 15-year warranty or a 20-year warranty, we do a 5,000-hour weather accelerated test in our plant. So it's a 1-year process where we have invested on a weather accelerator where we keep a product and check the harshness of UV 100%. So what you receive on the facade is just 2% or 1% of the entire UV that reaches the earth. That's all reaches the earth. But we do 100% UV testing for 5,000 hours to see what happens on the panel. Just a basic understanding of how coating works on ACP. So if you have a 10-year warranty product, you very well know that it should be a 25 micron product, 2 coat, 2 bake. If you have a 15-year warranty, it's 28 micron, 2 coat, 2 bake. If it's a 20-year warranty, it should be 35 micron, 3 coat, 3 bake. If it's 25-year warranty, it's 40 micron, 4 coat, 4 bake. So this is not something that we've formulated. It is basically what the standard calls for. Now, if there is, the topic is all about innovation. So initially, when we started doing 15-year warranty, the technology was 3 coat, 3 bake with 30 microns plus. Today, the technology has moved forward. Now we are at 15-year warranty, 28 micron, 2 coat, 2 bake. So we value engineered on that. So we're still giving you the 15-year warranty with a lesser micron coating. So thereby value engineering, so the cost is becoming more affordable. A lot of innovation is been a part of Viva. We've ventured into finding out different ways of getting cladding products to you in popular natural forms that are there. That's like natural stone series. We have our metal abstract series. This was one of our first early journeys into innovation. Then we have a very popular metal series, which is tarnished metalum. This is something exciting that we've created, that is textured stone finishes. Yes, we also innovate with safety. We just don't innovate, we just don't give you aesthetics, but we also innovate with safety. So we've put a lot of effort, resource, time into creating safe products that are fire rated. And how do we do that? We replace the core from an LDP to a mineral core mixed with virgin LDP in different proportion according to the standard demands. The standard that governs is the EN 13501. I'll not deep dive into it, but that's a separate topic by itself. But I just want to highlight, when you buy a FAR product, please ensure that you ask these questions. Is the product tested or is the product certified? There's a huge difference. When you certify a product, that means you're putting your plant through an audit. There's a systematic audit that happens by the certifying body, in our case, which is Thomas Bell-Wright. So there are 4 audits that are conducted per year, and this is what results in certification. Testing, on the other hand, you all understand, is a one-time affair where I test the best product I have and I give you the desired result. So that is more dependable. You can depend on that because that goes for a period of time. Another innovation we came into fire retardant is, from mineral core, we moved into 3 layers of aluminum. Not a solid sheet per se, but a sheet that has 3 layers of aluminum. So it is A2 rated because it is composite, but it performs better than an A2. So this, we were the first to manufacture this in India, and we do it at our plant in Umargaon. This is a structure section of the product. The next we ventured was into honeycomb. And this is a performance panel that has thermal performance and acoustic performance. So we make 12 mm, 25 mm with different configurations. We have 0.7 skin on top, 0.5 on bottom. So we can give you different configurations. We can also go on higher thicknesses. We're working on a project that is 60 mm honeycomb. So we can get into things that are pretty innovative and challenging as well. The thing that we're looking forward to is in the month of October 15th. For the first time in India, we will have an horizontal coating line that will give you solid aluminum sheet, 2 mm and 3 mm on the finishes that you see in our ACP. So all the finishes that I mentioned on the ACP will be there on the solid sheet as well. This is an A1 treated product, so if people have the apprehensions of wanting to have the best FR retardant product, then this becomes the solution. We will not only coat, we will also bend, make it into a tray and give you the solution. So you are ready to fix panels are available. So it's factory finished, so you have the best quality possible. Another wonderful product that we've collaborated with a world leader in Germany called O-Coil. They are the world leaders that make anodized coils in aluminum. And the default alloy they use is a marine grade alloy, that's a 5000 alloy. So this is a product that we've launched that's called the Pure Aura. It comes with a lifetime warranty on a 4mm FR solution, but the top coil is anodized. This is something really exciting, and this will change the way a building can look. Zinc composite panels are something that are in trend today, and we also have a collaboration with El Zinc from Spain, the world leaders. The unique feature they have is they give you panels that are 1320, 1220 vis-a-vis other zinc companies that give you only 1000. Another innovative product we have here is a solid copper aluminum sheet. I say solid copper aluminum because 10% of the top layer is copper, molten copper, which will age. The balance substrate is aluminum. So it is available in 1 mm, 2 mm, and 3 mm thicknesses. It's a very nice product that will age on period of time eventually and patina after 25, 30 years. If all this innovation has to happen, there has to be a place where it happens, and this is where it all happens in the 13-acre facility in Umbergaon, near Vapi, where we have a very, very important part of the plant, which is called the paint mixing unit. We do not buy ready-made paint. We work with all top paint manufacturers in India, Spectrum, Nippon, Monopole, AkzoNobel, to name a few. But we buy the components and we do the entire formulation in our plant. And that's one of the reasons when I show you the innovations and the customized shades we've done, you will understand how that had worked because of this. First coating line, we got into coating in the year 2018. This is a single coat, single bake line. In the year 2021, we commissioned our second line, India's first 5 feet coating line, that is a 2-coat, 2-bake system. In the year 23, we launched our third line, that's a 3-coat, 3-bake system. So we have lines that can coat up to 1670, but at the moment, Indalco, who's our major supplier, gives us only 1560. So we can coat 1550 panels max. 4 lamination lines for FR, Class B, and 1 line which is one of its kind in India that gives you 4 fire-rated products, which is A2, corrugated core panel, 12 mm honeycomb, and 25 mm honeycomb. So one single line making products that are highly performance oriented. This is Viva 2.0, a land bank of 50 acres where we are developing this entire premises. The first phase of development would have 2 coating lines, 3 lamination lines, and the first time in India we're going to be making the FR A2 core as well. The A2 core is not manufactured in India, it is still imported from China or Korea. We'll be the first to do A2 core in India. Out of the 2 coating lines is the 1 coating line that will have the 2 mm and 3 mm solid sheet coating, as well as the entire facility to do a panel, the shearing machines, the cutting machine, and the bending machine to give you ready to fix panel with a minimum warranty of 15 years and moving upwards. A few projects which we've done. Each of these projects has taught us something. What we are today is because of these opportunities we've got. Every project has taught us a lesson. Every project is a journey by itself, it's a story by itself. Wherever it's an interesting story, I will highlight. This is one of our interesting stories where we did the Mall of Asia in Bangalore. This is a 20-year warranty product on a solid sheet. So you see 5 colors. The 5 colors are customized, but the client wanted a 20-year warranty, which was the spec. So we've done a 20-year warranty on this product. This is CMRL Chennai with 18,000 square meter of FR A2. The challenge here was the client wanted a special bid of 1,100 in a particular period of time. We were able to deliver that with our support of our suppliers in 35 days with the first deliveries went out. That was one of the primary reasons we won this project. It's an iconic project in Chennai. This is a project of value engineering where it was a project that had budget constraints. So we had to present the corrugated core where the solid sheet was a spec, and then after the clients were satisfied, the consultants were satisfied because it's a tall-rise building experiencing high wind loads. But it's now been 3 years plus. We have the corrugated core panel with 17,000 square meters, all panels safe. This is another project where they had time constraints. They wanted a zinc finish. They didn't have time to import zinc. So we did a zinc finish on ACP. One of the large projects in Hyderabad with Phoenix Centaurus. This is a project where we did entire 3D panels of 4,000 square meter with corrugated core panel. A very interesting case study recently that we got into and we were successful. So the architects have clearly shown what is the RGB they want on each shade there in the render. So this was the final product we came out with. It's a 15,000 square meter project in Kingdom of Saudi Arabia in Riyadh, so a 20,000 square meter. And this is the coating that is happening, and that's the final product. So this is one of the very challenging projects that we took up. It's like a barcode. It looks like a barcode. The next one is the Alkur Zoo, which will always be close to our heart because this is a place that pandas are housed, and the concept is bamboo. So these were the specs that were given by the architect. We ended up with a product like that. Eventually, we supplied 30,000 square meters. This is the production happening. So, to summarize it, we are on a path of innovating. We are on a path of giving you new products and looking forward to your support. And you can catch up with my team at the booth. Exciting times ahead. Thank you for being a great audience. Good evening.
So innovation seems to be the catchword, especially with Viva. And I'm sure they're going to keep innovating as long as we keep imagining. So I'd like to invite now Mr. Rakesh Pant from Kinlong. And he is going to actually address some of the issues that came up earlier with caution and facades. So with great caution, I welcome you on top. Please, a round of applause.
A very good evening to one and all present here. So this is the first time I'm presenting on the behalf of Kinlong at Zak World of Façades. So I would like to thank for all the presenters since morning. I have taken out so many key points. Since morning there were so many ideas. I kept on taking a note so that I can keep on implementing it in my exercises further in my career. Of course, it will be going to helpful. So let's keeping further. Moving forward to the presentation. Myself, Rakesh Pant, I'm presenting Kinlong Hardware India Private Limited. So these are the topic what I'm going to speak on today. Distinctiveness in facade and cautions to be taken while designing. So I have divided this presentation into 3 parts. Let's move on to that. That measures while selecting the front fascia. The second part is selection of fixing methods to avoid the consequences which usually happen at the site later on. And we, like as a supplier and the applicators, we used to face a lot. And the third part is new trends. What are there in the facade industry, which are upcoming trends, which is going to happen, and it's going to add on more values to the facade industry. So moving further to the first part of the presentation. So these are a few of the system which we have, as a supplier, like bush spider system, I would say MS structure, and fin spider system, and then we have hybrid system, and then cable net structure. So this is what we used to supply as a facade hardware to our projects. So every single product is having a different advantage, and every product is solving their different application of the builder, of the architect, and of the consultant. So keeping on further. So there are many factors what we understood as our experience and working with our consultants, our architects, and the builder lobby. So what we concluded that these are the factors which used to be taken care when designing the facade, and this is actually happening, but there are a lot of areas where need to be worked on. Let's say the first thing is architecture. The moment architects design the project, then the most important cost comes to our applicators and the suppliers like us, that it has to be done into reality. Whatever the things are happening into their minds, it is going to be done at ground. So this is one of the important factor. The second thing is the location of the project. The location of the project always refers to the material what we are going to select for that project. Okay, and the taste of the client, I would say, like even though buildings is having the color shade, it can affect to the sustainability of the project. It is going to be affecting the effectiveness of the project as well. Let's say if we select some colors which are actually not energy efficient, so of course it is going to lower down the efficiency of the project. Now next is features including the lighting and landscaping. I'm going to speak on further for this particular thing like lighting, how we are going to cooperate in this facade industry for the lighting products. So before designing the facade, actually, there are two major factors what we found, that the environmental condition of the building site must be considered, that the project location should be analyzed well, what kind of selection of the product should be there from the applicator side, because when we get the budget from the client, of course, there are a lot of areas to work on to get the right product for the right project. And the second thing comes that facade design must appropriately respond to climate factors such as social exposure, that which glass we should use for that particular facade so that at least we can save some energy. How better we can utilize the resource which are natural resource like sunlight we have. So how better we are going to utilize it, this is one of the factor. And temperature, yes, of course, like everybody knows that temperature plays a vital role for changing the mechanical and chemical properties of any material. So the selection of the particular products that has to be considered while designing it, and the wind pressure and the precipitation. Now coming to the next part, these are the core factors where we are actually working and we are taking care of while designing it. Like there is a project which I have shown here. This is Mumbai International T3 where we have supplied our clamps. So while doing the analysis for such projects, what we understood that while selecting the facade products, let's say either it could be spider fittings for MS structure or maybe fin type structure, or maybe we are going with the tension cable system. The building codes that has to be followed well so that our product should be within the range and within the following the parameters of the industry. And coming to the site condition and climate, material selection. So I'm going to forward this slide because this has been somehow already spoken earlier, but the most important thing is maintenance and life cycle cost. This is one of the factor which somehow we didn't care much, because this is something where we need to understand how much energy, how much money, how much efforts we are going to put on after sales, like once the project is handed over. So this is something which we need to understand in the prior, that how can we save or how can we evaluate so well the maintenance cost and the life cycle of the building, so that there should be less, it should be within the budget of the client, it should be less, it should be effortless, it should be easy for the clients as well to maintain the building. Let's say recent one project, Meenakshi Tower, we have handover in Hyderabad. So in that project, we got the call from client that pre-tensioning has to be done. It was done earlier. Later on, the maintenance job was there. So client was happy because the team was there for the service. But while designing or while selecting the product for the particular project, this is really required to have a product which requires less working or maybe easiness for the client, because end customer are going to face a lot of issues which we have seen when they used to call us directly when they face a problem. Next part is construction and fabrication method. How better we can make it. Let's say there are so many kind of strategies we have in facade. Let's say maybe either we are going to make it prefabricated building or maybe post-fabricated, like we have some MS structure for using in the facade. So how better we can select the product, that is very important to understand by the fabricator lobby as well. Now coming to the facade, we have selection of the facade, what challenges we used to face and how to select it. So where we have different range, by the way. Like earlier we started with the stone cladding, that was now dry cladding or wet cladding. Then we have metal cladding over there. Now ceramic, and now the new era is like photovoltaic cladding is also there. Now so many clients have already incorporated in their project. So we are having the hardwares for all such kind of ranges, such kind of categorization, so that we can supply all our hardwares for these projects, because facade is one of the major product, or maybe I can say the base of Kinlong from where we have started. So this is what I can assure, or we Kinlong can assure, that for this particular segment, we can be a valuable partner for you to add on more values for your projects. And for the ideas, whatever you have in your mind, at least we can add on some values to make it happen into the reality. I'm going to show it in the for the slides how we are going to happen. So this is just a few glimpses how the facade has been changed over the decades. It has started, like still if I went to Lucknow, I see so many buildings, even though Ayodhya airport, still there are so many stone they have used. Why? Because they have that kind of taste. Still that city need that taste. So we need to understand the sales, or maybe the proposal cannot be same for all the territories or all the areas. Maybe one of the customer in north can have different taste, or maybe some of the city can have different taste. So we need to respect that, and then we are proposing to this kind of system, which is glass curtain wall system. Already we have supplied so many projects because this is the pioneer product from our side. So coming to the next part, like we have steel structure. That is very common, but now what we actually see, there are so many less projects where the spider fittings are being utilized. We are moving to the fixed glazing system, like every leaders in the market are having. So this is cable structure, what we are having as of now. Fist type also, even though single vertical cable. The one of the prominent project, I would say, Meenakshi Tower we have done, that is 40-meter continuous single cable we have done, and it has been successfully delivered to the client. So hybrid system, this is one of the add-on in the facade industry that is having combination of two or three system in the facade. We have handovered one project, Dehradun Airport, that is Jolly Grant Airport, where we have utilized these product segment, utilizing the maximum resources to ensure that client, like the client material uses should be less, so that at least we can save the cost, at least, but ensuring the safety factor, because safety is one of the first priority for us to ensure that failure should not happen later, because later if failure comes, so that is a pain point for everybody, not only to the fabricator, even though end customer, architects, consultant, all the key factors who are involved. This is one of the pain point for all of us. So what measures we need to consider basically as a supplier for the point fix system? The main thing is like bearing capacity. Whenever we are working with our applicators, what we used to check with them, the most important thing is what kind of system we are going to select for this particular project to ensure that system should sustain for that particular loading. The next part is vertical and horizontal span, of course, to ensure that the bifurcation of the glasses should be in proper manner. At least we can use the fittings well for that particular system to ensure less product to be used to have more aesthetic of the building. Then selection of the glass, what kind of glass, either it is laminated or it is DGU, or what shade of the glass, so that at least we can provide to the right product to the customer. And then wind speed, because usually what we get from the client that, okay, north region, maybe let's say Haryana, we are considering 2.5 kPa for this particular region, but that is not the actual requirement from the applicator side or maybe from the supplier side. We actually need the wind tunnel report, so that at least we can come up with the cost-effective solution plus optimized solution, which is actually a need of the customer. And then temperature difference for that particular project. Now coming to the application, okay, let me come to the topic, how to avoid the consequences after selection of the fixing method. The first thing is for the facade, based on the load like seismic, mechanical and chemical, we need to ensure as an applicator, as a client or as a fabricator, that whenever we are selecting the material and the fixture, that has to be taken care well, that what kind of seismic load is there considered by the architect and consultant for that particular project. Now coming to the material selection, because every territory is having a different climatic zone, every project is having different requirement, every architect is having somehow, they are having some practices which needs to be followed. The second part is type of subframe used. Either we are going with the fin system or maybe MS supported system. If we are going with the fin system, are we going with the suspended fin or maybe full fin? So that has to be taken care to make sure that hardware or the supply of the product should be well enough to ensure the effectiveness and to avoid the consequences. Next part is type of the fixing. Either it is going to be a pre-fixing structure or post-fixing structure. we can supply the product as well for that. Like casting channel, we used to see very less scope in North India, but this is one of the product where we can actually act on to optimize the solution for all of you, if we can get the inquiry, if we can get the interest from you. So next is cable system fixing zone, that earthquake zone, and that swag in like facade glass holding method. We have some fittings actually where we don't need to make hole in the glass, like clamp system, where we can fix up the fitting without making any hole, making any drill in the glass. We already supplied some projects, like you can see in the Delhi, like in the region itself, AIPL building is there. We have supplied that a project with the clamp system where we haven't make any hole in the glass. So, and next project like Omex projects we are doing with the same product, so that we can ensure the more of the transparency, more of the aesthetic of the building. And this is something where client are getting the interest by getting to the visit to the projects that we have supplied. Now coming to the railings, factor to be considered, either are we considering the right anchor bolt? This is one of the most important factor which always leads to the failure of a railing, that the selection of the anchor bolts are not happening as per the current, like I could say the channel or maybe the pillar, or as per the site condition. This is one of the important factor where usually railing get failed, and this we need to consider at a serious note. Second is the concrete type, either is it cracked concrete or uncracked concrete. Second is on-site issues, that upstand, either it is feasible to have that railing system on that particular upstand or not. Material of the railing as per the client requirement, considering the site location, either it is having the humidity or what kind of temperature range is there at that particular site, because we can supply SS304, 316, we have SS316L also, where we have less or low carbon, SS2205 also. We have done one project in Gurgaon itself, Tata Primanti, where we have supplied 2205 material, spiders, as per the client requirement. And then next part is handle fixing with the railing. So this is one of the factor where we have different typology to make sure that different kind of handles can be equipped as per the client intent. Now trends in the facade industry, we have moved to a different era, like we have started with the stone. It has been seen in the first PPT of today's. So now coming to the next generation, what we use, what we like actually, when we go to abroad, we see so many buildings are having so many of advertisement. Can you put up the volume, please? This is one of the product actually we have, Next Novo, where we can have the LED panel. Just wait for the. It's okay. It's okay. It's okay. So this is one of the product we have where we can actually utilize the facade well enough to get more efficiency. What actually we needed, actually we are spending a lot for the advertisement, like everybody in the market, and it's like we are investing a lot for the advertisement, but if we get the output from the buildings, what we can see, like in the heart of city, I can say Gurgaon, we have Cyber City, Cyber Hub we have. So we can utilize such places so well, even though Hyderabad we have, Bangalore we have. So what I understood when I've been to China, in the factory nearby, we have seen so many projects utilizing this product. And it is one of the efficient product what we see that is giving much more results. And it is having different pixel range. Like say, how far you want to see the screen, how clear you want to see the screen with how much distance. We have different customization for this product. So this is one of the product which is going to add on the value to the facade industry and where we can support it. So coming to the next project, I would show one project where we are actually working, like it's under working. So we are going to supply our facade system, lighting system for this particular area. This is in Gurgaon itself. Next is dynamic facade. This is one of the product actually we used to see very less in the market, but this is something which can be add on to get more aesthetic of the building. I'm just showing you a few glimpses actually, which is not common, but yes, if we add on, so it can give us more new look of the building, which is not happening actually. So this is something, this is the art basically, what we actually see after the completion of project. So I'll show you, this is in the daylight, how better a project could be. So we have the fittings for this basically. There are some planks we can supply And the fixing assistance we can provide to the customers, we can give them training on that, and we can make it happen from the idea to reality. Now coming to the next decorative cable, it can have HD kind of finish. From the inside you see, it will be totally transparent. Okay, next part I'll cover just 1 minute. Metal louvers we have, that is one of the new product we can add on for the facade. Then stainless steel fin we have, and glass louvers. And then metal structure facade, this is one of the new product actually we have recently launched. And then one more, like apart from getting the excellence of China, we have added some new companies as well with the Kinlong group, that is Cifil, Toden and Sever. Someone is from Portugal, they are more than 130 years of experience. So we can add on more products, not only with the Chinese technology or experience, we are adding up more and more experience of different countries to get the right product for our clients to make sure that their purpose should be solved. So these all the product range we can supply for a project, I could say from the excavation stage to the finishing stage. So that I must say that Kinlong, we can supply you as a one-stop supplier. So that's all for the today's sharing. Thank you all.
So here we go. This is Mr. Shyam Raghunandan with Shuko India. He's the MD. And he's going to be the moderator for the panel and will introduce all the panelists. I request all the panelists to also step on stage, please. Thank you.
We have a really esteemed group of panelists for today. Please give them a big round of applause. I'll start with our investor community. We have Anu Pragavji from the Unity Group and Stuart McConaughey from M3M. Then we have architects. We have Rahul Kumar from Rajendra Kumar and Associates, and Prableen, actually builder and architect, I must say, from the Gulshan Group. And we have Lalit Pandeji, facade consultant. And then I think the colleague from Mace is, yeah. We also have Mr. Shams Alam, who's a project director at Mace. So I think an esteemed panel with broad range of experience on this topic of project management. Let's, I think, sit down, just unwind, and then we'll get started. We'll wait for Mr. Alam. So I think before we start, this topic of project management is a big word, and I think everybody has huge expectations from this word itself. And it means, I think, different things to different people. So I'd like to start off the conversation by just hearing from each of the panelists, A, what do they mean by project management, and what is their expectation when they take on a high-profile project from a project manager?
Thank you, Shyam. Well, project management is a very key part in all projects, whether small, medium-sized, or big. As architects, we see this as kind of two phases. One is when it's in the design stage, and the second is when we move on to the construction stage, an in-between stage where you actually go for bidding and tendering. It's nice if the project management team is there early and they are kind of involved when we are involved in the design intent, the design concepts is much better. I just feel that they have a better understanding of what architects are imagining that structure should be. And it helps them to contribute a lot more to make sure that the end product is visible, aesthetically pleasing, and serves all the stakeholders. Very often the project management comes in very late, either just before tendering or well into tendering and before construction. And that becomes a challenge for us because a lot of them have very smart ideas. They all come with varied backgrounds, but it's important that they come together at that stage when we are putting our designs together. So we see it as a process. And if you see, particularly in facades and the building enclosure, at that stage when you're trying to get a
a good-looking product with sustainability and all other features. And if I may add, easy and practical to build in our conditions. It's really good if they get involved early with us.
Great. So if I could summarize what you said, I think from a project manager's perspective, capturing the intent and starting early in the journey. That gives them the perspective to make sure the building turns out as per the intent.
Yes, and I would like to say we love to work with project managers who are an architect's project manager. It's like you have certain contractors who are an architect's contractor. They understand what we're all dreaming, imagining, and trying to do. And other than having the tag of being the designer, architect, and manager, if they work together as a team, that spirit, that project always stands out.
Great. Please, sir.
Hi, thank you, Shyam, and thank you, Zak World, for inviting me. And I will start up from where Sir has stopped upon that. Yes, architects are very important for managing the project. At Gulshan, you know, in terms of selecting the facade sections, we always keep in mind the standards which are available across all the brands, so that we are not stuck up for any kind of delivery in past half a decade, the time of COVID and time of tying things when the supplies have a challenge. We try to conceptualize and have that thing in the mind at initiation stage, as well as, you know, at the time of execution. I feel the most important way of communicating with the execution team are the drawings, and we at Gulshan always try to focus on, you know, taking comments on all the stakeholders on the shop drawings. I think Mr. Chaube was there presenting. He has been our facade consultant. We have spent at least 3-4 months time before finalizing the tenders, and that really gives us a lot of strength. Apart from that, at Gulshan, we have also kept third-party property check, prop check for even checking all the strengths of door windows as well as the finishing, which really gives us benchmarking in terms of quality, as in terms of residential as well as in commercials as well.
Stuart.
I think this headphones hopefully working. So yes, thank you, Zak, and the sponsors for inviting me here, and thank you everyone for staying. I know it's been a long day for everyone, so thank you for being here. They've saved the best to last. When it comes to project management, I think the definition of project management, it means many things to many people in a construction project and in the delivery of that project. My view is that we tend to see project managers as a different entity or a separate part of the supply chain and the design chain and the client, but really the project manager can be any one of those entities, whether it's the architect, whether it's the owner, whether it's the contractor. I think the important thing is, from a project management perspective, that everyone works collaboratively and together, and you create that team, whoever the project manager is. And the project management is essentially setting up the processes, the procedures, the organization, the communication to allow projects to succeed. And that then needs the collaboration of the team, and it also needs the discipline to ensure that the cost, the time, the quality is then maintained throughout the project. And I think we get hung up on project management companies, or who's a project manager, or who's in charge, and people get hung up by different roles, where ultimately that project management is an onus on the whole team to work together to deliver. You know, and we have to get in early. The project management has to be set up early. Time, cost, and quality, which drive all our projects, is set up through good project management. There's no getting away from it. Project management and good project management is essential for a good delivery and a quality delivery of a project. Setting up, we all know in facade, there's multiple elements of mock-ups, visual mock-ups, performance mock-ups, testing, material selection, the shop drawings, getting contractors on board early, making the right decisions early in the design process. We've heard today about sustainability and making those decisions early. I think the project management goes right from the start. As you said, it has to be in there early, and it has to continue all the way through to the end on the quality and the installation to make sure that everything is maintained all the way through. So project management, to me, to answer the question, the definition of project management is the control of the organization, the system, the processes, and the delivery to manage that time, cost, and quality. But it's an onus on all of us to be project managers, to be collaborative, to be positive, and to work together to deliver what we all want to do, is deliver fantastic projects.
Hello. Yeah. Hi. Thank you, Shyam. And I completely agree with what my friend said, that it's a collaborative approach. Often people feel that project management, when they conceive a project, they can manage it very well. But I believe it's a very specialized job, and we have to depend upon the specialist to handle that part. It involves a lot of deliberation in the beginning, but setting up right processes, doing and giving a right training and the guidance to the team, and then establishing right checks and balances in the process to ensure that what has been conceived has been delivered. So project management is end to end. I mean, knowingly or unknowingly, when you start a project management starts by itself. Only difference is some people think that they can do it themselves, but some people do it in a more structured way, more organized way through a professional team. So that's something I believe should be there as a part of our thought process, as a part of our DNAs, to get better results, to get better infrastructure projects, and to have less of risk and uncertainty and surprises.
Audible?
I'm not sure. Can you hear it?
Is it audible?
Yeah.
Yeah, all right. So I can see not all of you have gone to sleep. Thank you so much for that. Thanks for the question, Jam. I think all of them have covered all the points basically. There's nothing left for me to say. Let me just add to whatever has already been said. So the link between the intent, somebody's dream, and somebody's money, and somebody's resources to the final product, there is a common link and there's a common chain. And this chain, I think you can call this devil as the project manager. He is the one who should be able to conduct from the design intent to the detailing of it, to putting into place the people, the resources, managing the timelines. This is the outline of it. Outside the boundary, there are many operating areas which come into play in our scenario. When there is a failure at some point, just for example, I'm saying that if there is a detailing failure, or if there is a failure with a contractor is not able to do something, if there is a problem in the method, or if there is a required change in material or in design, this is also area where the project manager needs to pitch in. How he would pitch in? He would use the resources, that is the architect, the detailer, or alternative materials and all these. So he is working inside the box as well as needs to keep his mind open so that outside the box also he is able to pull in resources and get everything done. This is my opinion. And this is where I say that a good project manager is a person who will be invisible in a project, as in to say that when a project manager is not functioning, everybody else has to pick up those points and function themselves. And a good project manager will put everything into place in such a way that it will function very smoothly and it will go through very well. This is my opinion. I mean, I think that the topic is actually so big that we could have a discussion for an entire day and it would not get over. But then,
no, that's a very fair point. And I think if I go through what the panel has said, there are topics of starting early, capturing the intent. I think what both of you mentioned. And I think from there, I think what all of you mentioned, controlling and defining the processes, and a good project manager makes sure that they are invisible and the project runs. It's like a toothache. Once you know you have teeth, that means you have a problem. So maybe a project manager is like a tooth. As long as you don't feel the tooth, everything is going fine. And I think there are many topics. You mentioned cost, quality, and time. Before we boil the ocean, I thought maybe we can pick one of these topics and dive into and understand one of those dimensions to start with. And all of you mentioned in one way or the other shop drawings. The importance of shop drawings in realizing the intent and realizing what the dream of the investor was and controlling the quality of execution. So I wanted to understand from your perspective, what are some best practices you have seen, an example of a project where what you intended was actually delivered, and maybe what methods were used, what worked, what technology was used, what worked, so that people sitting in the industry can say, hey, this is the way to work from the broad experiences. So I leave that open, whoever wants to start on that aspect of converting intent to quality to execution, shop drawing. What are tools and methods you have seen in your experience?
Okay, I'll kick off. I mean, I think the biggest key to success when it comes to facade, especially when it comes to shop drawings, from my perspective, early contractor involvement. We tend to wait a lot of time to get the contractors involved and to get the supply chain involved when it's the supply chain that are doing all the engineering and all the final detailing. And the shop drawings need to come in early. And I think we tend to wait too long to get that moving, and then the timelines are squeezed, and that ultimately impacts your quality, it impacts your decision making, it impacts your cost ultimately. So the first part of the process for me is that early contractor involvement, as early as we can, especially as we move now more to modularization and to sustainability practices. And you've really got to engage with the supply chain early and secure that supply chain early to allow the shop drawings to come in. Another aspect from a quality perspective that I'm seeing, we talked about BIM earlier on in the discussions in the day. I worked in a project in the UK where we actually took the as-built information from the building, the superstructure that we constructed, fed that back into the BIM model to allow the detailing to be done on an as-built structure, instead of waiting to stand up there and realize that your concrete's poured in the wrong place or a ledge is too short or things like that. So I think that's, again, a very good way of
so the civil
using that
contractor
management.
Delivered an as-built.
You take the as-built of what you've actually built there and then feed that back into the construction federated model, and then use that to maybe finesse some of your details and work out what your bolts need to be and your fixings need to be. So I think that's two practices for me, are early contractor involvement and utilizing the technology as much as we can on a real-time basis to help us deliver.
Yeah, I think that's a valid point. I mean, using the supply chain at an early stage would definitely eliminates a lot of doubts from your mind. So you actually design something which is practically possible, and you mitigate the chances of surprises at the later stage. And second to that, you also have to try and do, sometimes when you're evolving or designing something new which has not been done conventionally, you probably have to start doing some mock-ups for that. Do some samplings, do hit and trials, take opinions from the experts, so that before you raise the curtain, you open it for everybody, you have done all the permutation combinations, and you finally landed with the right product.
I agree to what you said, and I do point out to you, Sham, that you and me also have been involved very recently. Shop drawings go up to a certain point, and beyond that, when it came to a requirement, we didn't have any shop drawings for that particular component, and we walked together, we developed that component. So it comes back to the point that he mentioned, that bringing the supply chain early on. So we had this conversation very early on. when I wanted the particular component that was to cater for the bulletproof glass.
There is also one more thing that, even after the shop drawings are approved and, things are there, even after, before the finishing, in Indian conditions, whatever we say, there are always some rush of finishing, and at times before the finishing, the stakeholders are, not kept in loop, and it's all only between the client and the contractor. Even at times, we being an in-house architect also have to take a call instantly. I feel that culture itself in our industry has to be eradicated, and all the stakeholders need to be there till the last last finishing stage. We always keep whosoever is consultants, and when our finishing things are done, so that we can take a nod, and even a certifications from all the consultants that it's all safe and as per their designs, which I guess is less in terms of in our culture, but we in over the course of time, I think that is very much required, and from this forum we can at least have that word so that it spreads very wide.
Well, as an architect, we face different kind of challenges. There are projects where there are no shop drawings, and you can't say, I'm not going to build this project, or I'm not going to go further with it. We have some projects which have facade consultants like Lalit, but there are many which don't. So as a design practice, we had to do a lot of detailing on facades when we didn't have all of this support. Now, of course, it's different. So we, as a group, we had no choice, but you had to virtually do very detailed level of skin sections details, which actually brings out true quality. And now with good specialists, I often find architects aren't detailing enough. That design intent is not expressed well in those drawings. If those drawings are done well, the shop drawings always will come well. And you do have the challenges. There are many projects in different parts where you don't get the benefit of quality drawings, or many a times the working drawings that you give the same come back as shop drawings with a little bit more information. So I think shop drawings are very important, but very often design teams don't draw enough.
Enough detail at the beginning.
It's not just true in India, it's all over. Many times I see international drawings where the quality of drawings issued by architects is so preliminary and basic, and you think the contractor would come and do wonders. I think he's expecting too much. So,
I think that's a very good point, because the project management aspect of that is very important, that the project manager needs to set that level of expectation between the consultants and the contractors, because it can be very different expectations between what's coming from an architect at a design intent level. It's evolved over the years that I've worked as well. You used to get very, very detailed drawings from an architect. Now you get very limited drawings from an architect. That's pressures of fees. There's many reasons why that's happened, but a lot of it's getting pushed onto the contractors now, but the contractors don't want to take that, or they want more intent. And it's very, very important role of the project management team to set that level of expectation so that you don't end up with this big gap that never gets satisfactorily completed. And then everyone's then arguing, fighting. That's a very important role of the project management team, I believe.
And so if I can summarize the key points, I think one really interesting point was this culture of involving the key stakeholders at the beginning, also at the end, so that the loop is closed. Another aspect you mentioned was early involvement of the supply chain, so that when the shit hits the roof, you have people committed and involved to solve your problems. And I think what you mentioned, the detailing done early helps at the end. So the more details that come in, and involving the project manager to bridge that gap and make sure that gap is always ensured, helps that topic out. And the last topic which I wanted to build on for the next question, which was very interesting, is there's always an unknown, and a visual mock-up or a mock-up of some kind really helps. Or the last-minute firefight, how do we solve the problem in a systematic way when you're stuck, your back is against the wall. So seems like a lot of topics. And from a technology perspective, I think if we have time, we'll dive into that as well. I see the clock putting pressure on us. And that was really interesting. I don't know how much of that happens in India. The as-built model being used by the next team. And I think if that cycle, I've seen a couple of projects doing that. If that cycle runs, then I think knowledge is captured and transferred down the chain without getting lost.
Yeah, the technology can be used. I mean, the BIM modeling is untapped in a lot of countries in the UK, the Middle East. You hear all these stories of BIM modeling, but it's really yet to completely take off and be embraced in a lot of places. Still a lot of ideas, but I've worked on projects where you try to build in the digital environment. So you're building right down to the nuts and bolts and getting that, again, the supply chain involvement in there, because they've got to give you the sizes of those nuts and bolts. But you can actually try and build it in the digital world and but instead of standing on site looking at a problem, you've already solved it in the model. But again, it needs quite far-sighted teams to get that involved early and to really get that level of detail. Yeah.
One more thing, Shyam, I guess, having all the stakeholders from the first and the end is like a culture or maybe a benchmarking which can be done from various developers and all. But if we really want to have something good for the industry, then I feel that should come up from the authorities, because I remember in the past when Gift City was formalized, they gave us the mandate of keeping the facade consultant on board from day one. Even the BIM model also incorporated the facades, and that was a part of sanction drawings. So, I think when the government itself or maybe the authorities or the sanctioning authorities brought it as a mandate, then it would really bring up the culture. And though there are best practices in the industry, which many of us are doing, and that would really bring up this benchmarking.
Cool. So I think in the time we have left, I'm going to pick on this topic of the visual mock-up, how to deal with the unknown unknowns. And there are many things that architects, I worked with, not yet, but also when I work with architects, you do come up with, hey, is this possible? Right? Why can't this be possible? Hey, Shyam, there are these 5 materials I want to bring into one junction. Or investors, I've dealt with Gulshan and I know how you think. It's, hey, this is what we want to do. Why can't we do this? And now we try to do something with, I think you make us live at the edge. Same thing when you do projects. So all of you, I think one way or the other, push us to the edge. There are a lot of unknowns you drive. And now, in order to do the visual mock-up, and if I may speak on behalf of the industry here, how do we match your intent and create a mock-up to the standard without A, getting the job, and B, the level of precision you need without having anything in hand? What are some of the things you have done? Because there's this digital world which you don't believe, and the mock-up which is not really perfect. And you have to then take a leap of faith. Any thoughts on that, how you make your dreams come true?
Well, in the hospitality industry, we pay for the mock-up, always. And so before the building thing comes up, you have a little package where the mock-up room happens and the room comes up with a facade. Sometimes it's done off-site, sometimes on-site. But you can't expect somebody to put up that cost, that time and effort without having the project in hand. By the time you get the project in hand, it's very late. It's very late. So the best way to go about, and that's what we encourage, is to have a special package for a mock-up room. It's paid. That contractor may not get the main job, but then obviously he has he's the front runner if that mock-up comes up well. On large building facades, we often find the mock-up comes too late. And there's always the issue that the site can't take it. And We try and do a lot of off-site mock-ups. But that's the only way to go about it. And I think without that, you don't get that, because in a typical large building facade, you'll have 4 or 5 conditions which are being repeated around. And if you get hold of them, you know 80% of your building envelope is well in control. It's only those special ones which you may do, which you need to work harder. But at least you know 80% is
on the way.
Very well said. Mock-ups are something that, we keep on evolving. I think once the designs are freezed and everyone is on board, having a mock-up at a right initial stage, but when the complete designs are freezed, the shop drawings are being standardized, signed off, that's the right stage. And to be very honest, yes, it has to be paid, which sir has absolutely right said.
I wanted to add over here. So when we do the mock-up, there are 3 sides to this. One is the owner of the building and the person who's going to occupy. He needs to understand visually where he is going, his intent is being met or not. And the architect has created a dream, so the architect needs to see. But think of it from, I come from that side. So the fabricator is able to execute each and every detail. Is it workable? Is it something that he'll be able to scale up, repeat and do? Or does he want a modification? So mock-up is an absolute necessity. So the necessity is there. Now what you spoke about involves commercials. So you are perplexed about this. Yes, an answer has to be sought, and it cannot be a single answer answering everybody. Every industry you'll have to find, maybe invent different answers. So we are on the topic of project managers. Probably we can take help from them. But it's a necessity. We need to do it. And at the end of it, we understand whether we can execute it the same way or not. Right? So that is a necessity. Now, what remains is the commercial issue.
It has to be paid.
We need to take it up with the project managers. The project managers should be able to help us better.
And already I think there is some insight here. Early involvement of the supply chain, do a paid package thought through mock-up. I think that gains clarity on the execution repeatability, allows then scalable high-speed movement, use of technology gets easier. So I think I can see really the single digits popping up. I'm really going to take this away from the team, the panel on the ground. I think this culture of end-to-end, whoever was there at the beginning, sign off at the end. I think that's something I will take to heart even to my team. I think the second, what we all said, involving the supply chain early, and they understand and are behind you on the intent of the building. I think the third thing on this entire topic of the mock-up to shop drawing, because the shop drawing is the execution at the ground, but doing the mock-up to verify that the execution is feasible. I think the use of technology to make information seamless. And really at the end of the day, I think what you said, the project manager at the end of the day has to build a team so that the whole project, he becomes or she becomes invisible and the building comes up smooth. So I think that's probably the story of the bell. I must compliment the project manager who's running this show. So I want to give a big thank you to the panel for this short but deep insight that we can take out.
And with that, thank you so much for being here and being an amazingly patient audience despite our delays. And big thanks to the Zak team, and I think they all deserve a real applause for making this happen. Thank you.